Hello all, welcome to this session. In this session, I am going to answer software testing interview question 51. That is, what is vulnerability testing? Let me answer. As part of security testing, we perform or test vulnerability assessment and penetration testing. So vulnerability assessment is one of the testing types that we perform as part of the security testing. It's also known as vulnerability testing. So let me explain what exactly is this vulnerability assessment and how it is part of the security testing at a high level. Okay. So first of all, what is security testing? As I already explained about security testing in the previous sessions of this interview questions series. Okay. So what exactly is security testing? Okay. Security testing is all about identifying the, okay, it's all about identifying the security loopholes. Okay. Security loopholes in the application. What will happen if an application is having a security loophole and if it is not identified by the software tester? Okay, if security testing is not performed in application and if it is not performed, security loopholes in the application will not be identified before the software is released into the market, right? Before the software got released into the market, if you have not identified the security loopholes, what is the root? What will happen? What is the consequence? Hackers. The problem is with the hackers, guys. Okay, hackers, what they will do? They will try to exploit this security loophole. Okay, hackers will identify the security loophole and they will take advantage. Exploit means they will take advantage of this security loophole. Okay, so to avoid that, we generally perform security testing. Okay, where we are going to identify the security loopholes in the application or software before the software get released into the market, and we have to fix the security loophole before releasing the software into the market after identifying. And the process of checking or identifying whether there are any security loopholes in the software before releasing the software into the market, okay, is known as security testing in simple words. And this security testing can be performed as two types. What is that? Vulnerability assessment. As part of security testing, we perform one thing is vulnerability assessment. Vulnerability assessment, which is nothing but vulnerability testing, simple words. Okay. So generally people call that as vulnerability assessment. We can also name it as vulnerability testing for now. Okay. And on the other side, as part of secure testing, apart from vulnerability assessment, we have to perform penetration testing. Okay. We have to perform penetration testing. So what is vulnerability assessment? What is penetration testing? I'm going to explain now. Okay. So if I explain both this vulnerability assessment and penetration testing for you, you'll understand the vulnerability assessment better. So here guys, I'll take an example and explain vulnerability assessment. So what I will do is I'll take an sample application, test PHP dot vul web. Okay, this is application guys. So I'll search for that. I got this. Okay, you see test PHP vulnerable web. Okay, vul web. So this is a website, and this website is open for practicing the secure testing guys. I'm going to give a disclaimer here saying that you cannot perform. Okay, you cannot perform security testing randomly on any application that is available in the market. Okay, you will be treated as a hacker guys, and it is illegal. Okay, it's illegal to perform security testing on the random applications. Okay, if you don't have permissions, okay, from the application owners, you should not be performing the security testing randomly on any applications on the web. So here, this application is a sample application where you can perform security, where you can practice security testing. Okay, there's no problem in. There are some practice websites where you can practice the security testing. This is one of the website which comes into that category where you can practice the security testing on this website. Fine. Okay, you see they clearly mentioned you can use it to test other tools and your manual hacking skills as well. Okay, that means you can practice here. Okay, they are okay. This application is open to practice security testing, but you should not perform security testing on all random applications. That's a very important disclaimer, guys. I'm giving in as part of this session. Anyhow, so here, guys, I will show you how to perform vulnerability assessment. Okay, practically I will show you what how to perform vulnerability assessment. Okay, so here after going to this application, guys, I will go to this category that is browse artist, or click on the artist here. Either click on artist or browse artist. You'll go to this page. I'll select the first artist. Okay. There are three artists here displayed. I'll go to the first artist. Click on the first artist. Artist one came here. You see the URL what came? Artist is equal to one came. Details about the artist one came. So what I will do here this time is here instead of providing one, I will provide single quote here. Okay. Here one is the input case. Okay. Whatever the one you selected is the input in the URL. So instead of giving artist is equal to one, that is the first artist, I'm just giving single quote. So what is the single quote, guys? Single quote is nothing but the payload. We call the single quote here as a It is nothing but a payload, guys. Okay, it's nothing but a payload. Okay, so hackers will use this kind of payloads actually. Even security testers also have to use a payload with a good intention to identify the security loopholes in the application in advance. So guys, when I give one here, it will work fine. It will get me the artist one details. But if in place of the one, if I give single code, which is a payload that hackers may use, okay. If I press enter, what's happening, guys? You're getting a warning message. From where you are getting this warning message? You're getting a warning message from the database. If such kind of warning messages are coming from the database instead of from the application, it doesn't look like a normal application message, right? Okay, it some kind of thing is going wrong in the database. Okay, it sense, we can sense that when you give single code and press enter, and if you're getting this kind of warning message saying from the database, if you're getting like at line 62, you see at this PHP file, okay, something happened, it is saying means, that means there is a problem with the database. Okay, this application is prone to SQL injection. Okay, this application is prone to what? SQL injection. So you performed vulnerability assessment, you didn't exploit the application. Okay, you didn't take advantage of the application here. By providing this single code payload, you identified that this application is prone to SQL injection. That's it. You are not taking advantage of the problem. You are only identifying the problem in the application. That's what is vulnerability assessment. But in case of penetration testing, what will happen is, here, let's say, I'll go to another application, demo.testfy.net. I'll go to sign in. Here, I got to know that this particular login functionality of this application is prone to SQL injection. Then after figuring it out, what I'm doing is I'm entering another payload. Okay, the next level payload. This is the first level payload that I'm using as part of vulnerability assessment, just to detect whether the application is prone to SQL injection or not, whether I can do further testing, penetration testing or not. I'm checking here. That is vulnerability assessment. And coming to the penetration testing, guys, I'll give another payload here. So one of the payload I can give here is this kind of payload. Okay, like this I can give single quote R like this. Okay, this is our payload. Single quote R 1 is equal to 1 hyphen hyphen. Okay, this kind of payload, next level payload. This is a very simple payload which will only detect any problems in the application as part of security loopholes are in the application. It will detect, but it will not take advantage. This particular payload will not take an advantage of the consequence. Okay, the action or result. So but in penetration testing, as part of penetration testing, we use an advanced kind of payload like this. Okay, after identifying that the application is prone to this kind of injection, SQL injection and all, then the next level payload we are going to give like a single quote R1 is equal to 1 hyphen hyphen, like this payload will give here, and we'll give some random password and click on login. You see, I'm taking advantage here. Okay, in the first one, as part of vulnerability assessment, I didn't take any advantage of the payload. Okay, so it was just detecting that there is a problem with the application as part of SQL injection, security loophole is available in the application, it mentioned. But in penetration testing, by providing advanced payload, I'm utilizing it. You see, I'm able to get the access of the admin user. I'm penetrating into the application. As a hacker, I'm penetrating here. Okay, penetrating as an hacker. In vulnerability assessment, only detection, only identifying, but we are not penetrating. As a hacker, we are not penetrating, we are only detecting. But in penetration testing, we are penetrating as a hacker, right? As a hacker, we are penetrating into we are taking advantage here, taking advantage as a hacker. Okay, what the hacker will do when he gets access to this application, everything I'll do, guys. Okay, I'll transfer the funds and all those stuff. Okay, and that is what is penetration testing. Okay, so hope guys you got the understanding, right? What is vulnerability assessment? Vulnerability assessment is only about using simple payloads for detecting if there are any security loopholes in that application without taking advantage of the security loopholes. Whereas in penetration testing, we'll behave like a hacker. Okay, we will intentionally behave like a hacker and see the consequences, like what if the hacker is able to do this, what the hacker will do after right, penetrating into the application with this kind of advanced payloads and all, what the hacker can do. Okay, what can be possible by the hacker, all these things we'll explore here and do that as a simulate. We'll simulate ourselves as a hacker on the application. That is penetration testing. So in real time, do we have to perform vulnerability assessment or penetration testing? It depends, guys. The answer is it depends. Okay, it depends on the client. If the client has given the permission for you to perform penetration testing, then only you will perform penetration testing on the top of the vulnerability assessment. Otherwise, you will only perform vulnerability assessment, you will not perform penetration testing. Penetration testing requires additional, okay, additional permissions from the client. Okay, so if you got a project as part of security testing and the client is explicitly not mentioning whether you can do penetration testing or not, generally we'll do vulnerability assessment. Generally, we have to do vulnerability assessment first and detect the security loopholes in the application. Then we have to take permission. Okay, we have to ask the client, guys. Okay, we have to ask the client to give extra permissions to perform penetration testing. So as part of penetration testing, the problems that will happen is the database will go down. Okay, database will go down and the data inside the application may get corrupt. Okay, if the client is maintaining sensitive information in the that particular database of the application, that will be a problem, right? That's why extra permissions or extra, okay, extra permissions we need to ask from the client before we perform penetration testing, so that client will arrange you a replica of the application. Okay, even though that application goes down, doesn't matter for the client. Such kind of application the client has to provide. Then we can perform penetration testing. So better to ask client for the extra permissions to and mention them in advance that we are going to do penetration testing, which will take down your database and will correct the data in the database. Make sure we have the backup of the database. Okay, like that we have to say to the client. Just it's a duty, right? It's a kind of responsibility to inform client that okay. So it's like something, guys. Okay, let me give one more example, a real world example for vulnerability testing. Okay, so here, guys, let's say you are testing a car. Okay, let's say you are testing a car and you are testing a car and you have so much of expertise that before crashing it, whether the airbags are opening or not, you have to check. Okay, or something like that. For example, you are testing, okay, car whether airbags will open or not. So for that, you may simulate in a simple way that you know, right, without crashing this car with some object, you can check that. Okay, there may be some way. So that is like identifying the problem here without actually taking advantage of that, right? But here, other case, as part of penetration testing, we are really crashing the car, guys. Okay, against a wall or something. Okay, against a car wall or something, we are actually crashing the car. What will happen if you in case you are crashing the car? What will happen? The car will get damaged, right? Car will get damaged and airbags may or may not open. That doesn't that's out of context for now. But you see, in this case, we are simply detecting the problem and telling in advance that okay, if this car crashes, okay, then airbags are not will not open in this case. Okay, they may mention. But here you have to crash the car to explain that. That's what is the difference between vulnerability assessment, guys. In vulnerability assessment, we are simply detecting the problem, security loophole in the application without taking advantage of that. In penetration testing, we are actually doing it. We are simulating ourselves as a hackers and taking advantage using the advanced payloads and showing the client that okay, what all hacker can do on your application. Okay, that is what is penetration testing. So hope, guys, you got the answer for what is vulnerability testing now and how it is different from the penetration testing. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 52. That is, what is black box testing? Let me answer. Black box testing is a testing performed using the visual functionality of the software application without looking into its internal code implementation. So what does it mean? While performing black box testing, we are performing the testing of a software application by using its visual appearing functionality. Okay, and we cannot see the code written by the developers for developing that software application. Okay, while performing the black box testing, we cannot see the code that is written by the developers for developing that software application. Only by using the visual appearing functionality of the software, we are performing testing. That is called as black box testing in simple terms. And here I have given a diagram, guys, as you can see, just to make your understanding why we are calling that as a black box. Okay, why we are naming that as a black box. So this is a image or diagram, whatever you can say. You see there in middle there is a box, okay, which is in which color? Black color. Okay, inside this black color box, the code that is written by the developers for developing this application functionality is written. That code is not visible to you. Okay, you are testing this black box. Okay, you are testing this black box. You see here you are providing some inputs and you are getting some output. This is the process of testing. You are testing this black box which contains the code, but that code is not visible to you. Okay, if a box is in black color, can you see what is there inside the box? No, right? The code is inside the box, guys. Okay, the code that is written by the developers for developing the application functionality is inside the black box. And but when you are performing this testing, that is black box testing, You cannot see what is there inside the box. Okay, that's why it is called as black box testing. Okay, that's why it is called as black box testing. Only by looking at the visual appearing functionality of the software, we are performing testing without having any knowledge or access to the internal implemented code that is written by the developers. Okay, we don't have access to that. This is called as black box testing. There are some other names for the black box testing, guys. You can also call the black box testing as specification based testing. Why we call black box testing as a specification? Specifications means requirements, guys, client specified requirements. Okay, specifications are in simple terms are known as client specified requirements. Based on the requirements, you will be performing the testing. For example, I'll show you here. You'll open this application. Okay, I'll open an e-commerce application, a sample e-commerce application. If I ask you to perform testing of this, whether the functionality of the software is working fine or not, what you will do, you will use the visual appearing functionalities of this application. You can see the search box. It's visually appearing. You can see the search button. And here, if I type HP, if I type HP and click on the search button, and in the search results, if I'm getting the HP product, that means the test is passed. But how I'm testing here? How I'm testing here? I'm only testing with the help of the visual appearing functionality of this application software. I cannot see the code that is written by the developers for building this or developing this application functionality or behavior. Okay, so that's why it is called as black box testing, and also it is called as specification based testing. Based on the client specifications, I am performing the testing, guys. Okay, the client has given me the requirements where the user should be able to search for a product and he should get the product in the search results. Okay, I'm testing that with the help of the visual appearing functionality of the software. I'm testing this. That's why it's called as specification based testing. Okay, based on the requirements, I'm performing the testing. I'm not worried about what the developers have written the code for. Okay, for developing the software, I'm not worried about that. You can also call it as a behavioral testing, guys. Okay, you can also call that as, you can also call the black box testing as behavioral testing. Why behavioral? It's not only about the client specified requirements, guys. When you are performing black box testing, it's not only about the client specified, whether the application functionality is working according to the client specified requirements is one thing. Other thing is whether the software that you are building is according to the user needs and expectations or not. It's behaving according to the user needs and expectations. That's why it is also called as behavioral testing. Okay, using the black box testing, we can test based on the requirements, okay, given by the client, whether the application functionality is working or not. And also it should behave like the end user. Okay, after you release the software into the market, who is going to use? The end user or customer is going to use. Okay, so application is behaving properly according to the end user's needs and expectations or not. Okay, that also we test as part of black box testing. That's why it is also called as behavioral testing. Okay, and on the top of that, we can also call it as closed box testing. Okay, so what is closed box testing, guys? When you say closed box, guys, when you say closed box, here we represented as a black box. Okay, so why it is also called as closed box means, you see, when a box is closed, can you access some item inside the box? No, right? Okay, so let's assume that there is a box which is in a closed state, and inside the box, our application code is there. Okay, we cannot open the box, right? You have to test the software without accessing or viewing the internal implemented code of the application. That's what we call as black box. You can also call this closed box, because in a closed box you cannot access, right? The code that is written for developing the software you cannot access. So they gave the name as closed box testing also for black box testing. Okay, these are the different names of the black box testing, guys. And what are the different testing types in the levels of software testing? I have explained about software testing levels, right? There are 4 levels of software testing, like unit testing, integration testing, system testing, and acceptance. These are the 4 levels of software testing. In those 4 levels of software testing, okay, which levels of software testing falls into the black box testing? So system testing and acceptance testing will fall into the black box testing category. Okay, how we perform the system testing? Generally, the software testers will perform the system testing where they will test the entire application as a whole by cross-checking according to the client-specified requirements. We'll perform testing as a whole. Will perform testing, and while performing the system testing will not have the access to the code that is developed by the developers for building the application. Okay, or we cannot view the code that is written by the developers for building the application. Okay, so that's what is system testing. Acceptance testing, we have the alpha testing, beta testing, right? So all this kind of testings will fall into the black box testing category. Here beta testing will be done by the end users, okay, limited number of end users, where the alpha testing will be done by the internal team of the company, along with the support of the developers and testers. At the developer side, they will be doing that. All this kind of testings, you see, we'll be testing the applications as a whole. Here system testing will be performed with an intention of checking according to the client specified requirements the developers have developed or not. Acceptance testing is done to see whether the software is meeting the end user's needs and expectations or not. Okay. In the business point of view, we'll perform acceptance testing. In both the cases, guys, they are black box testing because we don't access or view the code while performing the system testing or acceptance testing. Hence, they are these two levels of software testing out of 4 levels fall into the black box testing category. Opposite of the black box testing is white box testing. Okay, the opposite of the black box testing is a white box testing, guys. It's clear cut opposite, guys, for the black box testing, because here in case of white box testing, testing is performed when the okay testing while testing is performed, we can see the code, guys. Okay, code can be visible or accessible while performing the white box testing, which is an opposite of black box testing. But who will perform this kind of white box testing where code is visible or accessible? Developers will do that white box testing. Okay, developers will do this kind of white box testing. For developers, the code is visible and accessible while performing the testing. Okay, so in software testing levels, okay, there are 4 levels, right? In that, unit testing, integration testing, system testing, accept. I already told you that system testing and acceptance testing will fall into the black box. So the remaining two, that is unit testing and integration testing, will fall into the white box. Okay, while developers performing this unit testing and integration testing, they can access or view the code, guys. Okay, that's why these 2 levels of testing will fall into the white box testing category. So hope, guys, you got the answer for what is black box testing in this session. So that's all for this session, guys. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 53. That is, what is white box testing? Let me answer. White box testing is a method of software testing which tests the code and internal program structure of the software application. That means while performing white box testing, we perform testing with the help of the code that is developed by the developers for building the software application. With the help of the code of the software, we are going to perform testing. That is called as white box testing. Here, we can look into the code while performing testing. Also, we can access the code while performing the software testing. That's what is called as a white box testing. So how does a white box testing look like in the diagram? Let me show you a diagram here. You see, there is a white box here. Okay, you are performing the testing on a white box. White box means you can see what is there inside the box, right? So in black box, there used to be a black box that you cannot see anything inside a black box. If some box is coated with black color, you cannot see anything inside the box, right? But unlike black box, this is a white box. So everything that is placed inside a box is visible outside the box. Okay. So here in this case, application code that is put inside the box is visible in case of white box, and we are testing such kind of white box. That's why we called it as white box testing. Okay, by looking into the code, by accessing the code, and with the help of the code, we are going to perform testing in case of the white box testing, guys. Okay, so fine. So who will perform the white box testing in real time? Who will perform the white box testing in real time? Developers are going to perform the white box testing in real time, guys. Okay, developers who can view and access the code are going to perform the white box testing. So there are other names provided for this white box testing. Okay, white box testing is also known as clear box. That means the code inside the box is visible. In case of clear box means transparent kind of box. That's why the name is again not only clear box. You can also call the white box as transparent box testing. Okay, white box testing also known as clear box, transparent box, because whatever you put inside a clear box or transparent box or white box, you can see out from outside the box. That is, code is visible outside the box. That is outside the software. Glass box, same again, right? Clear box, transparent box, white box, glass box. Okay, visible. Last one is structural, means code, guys. Okay, structure means code, guys. Structure means code. So structural testing means we are performing white box testing. Why? By looking into the code, by accessing the code, and with the help of the code. That's why we can call that white box testing as structural testing also. These are the different names for the white box testing, guys. Clear box testing, transparent box testing, glass box testing, and structural testing. So coming to the software testing levels, there are 4 levels of software testing, guys. Unit testing, integration testing, system testing, and acceptance testing. In that, the first 2 levels of software testing, that is unit testing and integration testing. Okay, while performing the unit testing and integration testing, who will generally perform the unit testing and integration testing in real time? Developers. And developers, while performing this unit testing and integration testing, they can look into the code, they can access the code, and they can perform the testing with the help of the code itself. That's why unit testing and integration testing levels of software testing fall into the white box testing category, while other 2 levels fall into the, that is system testing and acceptance testing, fall into the opposite of the white box testing, that is black box. Okay, what is the opposite of the white box testing? Black box testing, guys. So here in black box testing, we perform testing with the visual appearing functionality of the software application. In case of black box testing, we cannot look into the code that is developed by the developers for building the application, or we cannot access the code also. Okay. In case of black box, in white box, that is possible. We can look into the code, we can access the code. With the help of the code only, we are performing testing. But in black box, we only see the visual appearing functionality of the software. And when you use that functionalities, visual function appearing functionalities of the software, the code is going to run in the background, but you will not have the access, or you cannot view the code that is written for building such kind of visual functionalities. Okay, with the help of that visual functionalities only, you are performing testing in case of black box testing, which is an opposite of the white box testing. As you already mentioned, the other two levels of software testing, that is system testing and acceptance testing, will fall into the black box testing, while unit testing and integration testing, which are generally done by developers by viewing the code and accessing the code and with the help of the code, will fall into the white box testing. So hope guys you got an idea what exactly is white box testing, and hoping that you will be able to answer this particular question without any problem in the interviews. Okay. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 54. That is, what is gray box testing? Let me answer. Gray box testing is the combination of black box testing and white box testing. As you can see in this diagram, gray box testing is nothing but black box testing plus white box testing, which becomes a gray box testing. But what exactly is this gray box testing? To understand what exactly is gray box testing, first we have to understand what is white box testing. Then we have to understand what is black box testing. Then you can understand what exactly is gray box testing. So let me first explain what is white box testing. In case of white box testing, a person who is performing this white box testing knows the internal code implementation in a full manner. Okay, the complete code that is used for developing the software will be known to the person who is performing the white box testing. That is white box testing, guys. Okay. What about black box testing? In black box testing, the person who is performing the black box testing doesn't know anything about the code that is used for developing the software. Instead, this particular person who is performing the black box testing will depend on the visual appearing functionalities of the software to perform testing. It doesn't know anything about the internal implementation of the code for developing the software. That is black box. Here, fully known in case of white box, the internal implementation code is fully known in case of white box testing, whereas completely unknown in case of black box testing. Okay, internal implementation code is completely unknown in case of black box, but in gray box it is partially known. Here fully known, here is completely unknown, here partially known, guys. You know it partially. Okay, the code that has been used for developing the software is partially known. It's not completely known or entirely known, but it's partially known. Okay, the one who is performing the gray box testing will has some knowledge, okay, has some high level knowledge of what code has been written for developing the software, but he or she doesn't have the entire knowledge, but a partial knowledge is there. So what is the advantage, guys? Okay, just to conclude, guys, in gray box testing method, the internal code structure of the application is partially known to the tester who is performing the gray box testing. Okay, it's here, it is partially known. So what is the advantage? Okay, what is advantage of the gray box testing over the black box testing? In case of black box testing, right, we only test the software by depending on the visual appearing functionalities of the software, right? So the one who is performing black box testing uh, will create some test cases in advance, right? He will not directly perform the testing, right? He or she has to create some test cases to perform the black box testing. But in case of gray box testing, the person who is performing the gray box testing has partial knowledge of the internal code implementation of the software. With that partial knowledge, this particular person will create even more better test cases than the black box. Okay, the one who is performing black box testing will create some test cases, guys, but the one who knows gray box testing, that is partial implementation of partially, the person knows the internal code implementation, that particular person can create even more better test cases, because internal logic implementation is also known in this case of the gray box testing. In gray box testing, as the tester has partial knowledge of the internal coding structure, he or she will design the better test cases, okay, for testing the visual appearing functionalities of the software. So here, what we are going to do with the help of this is, if you are doing the gray box testing, guys, with the knowledge of the partial, with the partial knowledge of the internal code implementation of the software, we will be able to create the better test cases for testing the software, okay, in a black box only we'll test. Okay. Here, with the knowledge that is coming by the partial implementation of the code in the white box, we are implementing in that black box. Okay, we are utilizing that particular knowledge for creating better test cases for testing the visual appearing functionalities of the software. Okay, with this partial knowledge of the code implementation, we are testing the visual appearing functionalities of the software in a better way by creating more better test cases. Okay, so here both are taking advantage of each other, right? White box test, partial knowledge of the code implementation is taking advantage of the black box testing. Okay, that becomes a gray box testing. Okay, so hope guys you got the answer for what is gray box testing and how it is useful and all. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 55. That is, what are the different levels of software testing? Let me answer. There are 4 levels in software testing. First level is unit testing. Followed by unit testing, we have integration testing. Followed by integration testing, we have system testing. And finally, followed by system testing, we have the acceptance testing. These are the 4 levels of software testing. Coming to the first level of software testing, that is unit testing. So in unit testing, individual units will be tested independently. Okay, so individual units will be tested independently, that is separately, one by one. Each and every unit will be separately tested. Who will be testing these individual units as part of unit testing? Developers will be testing this unit testing. Okay, will be performing this unit testing. And this unit testing will fall into the white box testing category, where while performing the unit testing, developers can see the code of these particular units that they are testing, and also they can access the code of these units. Okay, that's why here code is visible and accessible. So unit testing will fall into the white box testing category and is performed by the developers. And coming to the next level of software testing, that is integration testing, which comes after the unit testing. After the unit testing is performed, developers will perform the integration testing. So this also falls into the white box testing category. Okay, similar to unit testing, integration testing will also fall into the white box testing category, where code is visible and accessible. And who will be performing here also? Integration testing will be performed by the developers only. But what exactly is this integration testing? Here, the group of logical units, okay, a group of logically connectable units will be connected together and perform testing. Okay, logically they will group the units. Developers will logically group these units which are tested independently into a kind of group. Okay, so logical group, they will unite the units and then perform testing. Okay, so that's what is integration testing. And here in integration testing, we have several approaches, guys. Okay, there are several approaches that developers may follow. Okay, developers may follow different type of approaches for performing the integration testing. What are the different approaches that developers will perform to perform the integration testing? Developers may perform top-down approach, top-down integration testing approach, or they can perform bottom-up integration testing approach. They can perform sandwich integration testing approach. They can also perform the Big Bang integration testing approach. These are the different approaches that developers may follow to perform the integration testing, where the group of units which can be logically grouped together will be grouped and tested as a integration testing, okay, by developers. That's what is integration testing. Now, third level of software testing we have is a system testing. Here, guys, system testing will be performed by the software testers. Okay, till now unit testing, integration testing was done by the developers, right? But system testing will be done by the software testers, and this falls into the black box testing category. System testing will fall, unlike unit testing, integration testing, which fall into the white box testing category, but system testing will fall into the black box testing category. As part of system testing, software testers will test the entire application functionality as a whole. Okay, complete functionality of the software they will test as a whole. As a whole, they will perform testing, and while performing testing, they will test according to the client specified requirements. Okay, so while performing the entire application as a whole, okay, software testers, while performing the system testing, where they will be testing the entire application as a whole, they will be using the client specified requirements to verify the stuff. Okay, to see whether the developers have developed the software according to the client specified requirements or not. They will check. Not only that, guys, I'm saying this as a black box testing. That means here the software testers will perform system testing using the visual appearing functionalities of the software. Here code is not visible, guys. Okay, code is not, neither code is visible nor accessible in this case of system testing, because it is a black box. So software tester doesn't know what code has been implemented or developed by the developers for building this software. Okay, without having the knowledge of the code which is written for developing the software application, testers will be performing testing on the entire application as a whole using the visual appearing functionalities of the software, where they will be testing according to the client specified requirements. Okay, they will see whether the application that is developed by the developers is working according to the client specified requirements or not is the main focus here. So what about the user needs and expectations? Here main focus of system testing is on the whether the developed application is developed according to the client specified requirements or not is a main focus, but less amount of focus is given to the user needs and expectation in case of system testing. But there is one more level of software testing, that is acceptance testing, where more focus is given to the user needs and expectations. Okay, in system testing more focus is given to the client specified requirements. Okay, whereas in acceptance testing, here the testing will be performed to check whether the developed software developed by the developers is according to the user needs and expectations or not. That is a main important focus in case of the acceptance testing. Okay, in case of acceptance testing, whether the developed software is according to the user needs and expectations is an important focus. Okay, it's a business is important here. Okay, whether the software that is developed will solve the problems of the users or end users or not, real customers that are going to purchase the software or not is a acceptance testing, guys. Acceptance testing is generally performed at two levels. One is alpha testing, followed by alpha testing. Beta testing is also performed. Okay. So in case of alpha testing, guys, okay, first of all, guys, before I explain alpha and beta testing here, you have to understand that acceptance testing is also belong to the black box testing category, where code is neither visible nor accessible. Okay. In case of acceptance testing, code that is used for developing the software by the developers is neither visible to the people who are performing the acceptance testing, nor it's accessible nor visible. Okay, nothing is you'll not have any knowledge of the code here. Okay, you will just see the visual appearing functionalities of the software. Using that, we'll perform the acceptance testing, and here the main goal is to see whether the developed software is according to the end user needs and expectations or not. Okay, and now you understood it is a black box testing similar to the system testing. Here coming to the alpha testing, guys, internal team will be performing the alpha testing. Okay, who will be performing the alpha testing? Internal team. So the client who has given the project, right, that particular client side people will be there who knows the business well. Okay, there will be some people from the client side who has given the project to other company for developing and testing. Okay, that client side people will be there who has good knowledge on the business knowledge on the software that is getting developed by the other company. Okay, so these people will come up with a checklist, guys, and verify whether the system testing completed software is according to the user needs or expectations or not. It will check. Okay, these people who are from the client side, they are interacting with the customers or whatever it is, they are collecting the feedback and all. They'll create a checklist. With that checklist, they will check whether the developed software which has passed the system testing is actually meeting the end user needs or expectations. They are going to check. If it is not it's not matching, what they will do, this internal team of the company, that is a client company, okay, will give the feedback to the company who is actually company where the developers and testers are residing and who are performing the development and testing operations of the software. Okay, and based on the received feedback, the developers and testers have to support this internal team so that the final version of the software is developed and created, which will pass the acceptance testing. Okay, that is alpha testing, guys. Okay, in case of alpha testing, internal team will take care of the things and developers and testers will support the internal team from the client company. Now coming to the beta testing, after the alpha testing is successfully tested and approved as part of user, it can be called as user acceptance testing also. After the alpha testing of acceptance testing is done, then the company will not directly release the software into the market. Okay, so what the company will do is the client company will release the software to the limited number of end users. Okay, not everyone in the world, only limited end users of customers. It will release the software. So with an intention of collecting more feedback. Okay, with an intention of collecting more real-time feedback, the company will, before releasing the software into the market after completing the alpha testing also, it will release the software only to the limited number of end users or customers or who are going to use the software in the coming days. Okay, so those people also will use the software and they will come across some defects or they will come across some feedback or something. They will share the feedback, and accordingly the company, okay, will accommodate those changes. They will go through the feedback given by the real end users, and then accordingly they will update the software and get it developed and tested by the team. And then finally, once the alpha testing, beta testing is completed and approved, then the final version of the software will be released into the market. Okay, these are the different software testing levels, guys. Before the software gets released into the market, all these levels of testing will be performed at different levels of the SDLC or whatever you can say. Okay, unit testing, integration testing will be done by the developers, whereas system testing will be done by the software testers, whereas acceptance testing will be done by the internal team or limited end users or customers. Okay, who are going to use the software. So these are the different levels of software testing. So hope guys you got the answer for what are the different levels of software testing. So that's all for this session. In the next session, I'm going to explain or answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 56, that is explain integration testing of application modules in real-time example. Let me answer. So integration testing of application modules in real-time example I have to give. Okay, I have to give the real-time examples for the integration testing of application modules. Let's say guys you take a application like Gmail. Okay, so what do you do in Gmail guys? Okay, so in Gmail, after you open your Gmail account, what you will do is you will just try to send an email to other account, okay, other Gmail account or other email account you want to send an email via Gmail. You are going to send an email to other email, okay. So as part of integration testing, how do you test a Gmail? So what you'll do is you'll first click on new email and compose the email. You will provide the email address of the other account. You'll provide the subject line. You'll provide the email body, whatever the text you want to write inside the email body, you will write it down. And after that, you will simply click on the send button. The moment you click on the send button, guys, the email will be sent. So now, do you have to continue the testing here? Till now guys you have tested the application module independently, okay, whatever the example I gave for the Gmail just now till now, okay, where you are just composing the email and sending it is just a particular unit application module you are testing, that's it, okay. You are not performing the integration testing of different application modules, okay. You are testing only the composing of email, okay, module in the Gmail application. If you are only composing the email and click on send button, means you are only testing the only one application module you are testing, that is related to the composing of emails in Gmail module you are testing independently, okay. But as part of integration testing of application modules, if you have to test, what you will do with Gmail? So after composing the email, after you click on the send button, then the testing will not stop there, okay. The testing will not stop there. As part of integration testing, you have to go to the sent items, okay. Apart from testing the composing of emails and clicking on the send button, you have to go to the sent, okay, sent items option in the email body, email account, okay. After going to that sent item section, you have to see whether the email has been sent or not to the desired email address, whatever you provided is being shown as sent or not in the sent items list. That is one thing you will check. Not only that guys, you will log out from your current Gmail account and log into the account to which you have sent an email, okay. First you will log out from your account and you will log in to the email account to which you have sent an email, and after logging into that another email address to which you have sent an email, you will see whether an email is received by that email account or not, okay. Whether the email has been received to that particular email account or not from the sent email address, okay. This is what is integration guys, okay. So in real time when you're performing testing, you cannot test all the application modules independently, okay. There's a connection between one application module to another application module. Here compose email application module is connected with the sent items, okay. Sent items is connected with the inbox of the other email account. From there you'll open the email address, okay. From that received email, you will open the received email from other account where you have sent the email, and you will check the details like who has sent the email, what is the subject line they have written while sending, what is the message body, okay. All this stuff you will check. So this is what is integration testing guys, okay, where we are going to integrate different application modules to test whether the application is working fine or not, okay. That is what is integration testing in real time. One of the example I provided just now with Gmail. Another example if I have to provide is bank amount transfer, okay. Everyone nowadays uses net banking, right? Let's say HDFC net banking or Axis net banking, whatever it is. So what happened? There's one of the application module in net banking, that is you can transfer the amount from one account to another account, okay. You can transfer the amount from your account to other account, let's say, okay. So what you will do guys, you will go to the account transfer. Let's say you are testing the application module, bank amount transfer module, okay. You will enter all the details like account number of the receiver and amount that has to be sent from your account to the other account, and then you will simply say transfer amount, okay. So you will actually say okay or something for the transfer. Okay, confirm that. So what happens, guys? That is not the end of the testing, right? Okay, if you are testing only the application module, you will simply say whether if I enter the amount and give the sender account details and click on send, that's not the enough case. Okay, so if you are testing only application module independently, that much is enough. But here integration testing means the testing is not done it. Okay, after the amount, after you click on that transfer amount confirm options and all, you will receive an message saying that the amount has been debited from your account and being sent to the other account. Okay, some success message will come. That is also not enough case. Okay, you will log into the other account to which you have sent the money, transferred the money, other bank account to which you have transferred the money, and see whether the money has been credited to that account or not. Okay, has been received by that account or not. How can you confirm that that account, that receiver account balance should be the older balance plus the received amount? Okay, that should be the current, okay, account balance of that received account. Okay, receiver account. Now in the sent account, okay, from the account from which you have transferred the amount, in that account, the balance should be minus the amount that you have transferred. Okay, the older account balance minus the amount you have transferred to the other account should be. All these things you have to test, guys. Okay, so this is all integration, right? Okay, simply transferring the amount is not enough. Whether the amount has been reduced from your the account from which you are sending the money to other account, or in the receiver account the amount has been increased by the number of, by the kind of amount that has been transferred or received to your account. All these things you have to check it. That is only possible with the help of integration testing of application modules. Okay, these are the two real-time examples, guys, I wanted to provide as part of this interview question. Okay, so hope, guys, you got the answer for this question. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 57. That is, what is top-down integration testing approach? Let me answer. There are different integration testing approaches, and top-down integration testing approach is one of them. As you can see here, these are the different integration testing approaches that can be followed while performing the integration testing. Okay, they are like top-down integration testing approach is one of the approach. We also have the bottom-up integration testing approach, and other integration testing approaches are sandwich integration testing approach and Big Bang integration testing approach. Any of these approaches can be used while performing the integration testing. Hence, top-down integration testing approach is one of the different integration testing approaches available. Okay, so how the integration will be performed? Okay, how the integration testing will be performed as part of the top-down integration testing approach? In case of the top-down integration testing approach, higher level, okay, higher level units will get integrated to their lower level units. Okay, let me show you. Let's say here you are integrating the different units. Okay, and this is the top down, right? This is the top down integration testing approach. Okay, starting from the top to the down. Okay, this is the top, and this is the down. Okay, going down from top, you are going down while integrating the different units. Okay, so before integration testing starts, guys, okay, generally the developers as part of white box testing category will perform the unit level testing, where the smallest unbreakable parts, okay, will be tested independently. After that, what they will do is they can follow any of these integration testing approaches to integrate those units. Okay, so in case of the top down integration testing approach, what they will do is they will first collect all the higher level units. Okay, they will correct all the higher level units. Let's say these are the different higher level units on the top. Okay, these higher level units will be integrated with their lower level units. Okay, the next lower level units they will be integrated with. Okay, these higher level units will be integrated with the lower level units, and then and so on, guys. Okay, and so on. Okay, so here higher level units are getting integrated with the lower level units, and these lower level units will be now integrated with their lower level units. Okay, the next level lower level units. Okay, it will go from top to down, guys. Okay, higher level units, next lower level units, next lower level units, and so on. Okay, this process continues until all the units are integrated properly. Okay, so but integration starts from top to down. That's why it's called as top down integration testing approach. So there may be some problem that comes while you perform this integration testing, okay? While the developers perform this integration testing approach where they integrate the higher level units with the lower level units and so on as part of this top-down integration testing, they may come across some problem where while during the integration, some of the unit may not be available. Okay, some of the units may not be ready for integration. So if developers have to wait for this particular units to get ready, that will take a lot of time. That will waste a lot of time. Okay, if this particular unit is taking a lot of time to get ready, the unit testing, the top-down integration approach will stop. Okay, because the unit is not ready. Okay, the unit is not ready. So in that case, guys, what the developers will do is, okay, so in place of this real unit, okay, in place of that real unit which is not ready, they'll put something known as stub. Okay, something known as stubs, okay, which is nothing but temporary program, guys. In case of this real units, they'll provide something known as stubs, stubs. Okay, so stubs are nothing but the temporary programs. Okay, they are not the real programs. They generally simulate the real units. Okay, stubs are temporary programs which simulate. They just give input and output. That's it. Okay, but real logic is not written inside the stubs. Okay, they are temporary programs. So for this integration testing to not stop, developers will use this kind of stubs. Okay, in case of top-down integration testing approach, they use something known as stubs. If some of the units are not ready, the stubs are nothing but the temporary programs. Okay, so hope guys you got the idea what exactly is the top-down integration testing approach. So that's all for this session. The next session I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session I'm going to answer software testing interview question 58, that is, what are stubs? Let me answer. Stubs are used in one of the integration testing approaches. Okay, as part of integration testing, developers may follow different approaches. Okay, what are the different integration testing approaches that developers will follow while performing the integration testing? There are 4 different approaches in integration testing that developers may follow. They are top-down integration testing approach, bottom-up integration testing approach, sandwich integration testing approach, and finally big bang integration testing approach. Any of these approaches the developer may use while performing the integration testing. Okay, but in which type of integration testing approach these stubs are used? Stubs are used in the top-down integration testing approach. Okay, the top-down integration testing approach, stubs are used. So let me explain this top-down integration testing approach and the requirement for using the stubs in this top-down integration testing now. Okay, so as you can see here, guys, this is the top-down integration testing approach. In top-down integration testing, developers, while performing the integration testing, will integrate the higher level units. Assume that these are the, whatever I'm drawing here are the individual units, higher level individual units. Okay, these higher level individual units as part of integration testing will be integrated with their immediate lower level units. Okay, higher level units will be integrated with their immediate lower level units like this. Okay, as part of integration testing approach, that is top down integration testing approach. From top we'll start and we'll go till down. Okay, we'll start with the higher level units and integrate this higher level units with their lower level units like this. Okay, immediate lower level units like this. Once this lower level units are integrated with this higher level units like this. Okay, these lower level units will be again integrated with their lower level units. Okay, for other units these are higher units, right, like that. Okay, the process keeps on going, guys. Okay, the integration process keeps on going like this. So we are going to integrate the higher level units with their lower level units as part of the top down integration testing approach. But what is the requirement of these steps in this top down integration testing approach? What happens during real time when developers are performing the top down integration testing approach is one of the unit may not be available. Okay, this unit may not be ready, guys. Okay, it's taking a lot of time to develop or create this unit by the developers. Okay, so this unit is not ready. Just because of this particular unit or units are not ready, we cannot stop the integration testing, right? Developers cannot stop the integration testing just because few of the units are not available or ready. In that case, what the developers will do is, in place of these real units, they will replace these real units with the stubs. Okay, just to proceed with the, just to not stop the integration testing in between. Okay, to continue the integration testing. So in top-down integration testing approach, to continue the integration testing, developers will replace these real units with the temporary programs known as stubs. Okay, what are stubs? Stubs are nothing but the temporary programs. Okay, So when the real unit is not ready, then developers will use the temporary programs, okay, which are a dummy programs, guys. Like they'll take input and give the output. That's it. No real logic is written inside that stubs, okay. Stubs are temporary or dummy programs which can be used in place of the real units, okay. Till the real units are ready, developers are going to use stubs, okay. So in case of the top-down integration testing approach, if few of the units are not ready, in that case, not to stop the integration testing, developers are going to use stubs, which are temporary programs or dummy programs, okay, and use them to continue the integration testing, okay. So this is what is called as stubs, okay. And there are other things, guys. So in another integration testing approach, that is bottom-up integration testing, we call these temporary programs as drivers, guys. Okay. In case of top-down, we call them as stubs, okay. In bottom-up integration testing approach also, we use some temporary programs when units are not ready. So that is those are called as drivers in case of bottom-up, but in case of top-down integration testing, they are called as stubs. In sandwich, we use both cases. Okay? In sandwich means both the directions the integration will happen. That is from top to down it will happen, bottom to up also will happen. It is a sandwich is a combination of top-down and bottom-up. So both will be there. That is stubs and drivers will be used here by the developers. Okay, when the real units are not available. Okay, so this is what are stubs, guys. Okay, so hope guys you got the idea, like you got the answer, like what are stubs in this session. So that's all for this session. The next session I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 59, that is, what is bottom up integration testing approach? Let me answer. There are different integration testing approaches that developers can use for performing the integration testing. Bottom up integration testing approach is one of them. So what are the different integration testing approaches we have? We have four different integration testing approaches. They are top-down integration testing approach, bottom-up integration testing approach, sandwich integration testing approach, and finally, Big Bang integration testing approach. Developers, based on their requirement, can use any of these integration testing approaches for performing the integration testing. But how does the developer perform integration testing using this bottom-up integration testing approach? Let me explain. In case of in case of developer using this bottom up integration testing approach for performing the integration testing, developers will integrate the low level units with their higher level units. Okay, they'll start with the lower level units and integrate them, okay, in an incremental fashion with the higher level units. Fine. So let me show you how the developers will perform the bottom up integration testing approach. Let me draw this box, and here I'll put an arrow, guys. Okay, this arrow represents bottom to up. Okay, developer will start from the bottom. Okay, developers will start from the bottom and then slowly will move to the upside. That's why it is called as bottom up integration testing approach, guys. In case of bottom up integration testing, first developers will start with the low level units. Okay, developers will use a low level units. Okay, the piece of unit, you already know about unit in unit testing, right? So each and every unit will contain a piece of code which cannot be broken further. Okay, which cannot be broken further. Such kind of units, low level units, the developers will start the work with. These are the low level units, and these low level units developers will integrate with the developers will integrate these low level units with what? Higher level units. Okay, these low level units will be integrated with the higher level units. Just to finish it fast, I'm just drawing like this. Okay, so here low level units got integrated with the higher. These units again will be integrated with, again they will be integrated with another upper level or higher level units. Okay, again the process will continue, guys. Okay, the process of integrating the lower level units with the upper level units will continue in the bottom up integration testing approach. So the process will continue until the bottom up integration testing is completed. Okay, all the units got integrated like this. Okay, this is the process, guys. Okay, they'll start from the bottom and go to the top. Now, guys, there is one more thing that you have to understand here in case of the bottom up integration testing approach. That is, okay, now you understood what is bottom up integration testing approach and how the developers are going to use this approach for performing the integration testing. You understood it now. Okay, now there is something known as drivers. Okay, there is something known as drivers. Okay, which are temporary programs and are used if units are not ready, guys. Okay, so let's assume that while the developers are performing this bottom up integration testing approach where they are integrating the lower level units with the upper level higher level units. Okay, let's assume that one of the unit is not available. Let's assume that this particular unit is not ready. Okay, it's not the development of this particular unit is not done. Okay, it's not completed. It is going to take some time. Just because this particular unit is not available, developers cannot stop this integration testing, right? Okay, developer cannot stop this integration process. So developer cannot stop this bottom-up integration process. To overcome that problem, guys, in place of this real unit, they will place a dummy unit or a temporary program unit which simulates the real unit. Okay, it doesn't have the code, guys. It just gives the input and it takes the input and gives the output kind of unit. Okay, it doesn't have the real logic created. A dummy unit will be placed in place of this real unit. Okay, till that real unit is ready, a dummy unit will be placed in case of this real unit, and that particular dummy temporary program is known as driver. Okay, driver or drivers you can say. So we'll use drivers, that is temporary programs. Okay, if any units are not ready, to continue our integration testing. Okay, to continue the bottom up integration testing, we use drivers. So hope guys you got the answer what exactly is this bottom up integration testing approach. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 60. That is, what are drivers? Let me answer. Drivers are used in one of these integration testing approaches. There are different integration testing approaches that developers follow for performing the integration testing. They are top-down integration testing approach, bottom-up integration testing approach, then we have the sandwich integration testing approach, Big Bang integration testing approach. Any of these integration testing approaches the developers may use for performing the integration testing. Out of all these integration testing approaches, where the drivers are used in the bottom-up integration testing approach. But what exactly are these drivers and why they have to be used inside this bottom-up integration testing approach? Let me explain now. Okay. So guys, here, as you can see, there's a box, and here I mentioned bottom up, which states bottom up integration testing approach. As part of bottom up integration testing approach, the developers, while performing the integration testing, will integrate the low level units. Okay. The lower level units, developers will integrate these lower level units with their higher level units. Okay. The next level, higher level units. This lower level units will be integrated with their higher level units like this. Okay. Developers will integrate this lower level units with the somehow logically they will integrate, guys. So it's ideal case, but logically developers will integrate this lower level units with the higher level units, and these higher level units again will be integrated with their higher level units. Okay, like this. Somehow they will be integrated. Okay, this lower level units will be integrated with the higher level units, and so on, guys, and so on. It keeps on going up. Okay, so here each and every circle here is a unit phase. Okay, so units are getting integrated as part of this integration testing, that is bottom up integration testing. Lower level integrate lower level units are getting integrated with the higher level units. Okay, so all good, so far so good. But what if while performing the bottom up integration testing, for example, this particular unit is not ready? Okay, it's taking a lot of time. Okay, this is a very complex unit, and this particular piece of unit is not ready, guys. Okay, so in that case, what developers will not stop the bottom-up integration testing just because this particular unit or a set of units are not ready. So what the developers will do is they will use something known as drivers. They will create something known as drivers, guys. Okay, driver or drivers here. Okay, driver or drivers they will use here. So what are these drivers? Drivers are nothing but, okay, in case of the bottom-up integration testing, if a few units are not available and they are blocking you from continuing with the bottom-up integration testing, in that case developers are going to use drivers which are nothing but the temporary or dummy programs. Okay, what are these drivers? Drivers are nothing, not the real units. Okay, drivers not the real units, they are temporary programs. Okay, temporary programs used until these units are available for integration. Till then, instead of stopping this integration process or testing process, what they will do is the developers are going to create these drivers. Okay, which are very simple things, guys. Okay, simple temporary programs, dummy programs, we just take input and give output. That kind of drivers they are. Okay, they are dummy stuff. So in place of this real units, they are going to use drivers until the real units get available. Okay, so that the integration testing will continue. So that's what our drivers, guys. Okay, until the units are ready, developers are going to use drivers which are temporary programs or dummy programs. Okay, for continuing their integration testing as part of the bottom up integration testing approach. But if the developers are following the top down integration testing approach as part of integration testing, there is something alternative to drivers, guys. We call them as stubs. Okay, in case of top down, we call them as stubs, guys. Okay, these are also same thing, guys. These are also the temporary programs used when units are not ready. Okay, so stubs. In case of top down integration testing approach, we have to name them as, we have to call them as stubs. In case of bottom up integration testing, we have to call them as drivers. What about sandwich? In sandwich, guys, sandwich is a combination of top down and bottom up, so hence both will be there. Okay, sandwich is a combination of top down and bottom ups. That's why both stubs and drivers will be used, okay, which are nothing but temporary programs. So hope, guys, you got the idea what exactly are drivers now. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 61. That is, what is UI testing or GUI testing? Let me answer. In UI testing or GUI testing, we test the user interface or graphical user interface of an application software. For example, if I take you to this application, okay, if I take you to this application, and if I have to perform the UI testing or GUI testing, how does the user interface of this application? Let me give you some examples, guys. For example, this particular button, background color of this button should be in black color. It's already there in black color, so no problem. According to the client specified requirements, if this button has to be in black background and the text on the button should be in white color, so according to the client specified requirements, I will check. Here I'm not testing the functionality of this button. I'm testing how the button should be there as per the client specified requirements. What is the UI? Okay, what is the display of this button on the user interface of this application page? And also, not only that, you see, as part of UI testing, we test whether the related fields are properly aligned or not. For example, here, this particular search box field is properly aligned with this search button, and it is properly aligned with this black color button and all those stuff. Okay, so and also here on the top, you see the menu options, all these header options are in a proper line. Okay, if one option is on the top and one option is on the down, that is an alignment problem. Okay, that's an alignment problem. And also, not only that, guys, there should not be any spelling mistakes. Okay, for example, if you read this my account, there's no spelling mistake in this my account. There's no spelling mistake in this wish list. Okay, shopping cart or checkout, all are properly spelled. So like that, we will test, guys. Okay, as part of UI testing, we have to test the user interface of the application or graphical user interface of the application. We don't have to worry about the application functionality is working fine or not. Here, the purpose of the UI testing is to test the user interface. So if this, for example, if you have to test this text, okay, you have to see whether the alignment of this text is proper. So it is left aligned, right? The text is left aligned. According to the client specified requirements, it has to be left aligned. Let's say it is left aligned. Not only that, whether you can read this particular text or not. Okay, visibility of the text. Okay, if some new user or a end user uses this application, can that end user can read this particular text? It should be readable, right? So and the alignment, guys, you see the heading and the subheading and this particular text are properly aligned here. Not only that, in this box also, the email address field, password field, and login button are properly aligned. Label and text box fields are properly aligned. And also inside the text box fields, the placeholder text is also provided. You say inside this field, email address placeholder text in gray color is provided. In the password text box field also password gray color text, that is placeholder text, is being displayed, and whether all the options that has to be there on the user interface of this application are available or not. As per the client specified requirement, there should be a proper heading for the login this login section, like returning customer kind of thing, and there should be a subsection like I am a subheading like I am a returning customer, and there should be a proper label. Okay, and their label should contain under the label there should be email address field, text box field, there should be a password label, and there should be a password field according to client specified requirements. All are provided, let's say, and you are checking that user interface only. You are not worried about the functionality of this application, guys. You are only worried about the user interface. Okay, according to the client specified requirements, user interface has been created or not. Okay, the proper number of fields in the proper format are created or not. And also you can check the colors, guys. For example, all the buttons on this page are in, you see login button is in blue color background, this continue button is also in blue color background. If I go to the register page, okay, a proper tendency is followed. Okay, across the application, all these kind of buttons are in proper color or not, all the hyperlinks are in a similar manner or not. For example, here login page, okay, and here privacy policy, all are in the same format. You see breadcrumb also has hyperlink kind of stuff, which is also in the same color. Okay, so alignment, you see the login, all are left aligned and properly aligned here. Okay, there is no problem, and there are no spelling mistakes, grammatical mistakes, everything we have to check, guys. Okay, so For example, if you got a defect, one of the example of the defect you may get in UI testing or GUI testing, I'll show you. This is one of the example of the UI a defect you may come across when you perform UI testing or GUI testing. You see here the plus symbol, okay, on this application. This is a screenshot, guys. So this is just a screenshot of the entire application. Okay, so of a particular portion of the application, the screenshot has been taken. As you can see, the first section, the things are good. You see one ebooks. That is a problem, right? For one ebook should not come. One ebook should come. That's spelling mistake is there. Okay, it's not proper way to say one ebooks. Otherwise, you have to provide circular brackets around this S so that we can understand that if in case of one, it's a ebook. If in case of multiple books, we can say ebooks. Okay, but here one ebooks is not right. Okay, this is one problem. And other than that, you see here in the first section, this thing is probably plus sign is properly placed in the first section, but in second section, one ebooks, PDF, EPUB, Amazon, you see plus symbol is okay is overlapping this Amazon. Okay, this should not happen. This kind of defects you may get in UI testing, guys. Okay, when you are performing UI testing, there will be some options which will be overlapping with the text and all the stuff. Okay, sometimes the text will be going outside the page, okay, and going outside the section. For example, here if you go to this login page here, if this particular text is bound to this particular box, what if this particular text is going outside this box? That is a UI defect. Okay, so a lot of UI defects are possible, guys. Okay, a lot of examples we can take. UI testing is not a simple thing, guys. It's a very complex and very detailed thing, you can say. So I have already given you a lot of examples, right? The whether the user interface is designed or developed according to the client specified requirements or not is the first thing. So if this particular height of this particular text box field should be some pixels and the width of this text box field should be some pixels, it should be according to the client specified requirements. Okay, the color, the height, width, and the type of the field, and whether it has a placeholder, everything will be specified in the client specified requirements. Whether it is there or not, we have to check as part of UI testing. Apart from that, we have to check whether there are any spelling mistakes in the in this label text or in this kind of text anywhere. Wherever you see some English text or any other text, it should not contain any spelling mistakes. Okay, it should not contain any grammatical mistakes. All these tests will fall into the UI testing category. Alignment, you see here the label is properly aligned with the text box field, and these two are properly aligned with this remaining stuff, right? Here everything on the page is properly aligned. I don't see any disturbance on this page. The alignment is very proper. Overlapping, no option is, no button is overlapping on a text field, or no label is overlapping with any other options. Okay, everything is properly placed on the page. Colors, proper colors are provided to all the UI elements. Here this button should be in black color, this one should be in blue color background, and all proper color combination is also there as per the client requirements. Proper color combination is there or not, we have to see. And many more are possible as part of the UI testing, guys. UI testing, as I told you already, it is a very detailed thing. So here is a full checklist, guys. Okay, if you want to see the full checklist, here is a full checklist. I'll copy this checklist. So here also in the notes, I provided this checklist, guys. You can take the checklist from here, the link for the checklist. I'll open the checklist link here. So this is a very detailed checklist I created. So which you can use for performing the UI testing on different type of UI elements on the web pages. Okay. So on different applications and all. Okay. So for example, if you are testing the text, okay, if you are testing the text, you can check for spelling mistakes. For example, on this application page, if you are testing this particular text, what kind of test, UI test you can perform on this kind of text on the application? You can check for spelling mistakes on these pages. You can check for grammatical mistakes. You can check whether the text is readable. Can you read it? Okay, as an end user, can you read this particular text, or if the font size of the text is too small or too big, you can find it out. Okay, font size, color of the text, family of the text. Okay, alignment of the text. You see the text is properly aligned. I feel left aligned, properly aligned. Okay, there's no problem. Should be left aligned. This particular text should not overlap with any other UI elements on the page. For example, this particular text is overlapping, coming on the top of the continue button. That is a UI defect. Okay. So is not going outside the page or section. For example, this particular text is bound to this particular section, and proper spacing is also provided within the box. Okay, so it's properly aligned and it's not going outside of the section or page. You see here page headings and page text are properly distinguished, right? There is a kind of differentiation between this main heading, subheading, and the text. Okay, you can see the difference. That kind of thing is followed or not. So only for testing the text, this many checklist items are there. So similarly, guys, in this checklist, you can find if you are testing the text box fields. Okay, text box fields are text area fields. For example, email address field, if you are testing, which is a text field. So then you can see like whether correct labels are provided for this text box field, whether the uh, label is properly aligned with the text box field. So a lot of other options are possible, guys. Okay, this is very detailed one. Okay, very detailed one, very detailed checklist, guys. Okay, so placeholders are there or not. Okay. If it is a mandatory fields, asterisk symbol is provided or not, like that, all the things we have to check. Okay. And what if you are testing the drop down fields? Okay, on an application page, if you have the drop down, this is the UI testing checklist for the drop down fields. If you are testing the buttons, let's say you are testing this login button. Okay, this is the checklist for testing the buttons. Okay, if you are testing the checkbox field, for example, on this page, there is a checkbox field. This is a checkbox field. If you are testing this checkbox field, this is a checklist for testing the checkbox field. If you are testing the radio buttons, yes and no are the radio buttons here. For that, this is a checklist. If you are testing the hyperlinks, for example, the login page is a hyperlink. For that, this is the checklist. Okay. If you're testing the images on the home page of this application, you can see there is this is an image, this is an image, all these product icons or images. These are the product images, right? All are images, nothing but. If you're testing that images, okay, this is the checklist for the images. Numerical input fields, this is the checklist. Okay, for scroll bars, this is the checklist. Okay, it's a very detailed checklist, guys. I'm not going to explain each and every checklist item here for you. I'm just at a high level giving you the confidence like how to answer this question in the interview. If you get a question where what is UI testing or GUI testing, okay, this is a very big complex topic, and the main idea is to test the user interface or graphical user interface of the application without worrying about the application functionality. As part of UI testing, you are not testing the functionality of the application, you are simply testing the user interface of the application, guys. Okay, so logo, you can test the logo with this checklist, you can test the menu options with this checklist, you can, if there are some maps displayed on the application, this is the checklist, and a lot of other things are possible, guys. Okay, a lot of other things. Okay, lot of things are required as part of it. This is a very big topic. UI testing is a very big topic, and you can go through this checklist items, guys. Okay, I have provided this in the notes. You can watch this. You can go through these notes, and whenever you come across any testing where you have to perform UI testing, you can use this UI testing checklist for your purpose, guys. Okay. So hope, guys, you got the answer. What exactly is UI testing or GUI testing, and how it is performed, and what are the defects that you come across as part of UI testing or GUI testing, and the entire checklist. Okay, very detailed checklist I shared you as part of this answer for this particular interview question. So that's all for this session, guys. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 62. That is, what is functional testing? Let me answer. Functional testing is performed to verify the working of the application functionality. For example, if I take you to this sample application, that is tutorialsninja.com/demo, which is an e-commerce application, if I have to perform the functional testing, I can perform something like this. Okay. So as part of functional testing, we verify the working of the application functionalities. For example, search functionality is one of the functionality of this e-commerce application. I have to verify whether this search functionality is working fine or not as part of functional test. How can I verify that? Here I'll type one valid product detail, that is HP, okay, which is one of the product name, and click on the search button. And if I'm getting this HP product in the search results, that means search functionality is working fine at a high level. Okay, this is not the only one test case. We can have multiple test cases using which we can test the working of this search functionality. Similarly, if I take you to this login functionality, I can test this login functionality whether it is working fine or not as part of functional testing. I'll give some credentials here. I'll give some valid credentials and click on login. The application functionality is working, right? I have verified the login functionality of the application with valid credentials. Similarly, I can verify the login functionality with invalid credentials also. If I give some invalid credentials here, let's say if I give some invalid credentials and try to log in, the application should not allow me to log in. That means the application functionality is perfectly working fine. So verify the working of the application functionality is known as functional testing. As part of functional testing, we'll verify, okay? We'll verify the working of the application functionalities. It can be search functionality, it can be login functionality. With various test cases, we'll verify the working of the application functionality. That is what is functional testing. So as part of functional testing, guys, we perform testing or verify the working of the application functionalities according to the client specified requirements. Okay. So in the beginning of the project, the client has given you the client specification. During the project or in the beginning of the project, whatever the client specified requirements are there, according to that, the functionality of the application is working or not, we'll test as part of the functional testing. And also on the top of that, we'll also see whether the application functionality is working according to the user needs and expectations. Okay. By using the application, whether the user needs and expectations are being met or not is also verified as part of the functional testing. And this functional testing can also be automated, guys. There are several automation tools available in the market depending on the type of the application. If the application is web application, we can use Selenium automation tool. Okay. If the application is a mobile application, we can use APM automation tool. If the application is a desktop application, you can use UFT, which is olderly known as QTP. Nowadays, it's called as UFT. Okay. Or test complete we can use. Different automation tools exist, guys, using which we can automate the functional testing. Okay. So now I'm going to list down the different types of testing which fall into this functional testing category. As you know, in software testing, there are a lot of different types of testing, right? A lot of testing types are there. So few of the testing types which fall into the functional testing, I'm going to list down here. Okay. So what are the different testing types which fall into the functional testing? This is not the entire list, guys. Okay. Only the few list so that you can understand, okay, which type of testings fall into the functional testing. I listed down here. Unit testing falls into the functional testing. Developer will perform this unit testing to see whether that particular unit piece of code which cannot be broken further is working fine or not. Okay, it's functioning properly or not. Okay, as part of white box testing, unit testing is performed here. This falls into the functional testing. Similarly, integration testing, a group of logical units and all will be tested together. As you already know, developers will do that. This also is part of the functional testing. System testing, where software testers will perform the system testing, where they will test the entire application as a whole, as a complete thing. That is functional testing. Here, basically, we'll check across the client specifications. Okay, whether the developed software is according to the client specified requirements or not, is working according to the client specified requirements. Is system testing. More focus is on the client specification. Acceptance testing, whether the developed software is meeting the user needs and expectations. Okay, as part of acceptance testing, alpha testing, beta testing will be done. It's also called as user acceptance testing. Here also we'll test whether the application functionality is working according to the user needs and expectations. Hence, it also falls into the functional testing category. Smoke testing, sanity testing, regression testing, black box testing, white box testing, UI testing, API testing, and many other testing types fall into the functional testing category, guys. Okay. So hope, guys, you got the answer what is functional testing in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 63. That is, what is non-functional testing? Let me answer. In non-functional testing, we will verify the non-functional characteristics of an application like performance, security, etc. Okay, so you will understand non-functional testing when I compare that with the functional testing. So what is functional testing and how it is different from the non-functional testing, and what is the difference between functional and non-functional testing? Let me explain. In case of functional testing, guys, we are going to verify the functionalities of the application are working or not. Okay, we will verify whether the functionalities of the application are properly working or not. For example, if you take a login functionality of an application, so we'll verify or check. As part of functional testing, we'll provide credentials into that particular fields of the login page fields, and then try to log in. Okay, if you are able to log in with valid credentials, the functionality is working. If you provide invalid credentials into that login fields of the login page and try to log in, the application should not allow you to log in. Okay, in that case, we can say that the application is functioning well. So functional testing is all about checking or verifying whether the functionalities of the application are working fine or not is functional testing. But coming to the non-functional testing, it's not about checking the functionalities of the application are working or not. Instead, non-functional testing is all about verifying the characteristics of the application. Okay, non-functional characters of the application we are going to verify as part of the non-functional testing. Okay, so like performance of the application is good or not. Okay, how much speed the application pages are loading under real world conditions, like this many number of users are using the application, still how much speed the application is able to load its pages. Okay, when end users are trying to access the application. And security, to talk about the login functionality, how secure is the login functionality? Okay, so will the hackers will be able to bypass the security, okay, without even providing the valid credentials, or without giving the actual credentials, whether the hackers are able to bypass the login functionality or not? Such kind of things we'll test as part of non-functional testing. Okay, here we are going to test the non-functional characteristics of the application, not about the working of the application function. It's all about the characteristics of the application, how secure is the application, how speed is the application. Such kind of non-functional characteristics are verified as part of the non-functional testing. So here we have a list of testing types which fall into the non-functional testing. This is not the complete list, guys. Whatever the list I'm going to show you now is not the complete list, but these are the examples, you can say. Okay, this testing types that I listed here will fall into the non-functional testing category. That is performance and security, as I already mentioned, are the non-functional characteristics of an application, right? Performance and its subtypes like load testing, stress testing, scalability, all this belong to the performance testing only, right? Spike testing, endurance testing, volume testing, all falls into the non-functional testing category. And security testing also falls into the non-functional category. Apart from performance and security, we have reliability testing, usability testing, resilience testing, recovery testing, baseline testing, and compliance testing. All these testing types that I listed down here will fall into the non-functional testing category. So hope guys you got the answer for what is non-functional testing. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye-bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 64. That is, what is requirements traceability matrix? Let me answer. Requirement traceability matrix is used to map the requirements with the test cases. Okay, software testers are going to create this requirement traceability matrix where they are going to map the client specified requirements with the tester created test cases. Okay, the client specified requirements will be mapped with what? The software tester created test cases as part of this requirement traceability matrix. And who is going to create this requirement traceability matrix? Software testers are going to create this requirement traceability matrix with this purpose. So in short, requirement traceability matrix is called as RTM. Okay, R means requirements, T means traceability, M means matrix. Okay, short form is RTM. Now let me quickly show you an example template for this RTM. Okay, so if you Google search on the web for RTM template, you'll get a lot of templates, guys. Okay, there are a lot of templates on RTM, but I'm going to show you only one template. Okay, so whatever the template I like and I generally use, okay, that I'm going to create here. Okay, that I'm going to show you here. So, but in real time, there are different type of templates, guys. Okay, this is one of the template that I felt good, okay, of using. I want to share with you guys as part of that, okay, because I liked it. So as you can see, this is one of the template for RTM. So what's happening in this template, you just see here, okay. The first two columns belong to the requirements, right? Requirement ID, requirement description. This part is client specified requirement. First two columns are nothing but the client specified requirements. What is the third column? Third column is nothing but the test cases, right? These are the test case IDs, okay, IDs of the test cases. So here what we are doing in this RTM, we are mapping the requirements with the test cases. That's what is RTM, right? RTM means mapping the requirements with the test cases. Client specified requirements should be matched with the mapped with the test cases. So why we have to map the requirements with the test cases? What is the purpose? There are two purposes here, okay? So there are two purposes why we are mapping the requirements with the test cases. The first purpose is, okay, initially when the software testers are creating the test cases, okay, when the software testers are creating the test cases, so we create this RTM to cross check whether for all the requirements the testers have created the test cases or not, okay, to check whether the test cases are created for all the client specified requirements or not, okay. Did we write the test cases for all the requirements specified by the client or not? To confirm that, we create an RTM. Okay, that is one of the purpose of why we create an RTM. So for example, you have written all the requirement IDs here, all the description of the requirements here, and here you have to fill up the columns with the third column with the test case IDs against these requirements. Okay, what if a requirement for a particular requirement test cases are not covered? Here you cannot fill up anything, right? So that's way you can understand that for this particular requirements test cases are not written, and software testers will go ahead and create the test cases to finish up this RTM. Okay, with the help of RTM, they can cross check whether for all the requirements test cases are created or not. If not, they are going to create it and finish up this RTM. Okay, that's what is one of the purpose of the creating the RTM. Okay, we can create this RTM in as simple as an Excel file, guys. Okay, in Excel sheet, in one of the Excel sheet, you can create this RTM, guys. Okay, here only for example, I created only 3 requirements, but in real time, an application will contain good number of requirements. For each and every requirement description will be there, and will be mapped with test cases. Okay, each and every requirement will be mapped with the test cases. What is the other purpose of the RTM? I explained you one of the purpose of RTM where testers have to check whether they have created the test cases for each and every requirement that is mentioned in this RTM. Okay, fine. That is one of the purpose. What is the other purpose, guys? Other purpose is to see how many requirements we have to test it. Okay, if you have to know how many requirements we have completed testing for. In that case, guys, so how can we know that how many requirements we have tested? So indirectly we can know. Okay, with the help of RTM, what we are going to do is we have to test all these test cases. Okay, you see here third column test cases are there. We are going to run all the test cases, and the results of the test cases we are going to provide here in a separate column. As you see, for test case ID status, this test case is executed and it got passed. This particular test case is executed by the tester and it got passed. Some of the test cases got failed also. Like this, we are creating the we are running the test cases. But here the purpose is to see how many requirements we have tested. So here indirectly with the help of RTM we can find it out, guys. Okay, when you run the test cases, indirectly we can know with the help of the RTM we can know how many requirements are covered. You see, since the test cases are here mapped with the requirements, we can know which requirements we have tested, right? To check whether we have tested all the client specified requirements by running the corresponding test case or not is another purpose of this RTM case. So hope guys, that is for traceability, right? For traceability of the requirements. Okay, we are tracing the requirements, like how many requirements we have tested. By running the test cases, we are checking how many requirements we have tested. Okay, that kind of advantages we get with the help of the RTM, that is requirement traceability matrix. So these are the two main purposes why we have to use or create RTM in our day-to-day projects. Okay, so fine. So who is going to create the RTM? Software testers. Okay, software testers are going to create the RTM for this particular purposes. Okay, for these two purposes. So hope guys you got the answer for this requirement traceability matrix from this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 65. That is, what is the link between requirements traceability matrix and the defects? Let me answer. Using the requirement traceability matrix, you can map the requirements with the test cases and defects. Software testers will create this requirement traceability matrix using which they are going to map the client specified requirements or client given requirements with the test cases that they have created and the defects they have reported. So I'll show you an example template for this RTM, which maps the requirements with the test case and the defects. Okay, there are a lot of templates on RTM. Okay, if you Google search, you'll get a lot of templates. But I'm going to use only such kind of template which is going to map the requirements with the test case and the defects. Okay, and this particular template, I liked it. Out of all the other templates that are there on the web, I like the template that I'm showing you right away here. Okay, so this is the template, guys, which I liked, which is actually mapping the requirements with the test case and the defects. Okay, as you can see here, the first two columns we have the requirements given by the client. Okay, client specified requirements are provided here. The requirement ID, their description. Okay, what the requirements are about. These two columns specify the requirements, and these requirements in this RTM are getting mapped. As you can see in this RTM, right, example template, the requirements are getting mapped with the test cases. Okay, that is test case IDs are provided here. This particular test cases belong to this requirement. This test case is written by the software testers belong to this requirement, and so on. So, and also the test cases will be executed, guys. Okay, the software testers will run the test cases, and the results of these test cases, whether the test cases are working fine or not, if they are not working according to the expectations, okay, if the application functionality is not working according to the test case expectation, they are going to fail. For example, here TC_LG_002 test case ID is failing, okay, due to a particular defect. Here, last one you see here, we are not only mapping the requirements with the test cases, but also with the defects case. Okay, for the failed test cases, we are reporting the defects. Defects are also mapped with the requirements. So what is the link between this defects? Why we are mapping the defects with this requirements and test cases here means? So by doing that, okay, by mapping the defects with this requirements, business, okay, the business only speaks about the requirements, right? They don't worry about the test case and the defects. Okay, so here business can decide the defects to be fixed before the release according to the requirement. By mapping these requirements with the test cases which are actually mapped with the defects, okay, indirectly we are mapping the requirements with the defects. So we can know that in this particular requirement, that's requirement_002, that is login requirement, we have a defect. Okay, like that we are mapping the requirements with the defects indirectly, and with this mapping, the business team can decide the defects to be fixed before the release. Okay, so since the defects are mapped properly with the requirements, they can understand which requirements have the defects and which requirement defects have to be fixed first. Okay, if before release, the business has to decide like which requirements need to be fixed. Okay, which should be working fine. So based on the requirement, kind of requirement, whatever the defects have to be fixed. Okay, whatever the application functionality should be stable according to the requirement, business can decide now. Okay, they can decide like Okay, this so and so requirements have these defects. They have to be fixed before, because these requirements need to be stable. Okay, after releasing it, releasing the before releasing the software into the market. Fine. So these are relation between the defects and the requirement traceability matrix, guys. In some templates, we actually map the defects with the RTM. Okay, in RTM we also map the defects. Okay, and this is advantage the business. Okay, business point of view, business team can understand which requirements have the defects and which defects have to be fixed, so that the requirements get stable. Okay, and before releasing the software into the market. And that is only the one of the purpose, guys. Okay, there may be other reasons behind that why we have to map the defects with the requirements. Okay, there may be other purposes also, like we can figure out like which requirements have the defects and all those stuff. Okay, so hope guys you got the answer for this question. What is the link between the requirement traceability matrix and the defects? Okay, so that's all for this session. In the next session I am going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 66. That is, what are the different techniques used in test design? Let me answer. First of all, what exactly are these test design techniques? Okay, what exactly are these test design techniques and what is the purpose of using this test design techniques? So using this test design techniques, we can derive the test cases that are required for our testing during software testing. On the top of that, we can optimize or select the data or finalize the data that is required for performing the software testing. Okay, using the test design techniques, we can derive the test cases required for testing and we can optimize the test data for performing the software testing. Okay, so these are the test design techniques. These test design techniques can be classified into three types. What are they? Black box test design techniques. Second type is experience based test design techniques. And third category of test design techniques is structured based test design techniques. In other words, it is a white box test design techniques. Okay, here black box, this is white box. And in between we have the experience based. So in case of black box, the code will not be visible, right? While you are deriving the test cases, the code is not visible. If you are deriving the test cases without having the code visible, such kind of techniques can be called as black box test design techniques. So what are the different black box test design techniques? We have different black box test design techniques like equivalence class partitioning, which is also known as ECP, which is called as ECP. Then we have the boundary value analysis, which is known as BVA, and decision table, state transition testing, and use case testing. All these black box testing techniques, okay, all these black box test design techniques are used by the software testers, okay, to derive the test cases and to optimize the data selection and all those stuff, test data selection for software testing. Software testers will use all these test design techniques, okay. Normal software testers will use it. Now coming to the experience based test design techniques, here not the normal software testers will use these techniques. These experience based design techniques are used by the experienced software testers. Okay, the software testers who have the good experience, okay, can use this experience based design techniques, and the purpose is same for deriving the test cases, for performing more testing. Okay, the purpose is same, but these techniques are used by the experienced testers. Okay, the one who has good experience in the IT software testing field. So error guessing, okay, these are the two techniques, guys, we have under the error based test design techniques, that is error guessing, and other one is the exploratory testing. Okay, this can be only done by the experienced testers, software testers. Now coming to the third type of test design techniques, okay, which is structured based test design techniques or white box test design techniques. These are used by the developers. Okay, developers use this kind of technique, guys. So there are several techniques under this structured based test design techniques that developers use it for deriving the test or to confirm the coverage of the test and all those stuff. That is statement coverage, branch coverage, path coverage, and condition coverage. Based on this, developers will derive the test sign kind of thing. Okay, so these are the three test design category techniques. Okay, these are the three categories under the test design techniques, that is black box used by software testers, experience based used by experienced software testers, and structured based used by developers for the same purpose, for designing the tests. Okay, statement coverage, branch coverage, path coverage, and condition coverage are structure. Error guessing and explore testing is experience based. Equivalence class partitioning, boundary value analysis, decision table, state transition testing, use case testing under black box test design techniques. So hope guys you got the answer for what are the different techniques used in test design. Okay, so that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 67, that is explain equivalence class partitioning with example. Let me answer. Equivalence class partitioning is one of the black box test design technique. So what is the purpose of this equivalence class partitioning? Why we have to use? The purpose of using this equivalence class partitioning black box test design technique is to filter out the finite possibilities of test data from the infinite possibilities of test data. Okay. From the infinite possibilities of test data that we can use for testing, from that we have to filter out the finite possibilities of test data without compromising the risk. Okay. Without compromising the risk. That is called as equivalence class partitioning. So if I explain about the equivalence class partitioning with example, it will be more clear for you. Okay. I am going to explain this equivalence class partitioning black box test design technique with lot of examples so that it will be more clear for you. Fine. So how this equivalence class partitioning is going to, is going to filter out the finite possibilities of the test data out of the infinite possibilities of test data without compromising the risk is something I'm going to show you with these examples. Okay. So after this, you will understand this line and you will understand the equivalence class partitioning without any problem. Fine. Let's start with one of the example, that is age field. So let me open this paint. So here I'll draw a diagram. Okay. So here guys, let's say there is a text box field and which has a label like age. Okay. There is a age with the age label. There is a text box field. This particular text box field accepts the age from some age value to some age value. Like for example, from 12 years to 25 years. Okay. This is the range. Okay. So this particular age box field will only accept the age from 12 to 25. So in such kind of cases, okay, in such kind of cases, if I have to test this age text box field, so if I am not using this equivalence class partitioning, what is the problem you are going to face? Okay, first I will not show you how to use equivalence class partitioning. Without using the equivalence class partitioning, if I try to test this age, how many possibilities are there? Let's see how many possibilities of the test data is there. Let's see, infinite possibility will be there. Okay, so if I have to test this without applying the equivalence class partitioning, infinite possibilities of test data will be there. So how? So I'll first start with 12 guys. Okay, I'll enter 12 into this age text box field. It should be accepted. Then I'll enter 13 into the age text box field and it should accept. Then 14, then 15, then 16, 17, 18, 19, 20, 25. Okay, 20, 21, 22, 23, 24, 25. All these values which are in the range should be accepted, right? It has to be accepted. If it's not accepted, we'll report a defect anyhow. Okay. So how many possibilities of the test data we got? From 12 to 25, we got almost like 12 to the 24, around around 13 amount of test data we got. Okay, 13 test data we got. But this is not enough, guys. Okay, what will happen if I give 11 here? If I try to enter 11 into this, which is less than 12, what will happen? It should not be accepted by the age. That means I have to enter the 11, right? Here already we got the 13 possibilities of the test data with a positive range, with a possible range, accepted range. Apart from that non-accepted range also I have to test. That is I have to test 11. Then I have to test 10. Then I have to test 9 and so on infinite. Okay. So minus 5, minus 10 and so on infinite. This list will not end, guys. Okay. The test data list will not end. So infinite possibilities of invalid data is there here. This is valid data. This is invalid data. Okay. 13 sets of invalid data in this example. And infinite possibility of invalid data is there. On the other side, guys, okay, if you take more than 25, that is 26, 27, 28, and so on, there is no limit here. Okay. This is infinite till infinite number. And here also we have the infinite possibilities of the test data. Not only this, what if you try to enter some alphabets? It should not be accepted. You can imagine, right, how much amount of infinite data is possible if you give alphabets, words, and sentences. If you enter here, right, that will infinite possibilities of invalid data coming to the alphabets and all. Okay, alphabets, etc. What about symbols? Infinite possibility of symbols and combination of symbols is there. That means there is how much possibility of test data that I can create for testing this age text box field. For testing this age text box field, which can accept the values from 12 to 25, I can prepare infinite possibilities of test data. But is this a good approach? No. We cannot test, right? Even though I give you 1 year also, you cannot complete the testing, because this much amount of data, if you keep on entering, after completing the year continuously 24/7, if you enter also, you will not be able to confirm that each text box field got tested properly. That's a problem. To overcome this problem, there is a black box test design technique known as equivalence class partitioning, using which we can filter out. Okay, we can filter out finite possibilities of test data out of these infinite possibilities of test data. Okay, without compromising the risk, without compromising the problem that a defect will be missed. Okay, and that is the equivalence class partitioning technique. Okay, test design technique, black box test design technique. So in case of age text box field, okay, so for example, the same text box field I am writing here, guys, age text box field. Okay, there is a text box field with the age. So if I apply the equivalence class partitioning for this age text box field, how many partitions you will get, I'll explain now. Okay, let's say this will accept the age from 12 to 25. In this case, we'll first create a valid partition. Okay, equivalence class partition means what? If I divide these three words here, okay, partition means, you know, right, you have to partition. Okay, partition mean one, not partition means what? Partitions means you have to partition, you have to separate. Okay, separation is nothing but the partition, right? This is one partition, this is another partition, this is another partition, this is another partition, this is another partition, and so on. Okay, these are the different partitions. So partitions, these are nothing but the partitions, separations. Okay, partitions are nothing but separations. Equivalence means what? Equal means equally you are dividing. Okay, you are making the partitions equally. This partition is equal to this partition, this partition is equal to this partition. That's why the name has given as equivalence class partitioning. Okay, different classes. Okay, this particular partition is a type of the partition is different. The type of the partition is different. That's why they are saying class here. Okay, every partition has its own type. That's why they are saying class. Equal class partitioning. Okay, kind of equally we are partitioning, and each and every partition of different type. That's why the name is coming as equivalence class partitioning. So if I apply the equivalence class partitioning to this age field, which is accepting the values from 12 to 25, instead of using this infinite possibilities of test data, I'm going to filter out this infinite possibility of test data to the finite possibility of test data. How? First, one of the partition, I'll name that as valid partition. In this valid partition, what is the accepted range, guys? What are the accepted values in this age field? 12 to 25, right? Any of the random value you take, okay, from 12 to 25, any random value you take. For example, if I take 19, okay, 19 falls in between this 12 and 25, right? In this range, 19 comes in this 12 and 25. If I enter 19 into this age field, the age field will be accepted. The age field will be accepted, right? The 19 value will be accepted by the age field. So I will not test with 12, 13, 14, 15, 16. I will not test with all the values. I'll only take one of the value in this range and take that as valid partition. In that valid range, I will take only one value, which is of valid type, and give that. This is a test data, guys. Okay, I filtered out this valid range into this only single data. Okay, single valid data. After that, I'll give another one as invalid range. Invalid range means which is greater than 25. Okay, starting from 26 to infinite number, any random value you take. Okay, any random value after 25 you take. That can be anything, guys. Okay, it can be like as simple as 75. Okay, if I give 75, which is above the 25, okay, this invalid partition is coming. So this is invalid. If I give 75 here, age will not should not accept, right? So one of the test data I got, I will not test all the infinite numbers. Okay, I'll only go with one of the random value out of this infinite range, infinite invalid range after the 25. And below the 12 also, I'll get infinite possibilities 11, 10, 9, 8, 0, minus 5, 9, minus 10, and so on. Okay, infinite. So from that invalid range also, from that lesser than 12 infinite range also, I'll only take one value. Okay, let's say I'll take some value like minus 6. Okay, minus 6 I'll take randomly. Fine. So here we got three partitions already. One valid partition, two invalid partitions. On the top of that, if you still want to create more partitions, it's okay. You can create this. Okay, you can create more partitions. For example, what will happen if you give alphabets here? If I give ABC, it should not accept, right? Only numbers should be accepted. So ABC will be restricted here. And what about if you enter symbols? Let's say symbols. Okay, symbols. If you try to give some symbols here, dollar. Okay, dollar hash kind of symbols, it should not be accepted. Symbols should not be accepted. Only this 12 to 25 should be accepted. So this is another invalid. So there are infinite possibilities of symbols and symbol combination, but I am only giving one random invalid test data to test as part of the symbols. Okay, to test as part of the alphabets, entering alphabets into the age, I'm giving only one random value. There are more possibilities. DEF is possible, ARUN is possible. Okay, testing is possible, everything is possible, but I'm only taking one sample data out of that random range. Okay, so what else is there? Okay, so I can give one more invalid also. I can give, let's say, out of my out of box thinking you can do, where you can give something like combination of alphabet dollar, I mean symbol alphabet and some number. If I give, what will happen? It should also not accepted. Okay, H field should not accept this invalid data also. So how many partitions I am able to create here? 1, 2, 3, 4, 5, 6. Total how much? How many sets of test data I got here? How many sets of test data I got, guys? 1, 2, 3, 4, 5, 6. Only 6 sets of test data out of the infinite possibilities of test data. If I keep on testing this infinite test data with this H text box field, more than in year also you will not be able to test this field. But if you apply the equivalence class partitioning, this entire infinite test data is filtered out to just 6 sets of test data. Six test data, that's it. Okay, you see how much time will it take for you to test this particular age field with these 6 sets of data, where one is valid and remaining all are invalid. Only valid should be accepted by the age field, whereas all this invalid should not be accepted. This invalid should not accepted. We are simply testing that it should not be accepted. Here, this 2 invalid also should not be accepted. Only this valid partition should be accepted. Okay, then only the age text box field is working fine. So this is what is the equivalence class partitioning, guys. Okay, we can apply the equivalence class partitioning to different examples. Okay, here I explained you with the age text box field. What if there is a situation where in real time you have to test a field, okay, where you can enter a mobile number, okay, mobile number text field is there, which can accept the mobile number. What will be the generally the size of the mobile number is 10, right? 10 digits. For example, if I give one mobile number 912124545 6. Okay, how many digits are there here? 1 2 3 4 5 1 2 3 4 5. This is a 10-digit number can be entered into the mobile, because mobile number should be of 10-digit sets, let's say. Okay, a 10-digit mobile field number this is. Okay, into this we can enter the 10-digit mobile number. That's what is the testing. So here infinite possibilities are there for testing this, right? Okay, so but I'll apply this equivalence class partitioning, where first I'll create a valid partition. In the valid partition, I'll give a random phone number, mobile number, which is of the which is having 10 digits in size. Okay, a random mobile number which is having 10 digits. Okay, this is a random number I'm giving. 91212454556 is a number. One random, because there are infinite possibilities. I'm only taking one number here. What about invalid? Here, the size of the mobile number is how many digits? 10 digits, right? 10 digits. What if I give more than 10 digits? That will be definitely invalid, right? If I give something like this and add 1 to here, append 1 to here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, total 12 digits are there. 12 digits should not be accepted by this mobile number field, okay, which is of greater size than 10 digits. Here the size, guys, okay, the size of the number is important here. Okay, the size of the number that you are trying to enter into the mobile field is important. Here it's not about the range of values, it's about the size of the number is important. How many digits the number is there, that is important here. Okay, in this example we have to create the equivalence class partitioning with the help of the size, guys. Okay, size of the numbers. So here if I give 12 digits, it should not accept. 10 digits it should accept. Again here if I give some less number of digits than 10 digits, for example if I give here 3 1 2, will it be accepted? It should not accept. Mobile number should be of 10-digit size, but here only 3 digits, it will not be accepted. That's why it's invalid partition. On the top of that, guys, we can test by entering some text symbols into this mobile number field. Okay, we can create few more invalid partitions here. One more invalid partition I'll create here. Like this, I'll create invalid partition where I'll try to enter some alphabets, guys. Okay, so already the type of the data is what here? Number, right? The size of the data is 10. The type of the data is number data. Number data size is 10. Here number data wise we created the partitions, but here the type I am changing. I'm changing the type from numbers to alphabets. Okay, A B C D E F G H I J. How many are there? 1 2 3 4 5. 1 2 3 4 5 are coming. Okay, alphabets. The size is 10. Okay, this particular alphabets are matching the size, but these alphabets are not digits. So that's why it is invalid. Even though size is 10, but still these are alphabets, so it should not be accepted. This much is enough, guys. You don't have to go beyond that. Okay. So invalid. Some symbols I'll give, but I'll stick to size 10. But here instead of digits, I'll give symbols. Okay. $X exclamatory mark at the rate symbol. Okay. Dollar percentile, like this. Some symbols I'll give. Okay. Of size 10 I'll give. Okay. Number of characters 10 I'll give, but they are not digits, but they are symbols. 1 2 3 4 5 1 2 3 4. Two more I have to give. Let's say I'll give like this. Okay. So this is of size 10, but the problem is here digits are there, but you are giving what? Symbols, which will not be accepted by the mobile number field. So how many sets of data I got for testing this mobile number field now, which will accept the 10 digit size of number? I got 5 partitions, 5 sets of data I got. Okay. Instead of testing this mobile number field with infinite sets of data, you're going to test this particular mobile number field with just 5 sets of data. Okay. I'm giving more and more examples so that you will get used to equivalence class partitioning, guys. Okay. You'll be able to answer the this particular question if it comes in the interview well, if, with these examples. Okay. So like that, other things are possible, guys. Only positive numbers, only credit cards. Okay. 10 to 20 alphabets. Lot of examples are there here. Okay. Which is a combination of ranges and size. Lot of things are there. Here it's a range. Okay, this is a range. Just 12 to 25 is a range. But here mobile number is a field of which type? Size type. Okay, size and type. Type is number, right? Type is number. Size is 10 digit size. Okay, 10 is a size. Type is a number type. Okay, but in coming to the only positive number, already this is completed, guys. Okay, uh, this example is already completed, which has 10 digits only. Is mobile number will be 10 digits only, where both combination of size and type is already explained. Okay, we are left with 3 more items. Okay, we are left with 3 more items, where only positive numbers, only credit cards, 10 to 20 alphabets. 3 examples I am going to give you. Okay, so only positive numbers. Let me explain. Only positive numbers. Let me give only positive numbers. For example, there is a text box field, okay, which will accept, okay, there is a text box field which will accept only positive numbers. Which, okay, some number you have to enter into the text box field, but it can be any number. It should be a positive number. Okay, positive numbers are accepted. Let's say, okay, positive numbers are accepted. In that case, valid partition I'll give, and I'll give a random number here. I'll give a random number here, guys. Any random number you give for this positive number. Let's say I'll give 894. Okay, is a random number I gave. Okay, with this I will test positive number. But here I'll give an invalid partition where I'll give a negative number. Okay, minus 59. Okay, which is an invalid number. Negative should not be accepted. That's why. Okay, so here only numbers are accepted. Number means type is number, right? Only number should be accepted. In that case, what I will give? In that case, I'll give another invalid saying, what if I enter alphabets? What if I enter some alphabets? A, B, my name I will enter. It should not accept. Another invalid. I'll give some symbols. Okay. I'll try to enter some symbols as this partition data. I'll say, okay, some symbols I'll enter. All these are invalid partitions, right? All these are invalid partitions. So here, how many sets of partitions we got? How many sets of data we got? Only 4 sets we got for testing this positive number field. Okay. So this is how we test a text field which will accept the positive number. Now we have the credit cards. Okay, coming to the credit cards. Let's say there is a, okay, there is an application functionality, guys, where only credit card should be accepted. Okay, there's an application functionality where only credit card should be accepted. Other things should not be accepted. So here you can only select the credit cards. Okay, in that particular fields or whatever it is, you will only select the credit cards. Okay, but other things should not be accepted. So here what you will do here is only credit card means what you will do here is first you will create a valid partition here. Okay, for testing this using the for right, filtering out the finite possibility of data with the from the infinite possibility of data. What I will do here is, out of all, there are different bank companies, right, for credit cards are there, like HDFC Bank credit card is there, ICICI Bank credit card is there, Axis Bank credit card is there, SBI Bank credit card is there, S Bank credit card is there. Different banks credit cards, American Express credit card is there, Citibank credit cards are there. But I'll only take one of the credit card I will take. Okay, only one. Let's say HDFC credit card I will take. Okay, HDFC credit card as a sample. Okay, as a sample data for test data for this valid category, I'll only take HDFC credit card by ignoring the other type of credit cards. Okay, this is how I test. Then invalid, if you apply equivalence class partitioning to this particular functionality where credit cards can be selected and the other payment options are not selected, in that case, here invalid is debit cards. Okay, I'll take one, let's say Axis Bank, Axis debit card as a sample test data I'll take to test this invalid category, which should not be accepted here. And other invalid I'll take. This time, instead of debit card or some cards, I'll take a net banking. Okay, I'll try to pay using the net banking. I'll take some ICICI bank net banking. Okay, I'll try to pay via it should not be accepted by this functionality. Okay, because only credit cards are accepted, so net banking should not be accepted. Then another data, what I will get, invalid partition, what I will get, guys. So cash on delivery, okay, COD should not be accepted. Like that, all these invalid partitions we can create. How many partitions we got? 1, 2, 3, 4. One more invalid partition you can think of, right? In real time, what is another partition you may expect? Another partition you may expect is UPA, right? Okay, that is you can use some wallets, UPAs, and all those stuff. Okay, UPIs and wallets like like Google Pay and whatever it is. Okay, so here instead of writing UPI here, I'll say Google Pay otherwise. Okay, I'll write Google Pay. That will be the correct data. Here we have to give the test data, guys. Okay, we should not be randomly writing that. I'll say Google Pay. Okay, Google Pay. I'll say simple, done. So 1, 2, 3, 4, 5. Total, how many sets of data we got? 1, 2, 3, 4, 5 sets of data. With this, we'll complete the testing. This is how we can filter out the finite possibilities of test data out of the infinite possibility of the test data by applying the equivalence class partitioning. Now, last option, guys, last example I'm going to give you for making you guys understand what exactly is equivalence class partitioning, how many situations you will get in real time where you can filter out the data using this equivalence class partitioning. Last example I'm going to give you, that is 10 to 20 alphabets. Okay, 10 to 20 alphabets. So let's say there is a field, guys. Let's assume that there is a field. Okay, let's assume that there is a field which can accept the test data. Okay, which can accept the data which is having 10 to 20 alphabets. Okay, 10 to 20, 20 to 20 alphabets can be entered. Okay, so here size is there, right? One of the item is range. Sorry, 10 to 20 means it's not size, guys. It's the range, right? 10 to 20 range, size and range combination. You can say it is a range, size, and type combination. Okay, this is a combination of three things. Here 10 is the size. Okay, allowed size is 10, allowed size is 11, but that size is in the range. Okay, it's kind of complex situation where size is actually specified in range and the type is also specified as alphabets. So if I have to give this valid partition here, if I have to create a valid partition for testing this particular text box field which will accept the 10 to 20 alphabets, then first type is important, alphabets is important. Okay, and what should be the range and size of that alphabets? The size of that alphabet text that you are trying to enter into this field should be in the size of 10 to 20. I'll take some random one, 13, let's say. Okay, I'll create something like this: A, B, C, D, E, F, G, H. Okay, how many came already? 5, 8, 9, 10, 13. Okay, size 13 I gave. 13 size, which is in the range, right? 10 size range to 20 size range. 13 is in the range of 10 to 20, and size is also matching. Type is also matching. Alphabets are matching. So this will be accepted, valid partition. If I have to give invalid partition, what I have to give? So I'll give out of this range. Okay. So here 13 is there, but I'll give out of the range. That is A, B, C, D, E, A, B, C, D, E, A, B, C, D, E, up to this 15, A, B, C, D, E, 20, A, B, C, D, E, 25. 25 should not be accepted, right? That is invalid. This side also I'll create an invalid based on the size and range. Okay, based on size and range, I'll give an invalid thing. That is, I'll give just ABC, which is less than 10, right? Less than 10 size. And also it's not falling in the size range. So ABC will not be accepted. So invalid. And on the top of that, what if I give valid size range, but invalid type? That is, I'll give something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. How much size this is? 10. 1, 2. Okay, something like this if I give 12, size is 12, which is falling in this range, but type is different. So it will be invalid. Another one, another invalid. I'll give something like this. dollar hash @ okay, exclamatory mark and hash dollar percentile and how many came already? 1, 2, 3, 4, 5, 6, 7, 8, 9 came. 9, 10, 11, 12, 13, 14, 15. Okay, 15, which is in the size only. Okay, which in the range. The size is matching, but type is not matching. Alphabets here, symbols are there. That's why it's invalid. How many sets of data we got for testing this text, this particular field? 5 sets of data are enough. You don't have to give infinite. You don't have to test this field with infinite possibilities of test data. Rather, you can use this filtered out. Okay, finite possibilities of test data out of the infinite. We have filtered out using the which test design technique, black box test design technique. That is none other than the equivalence class partitioning test design technique. So guys, with these examples and all, now I hope that you'll be able to easily answer this question if you get this in the interview. If someone asks you in the interview, like explain equivalence class partitioning with an example, you see, with this session, you should be in a position to answer it at any cost, guys. Okay, there is no other way of escaping. So many examples I gave, right? So many examples I gave from the beginning and end. Okay, too many examples I gave. Whatever the example you get in the interview, you will be able to answer with this explanation, right? No matter what, you can answer the question now. So that's all for this session, guys. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 68, that is explain boundary value analysis with an example. Let me answer. Boundary value analysis is one of the black box test design techniques, and it is an extension of another black box test design technique known as equivalence class partitioning. But what is the purpose of boundary value analysis? The purpose of using the boundary value analysis is same as the purpose of using the equivalence class partitioning. That is, the purpose is to filter out the finite possibilities of test data for testing the software from the infinite possibilities of test data. Okay, out of the infinite possibilities of test data that we can use for testing the software which is possible to test. Okay, using this boundary value analysis and equivalence class partitioning test design techniques, we are going to filter out the finite possibilities of test data which we can use for performing the testing without compromising the risk of software. Okay, without compromising the risk. That is what is the purpose. Okay, so already equivalence class partitioning test design technique is able to filter out the finite possibilities of test data from the infinite possibility of test data which is not possible to test the software. But why again boundary value analysis is required? It is required for a purpose. Okay, let me give you an example, guys. Okay, let's say there is a text field, okay, which will accept the age. Okay, let's assume that there is text field which will accept the age from 18 years to 25 years. Okay, let's say there is a text field which accepts the age of a person from 18 to 25. In this case, if you apply the equivalence class partitioning, okay, in this case, to filter out the finite possibilities of test data out of the infinite possibilities of test data, if you first apply this equivalence class partitioning, black box test design technique, in that, how do you apply? First, you will create a partition here as part of ECP, guys. This is okay. If as part of ECP, how do you apply the test design technique here? First, you will say valid partition. You will create a valid partition. Here, in this valid range, that is 18 to 25, you will pick some number. Okay, out of this range, in this particular range, you will pick some number. Let's say I'll pick some number like 22. Okay, 22 falls between 18 and 25, right? In this range, it is applicable. Okay, one valid test data from this 18 to 25 age I took. Okay, if I enter this 22 into this age field should accept that. Okay, it should work. Then only the field is working fine. I can test. Okay, this is a test data, guys. Okay, valid test data. Now, similarly, I'll create an invalid test data where I'll take a random number which is above 25. Above 25, this age field should not accept, right? After 25, it can be 26, 27, 29. Infinite possibilities of test data are there. But I'm not going to test this field with all the infinite possibilities of test data, right? Above 25, some random value I'll take. Let's say I'll take a value like 76. Okay, about 25, some 76 random value. I'll not test with each and every infinite possibilities. I'll only take one random value about 25 and try to test that, its age field will reject this 76, right? Because only 18 to 25 are allowed. If I give 76, it will not accept. That's fine. Now this side also I'll create another invalid, okay, invalid partition where I'll give a age which is less than 18. Okay, less than 18 can be 17, 16, 15, 14, 13, 12, 11, and so on. 0, -1, -10, -20, -100, and so on, infinite. Again, infinite possibilities of values are coming. Test data is coming. Out of that infinite possibilities, I'll take some random value. Let's say I'll take a random value, say 5. Okay, which is below 18. So this 3 test data is enough for testing this age field as part of ECP. ECP means equivalence class partitioning test design technique. If you follow, you can, okay, filter out the finite possibilities of test data, okay, using ECP test design technique, black box test design technique. Using this particular ECP, that is equivalence class partitioning test design technique, we can filter out the finite possibilities of test data for testing this particular age field out of the, okay, out of the possible infinite possibilities. Okay, if I don't apply this, I have to test with lot of values, 18 to 25, 18, 19, 20, 21, 22, 23, 24, 25. Okay, 8 values I have to test. And about 25, 26, 27, 28 to infinite possibilities. Below 18, 17, 69, infinite, which is not possible to test, right? So we have to apply ECP where we will filter out the finite possibilities of test data out of the infinite possibilities of test data. Okay, this is one step. But for example, there is a, let's assume that this particular, okay, let's think that there is a text field for which the developer has written the code. Let's say developer has written the code in one of the programming languages. For example, I'll assume Java code I'll write, public static void, some Java code I'm writing, guys. Assume that the developer has written this code for accepting the data into the text box field, which will accept only 18 to 25. For that, how the developer would have written the code. You don't need to know Java, guys, for understanding this. At a high level, you understand, okay? Main, this is how we write the code in Java. But if you don't know Java, no need to worry. You will be able to understand still, okay? Just understand this code at a high level, okay? This one, I'll just make it big. And inside the main method, the developer will write something like this. That is, the developer will write if, okay, if age, okay, if age, some age is greater than or equal to 18, okay, if age is equal to greater than or equal to 18 and age is less than or equal to 25, if the developer has to properly write the code for the above text box field, which will accept the age of a person from 18 to 25, then the developer has to write this if condition like this. Okay, if age is greater than or equal to 18 and age is less than or equal to 25, then here some Java code for accepting the age. Accepting the age should be written. Otherwise, the age should not be accepted. This is what is the code generally the developer has to write behind this text field to accept the age from 18 to 25. But assume that developer by mistake has forgot to provide this equal symbol here. This is a common mistake that the developers will do, guys. Okay, a common mistake any developer will do is, okay, in these conditions, okay, they'll write the logic well, but in a hurry or something, they will forget to provide this equal symbol. What happens with this common mistake? Will the ECP, that is equivalence class partitioning, will be able to find this particular mistake done by the developer while writing the code for this text box field? No, it will not be working fine, because you see, as per the ECP, how many sets of test data we got? 3 sets of test data we got. Let's try 5 here. If 5 is passed to the age, 5 is greater than or equal to 18. Is 5 greater than or equal to 18? No. 5 less than 25? No. If 5 less than 25 is true, but this part is false. False and true means it will become false. So the age will not be accepted. Okay. Age here 5 is not greater than or equal to 18, right? If this particular condition is failing, so this if condition will not run, the block will not be executed, and the age 5 will not be accepted. So this age will be rejected. Anyhow, this is invalid. That is the correct process. Okay. As per testing, it's working fine. Now, if we give the second partition data, that is valid test data 22, 22 is greater than or equal to 18, true. This condition is true. And 22 is less than 25, this condition is also true. Here 22 will be accepted. 22 will be accepted as it is valid data, it has to be accepted. Invalid data should not be accepted by this age field. Valid data should be accepted. This is working fine. Now, here if we give 76 to this particular code, 76 greater than or equal to 18, 76 greater than, this condition is true, but 76 less than 25 false. Since one of the condition is false, this condition will become false, and here 76 will not be accepted. 76 is an invalid data which will not be accepted. So far testing is fine. We are able to test this software, but any of these values, any of this test filtered out test data by this ECP were able to identify this problem where developer is missing this equal symbol. By mistake, developer has forgot to, or in a hurry, he or she didn't put the equal symbol here. Were this test data able to identify the defect in this particular program, which is written for this text field? No, that's the problem with ECP. That's where what we have to do here is, since most of the problems will come in the boundaries, okay, here equal symbol is all about boundary, right? Most of the problems in the code, while developer writing code will come in the boundaries, okay? The boundaries will get the defects. But ECP is not testing the data around the boundaries, okay? Around the boundaries, ECP is not testing. It's randomly picking some equivalence class partitionings, and it's giving the data to complete the testing to filter out the finite possibilities of test data out of the infinite possibilities. But the testing is not completed here. Hence, we have to use another test design technique known as boundary value analysis technique, which is an extension of the ECP, which also covers the test data, which also filters out the test data for the boundaries, testing the boundaries. Okay, that test design technique is known as BVA, that is boundary value analysis test design technique, black box test design techniques. So on the top of ECP, we have to use BVA. We have to extend this partitions with BVA. Then we'll get more test data, using such kind of test data, which is an extension of ECP, that is ECP plus BVA filtered out test data, we'll be able to find these mistakes that happen at the border in this kind of program. Because generally, guys, developers make this kind of mistakes with the border values. Okay, that's the problem. So let's apply the BVA, which is an extension of EC2 to this existing partitions here. Okay, to this existing partitions which are created by ECP, we'll extend this ECP partitions with BVA. How means, here for this valid partition, okay, around the valid partition, what are the borders here, guys? 18 and 25 are the borders, right? Let's write 18 here. Okay, here I'll write 18, and on the other border I'll write 25. Okay, 25. These are valids only, right? 18 and 25 are valid. Okay, otherwise we can write inside this also. You can write like this also. 18. You can write 25 because these are valid range, right? 18 is a valid and 25 should be also be valid. These are the border values which are valid. So now, not just writing 18, 25 here, we have to add number 1 to 25. What will come? 26. 26 will fall into which category? 26 will fall into the invalid category because 26 should not be accepted by the age field. Up to you, 25 only accepted. Now you have to reduce the number by 1. 25 minus 1. How much you will get? 24 you will get. Okay, you will get 24. 24 falls into the valid category. These three are the boundary values we got. Okay, these three boundary values, extra boundary values we got by applying the BVA. Okay, apart from this 5, 22 and 76 which we got from ECP, by extending that ECP with the BVA test design technique, we got extra 3 boundary values at this level. Not only that, guys, we have one more. Okay, another boundary is there for this example. 18 is there. So what we have to do here is 18 plus 1 we have to do. Okay, 18 plus 1, how much will come? 18 plus 1 means here 19 will come. 18 plus 1 is 19 will come here. Okay, 19 will fall into the valid category, whereas 18 minus 1 you say. 18 minus 1 means how much? 17 will come. So how many boundary values again we got here? This side boundary, again we got 3 more boundary values. Now, earlier when we applied this ECP, black box test design technique, to this field for this test, infinite possibilities of test data, we got 1, 2, 3 sets of data. Now, along with this 1, 2, 3, we got extra 1, 2, 3, 1, 2, 3, extra 3, 3. Total how many? 3 plus 3 plus 3. Total 9 sets of data we got. Okay, when we extended the ECP with BVA, this time we got, okay, with ECP we got 5, 22, 76, but by extending the ECP with BVA, we got 6 more sets of data, that is 17, 18, 19, 24, 25, 26. Okay, 24. Boundary values we have to plus and minus. Boundary value we have to plus and minus for the valid range. Okay. Then we'll get the BVA test data. Total 9 sets of data we got. Now test it. Okay. If you enter 5 here, 5 will not be accepted. You already know. If I enter 17 here, 17 is greater than 18 is false. Hence, since one of the condition is false, it will not accept 17. 17 also will be rejected. Now coming to the 18. If you give 18, yes, 18 equal to 18 is true. Okay, here condition is matching. Hence, 18 will be accepted. Now 19. 19 is greater than 18 and 19 is less than 25. This also will be accepted. Then 22. 22 is already accepted. We have seen that. Now 24. 24 is greater than or equal to 18 is true and 24 less than 25 is also true. So 24 also will be accepted. Then 25. Then 25. 25 is greater than or equal to 18 is true, but 25 less than 25 is false. 25 equal to 25 should be there. 25 less than 25 is false. 25 is not being accepted despite of it being a valid range. Okay, despite of it being a valid test data, 25 is not getting accepted by this program. That means there is a defect in this program. Okay, there is a defect. The developer has done a mistake while writing the code that we as software testers, while applying this BVA, we got this boundary value. When we tested with this boundary value, we got this defect. We'll report this particular defect saying that age field is not accepting the valid data, that is 25. This is only possible with BVA, guys. ECP was not able to find this problem, but BVA, when extended with ECP, is able to find this problem in the code. Remaining all will work fine, right? This will be 26 will be rejected or 76 will be rejected. Okay, but 25 has actually this boundary value with the help of BVA which we have generated is able to find the problem in the program, is able to find the defect in the program. Once we report this particular defect to the developers will correct the mistakes by simply putting equal symbol here. Okay, simply they will add equal symbol here and the program will be working fine. And BVA was the only thing that was able to find the problem in this program. So hope guys you got the idea, right? How the why BVA is required and why BVA has to extend ECP for filtering out the more finite possibilities of test data from the infinite possibilities of test data without compromising the risk. Okay, this is what is BVA, which is one of the black box test design technique. So hope guys you got the answer for this question now, and you will be able to answer this question if you get in the interviews. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye.
Hello all, welcome to this session. In this session, I am going to answer software testing interview question 69, that is explain decision table with example. Let me answer. Decision table is one of the black box test design techniques. There are several black box test design techniques like equivalence class partitioning. We have boundary value analysis. We have decision table, state transition testing, and use case testing. These are the different black box test design techniques. And in this black box test design techniques, decision table is one of them. But what is the purpose of this decision table? Using decision table, we can derive the test cases for a particular functionality by checking the possible combinations of testing it. Okay. So using the decision table, we are going to derive the test cases for a particular functionality based on what? Based on the possible combinations of testing that functionality. Let me give you example so that you will understand the purpose of this decision table. Okay, there are several examples I am going to give in this session, using which can understand what this particular line is all about. And also, decision table is called as cause effect table. Okay, some people call decision table as cause effect table. Okay, both are same. Cause effect table and decision table both are same. So I was saying about the examples, right? So using these examples, you will understand this particular line well. Okay, what are that examples? So I created 3 examples so that you will understand how to use the decision table on a real application. Okay, so first example is login functionality. For example, if I take you to an application having the login functionality like this, okay, if I take you to an application having this login page kind of stuff where username, that is email address and password are there with the login button, here 2 fields are there. So for this particular functionality, we can apply decision table test design techniques to derive the test cases. How? I'm going to derive the test cases based on the possible combinations of testing these 2 fields together. Okay, so what are they? If I can show you this diagram, you can see, okay, what are the possible combinations we have? So I'll create this kind of table, guys. You can create this kind of table in Excel file if you want, like this. Okay, you can create this kind of decision table in an Excel file if you want. Okay, so here in the first column I mentioned conditions by output. Okay, so under this conditions by output I'll provide the field names. So here in this login functionality we have the email address field and password field. I have written them here. The possible combinations of this email and password will result in some output. Okay, that I'm going to use for deriving the test cases using this decision table. So first case is combination of email and password where valid email will be provided and valid password will be provided. Okay, if I provide valid email and valid password, what will happen in the application? If I provide valid email and valid password and click on the login button, I should get logged in, right? This is the first test case. Okay, we are deriving this case one, that is the first test case. And coming to the second test case, guys, we will give valid email address but invalid password. Okay, what should happen in case of valid email address but invalid password? For example, if I give valid email address but invalid password and try to log in, I should get a warning message. The same thing is mentioned here. This is a second test case for testing this login functionality. Okay, where I'm going to derive the test cases for testing the login functionality by using the possible combinations of testing the functionality, that is email password. So in the case 3, I'll give invalid email address and valid password. Same thing will happen. You should get a warning message. And final case is where I'll give both email address and password as invalid. Still, I should get the warning message. Okay. Only in case, in the first case where I provide the valid email address and valid password, it should allow me to log in. This is the first test case. So total, how many test cases I got? Okay. How many test cases I got? 4 test cases. First test case, second test case, third test case. Case 4 is the fourth test case. A few more examples for you apart from this login, that is uploading a file. Okay, let's assume that on a particular application page, there is a upload file functionality. You see, this is upload file functionality where you have to browse for a particular file and choose try to upload that. Okay, you have to upload the file. So in that case, guys, how to apply this? Okay, how to apply this decision table? So here I created another sheet where we have this decision table created for testing this upload file functionality. So assume that this particular upload file functionality, will only intake JPG files, and also there are some restrictions related to a file. Okay, that is, this particular upload file functionality can only accept the files whose size is not more than 32 KB. Okay, up to 32 KB, the size of the files are allowed to upload, and also the type of the file should be JPG file. Other formats will not be allowed. If such is the case of the functionality, how to test such kind of upload functionality which only accept the JPG files and which only accept the files up to 32 KB and not more than 32 KB. In that case, if I have to create a decision table, I'll be creating like that. Under first column, that is conditions by output, I'll provide the file type. Okay, which type of files the upload file functionality will accept. And second one is the size of the files that upload file functionality will accept. These two conditions I'll provide here. And the first test case, that is case 1, I'll give valid file type and valid file size. Okay, valid file type is JPG and valid file size is up to 32 KB, less than or up to 32 KB or allowed. So when I upload these two things, you see the file will get uploaded. But in the second test case, okay, I'll give different combinations where I'll give valid file type but invalid size. Okay, that is greater than 32 KB, it should not allow. Error should come. Okay, relevant error should come. The third test case, I am not going to give the proper file type. Rather, I am going to give not JPG means it can be PNG or other formats. Okay, but size is correct only. Valid size is. Still, I have to get the error because I am not giving a proper file type. The last case, I'll give both invalid types. Okay, invalid type and invalid size. Okay, so not JPG. If I give PNG here and or Word document or whatever it is, and here if I give the size, this is like less than or equal to. This is greater than or equal to. Sorry, this is I have to make it greater than. Actually, there's a small mistake in this. Okay. So greater than or equal to. Okay, both should be invalid. Okay, it should be greater than, otherwise. Okay, it's equal to will not be there. Not JPG and greater than 32 KB. In both the cases, we should get the error. Okay, invalid. This is the right one. Now, guys, the last one, another example I'm going to give, that is So here, let's assume that there is a functionality, guys. Let's assume there is a functionality and there is a form. Okay, similar to login page functionality, there is a form which have 3 fields, and there is a button or something on this page or form. Okay, that first field is, you see, let's say you want to travel to US. Okay, what are the 3 things that are required? A valid visa should be there, valid passport should be there, and valid ticket should be there, right? 3 items. So here, let's say there's an application functionality where you have to provide the visa number, visa details, and here you have to provide the passport details, and here you have to provide the ticket, flight tickets. Okay, then there is a button like check button. Okay, let's say check these details kind of button is there. Okay, if all these 3 things are valid only, you will be approved to go to US or something. Okay, so in that case, guys, first test case, how I'll write, I'll say valid visa, valid password, and valid ticket. Otherwise I'll show you here. Valid visa, valid passport, and valid ticket. So all are valid, so allowed. The second test case we have is invalid visa, valid passport, and valid ticket. This is another combination, which is not allowed, guys. Only when all the 3 are valid, allowed. Remaining all cases, you see here, we are not getting just 4 test cases. We are getting 8 test cases because the number of conditions are more. The number of conditions are more. In that case, more test cases we can derive using this possible combination. Okay, if all 3 are valid, then only allowed. If any one of the thing is invalid, like invalid valid valid, or valid invalid valid, or valid valid invalid, valid invalid invalid, invalid valid invalid, invalid invalid valid, and invalid invalid invalid, all these cases, you will not be allowed to travel, whereas only in the first test case you'll be allowed. So totally 8 test cases I can derive from this kind of functionality. Okay, so this what is a decision table, guys. Hope you got the idea what exactly is a decision table here. Okay. So now let's go back to the definition or purpose. Okay, let's understand the purpose after I demonstrated the example. Now you should be in a position to understand what is this line states. So decision table, the purpose of the decision table is to derive the test cases for a specific functionality or a particular functionality by checking the possible combinations of testing it. Okay. So here we derived the test cases based on the possible combinations of testing the functionalities, right? Possible combinations of testing it. These are the possible combinations, and this is called as decision table. So hope guys you got the answer for what exactly the decision table with several examples have demonstrated. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 70. That is, can you explain defect life cycle? Let me answer. There are different defect tracking tools available in the market. Different defect tracking tools follow different defect life cycles. That means Jira defect tracking tool has its own defect life cycle, whereas Zoho defect tracking tool has its own defect life cycle. There is no common defect life cycle for all the defect tracking tools available in the market. Every tool has its own defect life cycle. That's what is the problem. For example, here you see this is the Zoho defect tracking tool. Okay, in this, if you report a defect, what are the different states available? Here, open state is there. Then after that, we have in progress, to be tested, closed, and also on the top of closed, we have reopen. Okay, 4 to 5 states are there in this Zoho bug tracking tool. But if you Google search for Jira defect lifecycle, you'll get this in the search results, guys. As you can see here, many states are there. Okay, in Zoho defect tracking tool, there are 4 to 5 states. But in Jira defect tracking, okay, in Jira defect lifecycle, we have more states. Here, 4 or 5 are not there. You see, new is there, assigned is there, fixed is there, reopened, rejected, deferred, duplicate, verified, closed. Many states are there. That means different defect tracking tools follow different defect life cycles. That's the problem. So if you get this particular question in the interview, can you explain defect life cycle? You have to mention this point that different defect tracking tools follow different defect life cycles. For example, Jira follows a different defect life cycle. Zoho tool follows a different defect life cycle. But I am going to answer this question with a common defect life cycle. Okay, that most of the defect tracking tools follow. Okay, So you have to mention that in the interview, guys. Okay, whenever you get this question in the interview, you have to mention that I'm going to answer or explain about a defect life cycle, which is commonly followed by most of the defect tracking tools. Either it may be Zoho or Jira or whatever it is. Most of the defect tracking tools available in the market follow this particular defect life cycle. You have to mention and then explain. Then the interviewer will understand what you are trying to mention. Okay, he'll know that you know the answer because of that statement. Now you after mentioning this point, guys, then start explaining about this defect life cycle, which can be followed by most of the defect tracking tools available in the market. So everyone will understand this different states. You see in this diagram, all these orange color boxes are the different states of the defect. Okay, so all the states of the defects form a defect life cycle. So it doesn't belong to any one of the defect tracking tools in the market, guys. This diagram doesn't belong to a single defect tracking tool in the market. It is applicable for most of the defect tracking tools available in the market. Okay, so let's start explaining that. So here, as you can see, these activity blue color things are the activities that are done by the tester, and because of these activities, what will be the status of the defect that is there in the orange color. Okay, so throughout this diagram, the same process is followed. So you see, when a tester finds a defect, okay, you see when a tester finds a defect, the state of the defect will be in new state. Okay, the initial state of the defect will be in new state. For example, here if I take you to this application, okay, and take you to this register page. So here there is a telephone field number. This telephone field number should accept only numerical values. But what if I am entering some alphabets and trying to click on continue? So let's see what will happen in this case. Okay, so what is happening in this case? Let's see. When I enter alphabets instead of numbers and click on continue, what's happening, guys? You see, the warning message is not coming for telephone. That means telephone field is accepting this alphabets. This particular telephone field is accepting the alphabets. Instead, it should not accept the alphabets. It has to give a message saying that invalid telephone number message should come. So this is a defect. Let's say if I have identified this defect as a software tester, when I report a defect here into any of the defect tracking tools, so commonly the status of the defect will be what? New state. Okay, the state of the defect, the immediately when once a tester reports it into a defect tracking tool, the state of the defect will be new state. That is the first state. After that, dev project manager comes into picture, guys. Okay, after you have reported a defect, a dev project manager will come into the scene, where the dev project manager will check whether this is a valid defect or not. Okay, is this a valid defect or not? Dev project manager will check. So is it a valid defect? Yes, it is a valid defect, right? So if you enter alphabet, cell phone number should not accept. Instead, a warning message should come, which is not coming. So it's a valid defect. If the dev project manager believes that it is a valid defect, okay, then he'll go with the next check. But what if it is not a valid defect? In case if the defect reported by the tester is not a valid defect, in that case, dev project manager will select the rejected state. Okay, if it is a valid defect, no problem. Another check will be done by the dev project manager. But if it is not a valid defect, in that case, the status of the defect will change from new state to the rejected state. Okay, dev project manager will reject the defect and status of the defect will get changed to the rejected state. Otherwise, if it is a valid defect, another check will be done whether this particular defect is already reported the defect tracking tool or not. Okay, you or your colleagues have already reported this defect earlier in the same defect tracking tool or not will be checked as part of this. Is this an existing defect, that is a duplicate defect? The dev project manager will check, is this a new defect or is it really a new defect, or this defect is already reported earlier? That will be checked. If it is not reported, then no problem, next check will be done. But if it is already reported but again the tester has reported it for the second time, then definitely dev project manager will change the status of the defect from new state to, if it is a valid defect but it's already reported, why you are reporting again? So dev project manager has changed the status from new to duplicate. It is a, he will change the status of the defect to duplicate status. And also there is one more check, guys. Okay, if it is a valid defect, if it is not reported already, in that case, another check is done by the dev project manager. That is, can we delay this defect fixing to the next releases or not? Okay, do we have to fix this defect before this release, or can we postpone the fix of this particular defect? why the dev project manager thinks about postponing of the fixing of the defect? Because there may be a situation where all the developers in the project are already busy. Okay, they are occupied with a lot of work, and if some kind of defect comes which is not that much important to be fixed right away, maybe the dev project manager to just to decrease the load on the developers who are constantly working the project. So what the dev project manager will do is, okay, he will make a decision, he or she will make a decision to delay the fixing of the defect by changing the status of the defect from new state to deferred state. In that case, status of the defect will change from new state to deferred state. If the defect need to be fixed, can be fixed later. Okay, it can be postponed. Fixing of the defect can be postponed if the dev project manager believes the status of the defect will change from new state to the deferred state, guys. Okay, there's another one. Now, guys, there may be a situation where the defect is valid, defect is not already reported, it's not a duplicate defect. Okay, and defect has to be immediately fixed. It cannot be delayed. Okay, before this release, we have to fix the defect. In that case, dev project manager will finally change the status of the defect to new to assigned state. Okay, the status of the defect will change from new state to the assigned state. So in assigned state, okay, in assigned state means it got assigned to one of the developer, guys. Okay, status of the defect is assigned means the dev project manager has assigned this particular defect reported by the tester to a particular developer. Okay, so the developer who has who for whom this particular defect has been assigned, okay, what the developer will do when the developer start working on this or start fixing this particular defect, developer will change the particular developer for whom the defect has been assigned by the dev project manager. That particular developer will change the status of the defect from assigned state to open state. Okay, the status of the defect will change from assigned to open state. So open means the defect developer is actually fixing the defect, started fixing the defect. Okay, fixing of the defect is in progress, then open state of the defect. Let's say while fixing the defect, let's say the developer has completed fixing the defect. Okay, properly fixed the defect, he believes. In that case, developer will change the status. Okay, once the fixing of the defect is completed, the status of the defect will change from open state to fixed state by the particular developer who feels that the this particular defect got fixed. Fixing of the defect got completed, so it will be status of the defect will be changed from open state to the fixed state. Fine. So before starting fixing the defect, it is in assigned state. After that, while the developer has started fixing, it is changed to open state. And once the developer has completed fixing, the status of the defect has been changed from open to fixed by the developer itself. Fine. Once the status is shown as fixed, the defect tracking tool, then testers will come into picture. Okay, tester will come into picture, and the tester will perform retesting of this particular defect in the proposed version where the fix really happened for this particular defect. Okay, so there are two possibilities here. This particular defect may either have been really fixed. In that case, if it is really fixed, as part of retesting, the tester found that developer has properly fixed the defect. In that case, the tester will change the status of the defect from fixed state to the closed state. Okay, if the defect is really fixed by the developer, in that case, tester will change the status of the defect from fixed state to the closed state. Okay, because it is a pass, right? Retesting has passed and status of the defect has been changed from fixed to closed state. Okay, defect is closed now, kind of. Okay, or else if the defect is not really fixed or partially fixed. Okay, if the defect is not fixed as stated by the developer, or if the defect is partially fixed, some portion is working, some portion is not working. In that case, either not fixed or partially fixed. In that case, the tester will fail the, okay, the retesting will fail, and tester will change the status of the defect from fixed state to again open state, so that developer has to again fix it. Right? This is what happens. And there's one more case, guys. What happens is, you see, in one of the case, if the tester feels that the defect that is stated as fixed by developer is really fixed, the status of the defect will be changed by the tester from fixed state to the closed state. But after a few days of closing the defect, again in the application, if the same defect is coming, then the tester should not report the defect again. Okay, already defect is there and it is closed. Now the defect is coming again means you should not open, you should not report a new defect. Okay, already defect is there, again you are reporting a new defect. That is not correct, guys. Rather, whatever the defect that the tester has closed earlier, which is coming again, the tester has to change the status of the defect from closed state to open state. Okay, tester should not report new defect. Instead, the old and earlier closed defect has to be opened again. So the status of the defect can change from closed to open. This activity will be done by the tester. If the tester finds that the earlier closed defect is again coming, in that case, closed state of the defect will be changed to open state and developer has to fix it. And again, once fixed, developer will change it to fixed state, then tester has to retest. And if it is really work fixed now, again, the tester has to close. The process continues. So guys, these are the different states in the defect life cycle. Okay. So, and there is one more thing, guys, before I wind up. I explained you all the different activities of the tester, dev project manager, and the developer here while changing the states of the defect as part of the defect life cycle. But you see, there is one thing like to check whether dev project manager to check whether this is a valid defect or not. There are several things. Okay. Some cases, the defect is not a valid one. Okay. For example, is as per the design. For example, someone says that there should not be forgotten password link here. Okay, a new tester came into the team and he doesn't know what is forgotten password. Let's assume, and that particular tester has reported defect saying that some link is coming. Okay, which is not required here. Email address, password, and login are enough. Why forgotten password? Some link is coming. It's unnecessary kind of thing if a tester reports, but it's not correct, right? It's as per the design. Generally, all the login pages will have the forgotten password. So in that case, it is as per the design. So in such cases, since the particular defect reported by the tester is as per the design, is as per the functionality of the application, the dev project manager will reject the defect saying that it is as per the design. Okay, it's correct only, in simple words. In some cases, what happens is the tester has reported the defect. The tester has reported the defect, but in the defect, but while the dev project manager is trying to replicate the same defect that the tester has reported by following the same steps written by the developer and tester and all, if the dev project manager is unable to reproduce the defect, if the defect is not coming at the dev project manager side, simply dev project manager will write down saying that rejected the defect as the defect is not coming my side, hence not reproducible. Like that, another reason for rejecting the defect by the dev project manager is if the defect is not reproducible, then also dev project manager will reject the defect. And in some cases, guys, the tester has reported the defect, but tester has not provided enough information for the dev project manager to understand the defect. Okay. In that case, dev project manager to ask the tester to provide all the complete details. Dev project manager again will reject the defect with the reason as need more information, provide more information so that I can understand the defect well. So that is another reason for rejection, guys. And there are some situations where so testers will think that the functionality, okay, suddenly they will come across some functionality and they think that that is a defect, but ultimately that is an enhancement. Okay, the old functionality has been upgraded to the latest format. Okay, so for example, here email address and password are displayed in the same page. If you go to Google, guys, okay, Google or Amazon or some kind of places, right? First, they'll not show you the password field. First, once you enter the email address, then only in the next screen, password will be coming. So assume that there is a tester who doesn't know about this, and the tester has reported defect saying that okay, password field is not coming. Okay, earlier it was you used to be there in the login page. Now password field is coming in the next page or something. If the tester has reported, in that case, the dev project manager what he or she will do is okay, dev project manager will again reject the defect saying that it is an enhancement. Now it is decided to display the password field in the next page, okay, rather than the same page where email address field is available. Okay, so there are different reject reasons that dev project manager can provide while rejecting the defect. Okay, so these are the different states of the defect in the defect lifecycle, and this is what is the defect lifecycle, guys. If you can explain this diagram well, that is nothing but the defect lifecycle, which is applicable for most of the defect tracking tools available in the market. It's a common defect life cycle which can be applicable for most of the defect tracking tools available in the market. So, so this is what, guys. Okay, this is what. So fine. So with this, guys, hope you got the answer for can you explain defect life cycle. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 71. That is, what is defect severity? Let me answer. Defect severity is nothing but the level of technical impact the defect has on application. While reporting the defects, based on the level of the technical impact the defect has on application,
we have to specify the type of defect severity. There are 4 types of defect severity. That is critical severity defects, high severity defects, medium severity defects, and low severity defects. While reporting the defects, based on the level of the technical impact the defects has on application, we have to choose one of the type of this defect severity. Okay. So for example, while you are reporting a defect which is resulting in server error pages on the application, then we have to specify the severity type as critical severity for the defects. Okay. The defects which are resulting in server error pages on the application, then we have to specify critical severity because the level of the technical impact is high in case of server error pages. Okay, the technical impact level is high in case of server error pages. So critical severity defects we have to specify while reporting such defects. So why we have to specify critical severity kind of type of defect severity for this kind of server error pages defects? Because when you get server error pages, guys, you cannot do anything on the application. You cannot proceed further. It blocks the functionality and testing cannot proceed further because of the server error pages. We cannot proceed further. That's why this type of defects have the high level of technical impact. Okay, a critical level of technical impact. Hence, we have to specify such defects as critical severity defects. Next level of next level of severity is high severity. Okay, to which kind of defects we have to specify high severity level. So there are some key functionalities on the application. Let's say there are some key functionalities on the application, like for example, in an e-commerce application, the major functionality that everyone uses in e-commerce application is search functionality. You have to search for a product. Okay, all the users who land on the e-commerce website, first they will search for a product. For example, if they are searching for some product, in the results, some other product is coming, a wrong product is coming. That means the key functionalities of the application are not working. Okay, if the key functionalities of the application are not working, in that case, we have to specify the severity type as high severity for such kind of defects. Okay, so such functionality in the application is not working or giving some wrong search results or wrong products in the search results. In that cases, we can specify the severity type of the defect as high severity defect. Then we have the medium severity defects. So in the normal functionalities of the application, okay, when we have to specify the defect as medium severity type, then the normal functionalities in the application are not working as expected. These are not the key functionalities of the application. These are the general functionalities of the application which are not key type. Okay. For example, you are unable to update the address in the application. You are unable to change your profile picture in the application. In such cases, such kind of defects can be selected as medium severity type. Okay. You can specify such defects as medium severity type. Now, coming to the low severity defects, guys, which has cosmetic defects, guys. Okay, all the other cosmetic defects doesn't fall into critical category or high category or medium category, will fall into the low severity defects category. Okay, which are nothing but cosmetic defects like spelling mistakes, color combinations, grammatical mistakes. All these kind of things will fall into low severity defects, guys. So the functionality is working, but UI is not good or bad. Okay, so in such cases, okay, functionality is working, but UI is not good or UI is bad. In that cases, you can report such defects as low severity because level of technical impact that this low severity defects is very low. That's why we call them as low severity. For example, color of the button is green instead of blue, or there is spelling mistake or grammatical mistake some of some text on the application. Okay, there's some text on the application which is grammatically wrong or spelling mistakes are there in that. In such cases, low severity we call. So hope guys you understood what exactly is defect severity, which is nothing but the level of the technical impact that the defect has on application. Okay, we have different types of defect severity like critical severity, high severity, medium severity, and low severity. Based on the level of the technical impact, we can specify any of these types of severity to the defects while reporting the defects. So hope guys you got the answer for what is defect severity in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 72. That is, what is defect priority? Let me answer. Defect priority is all about how fast the reported defects have to be fixed by the developers. Let's say the testing team has reported few defects and these defects need to be fixed by the developers. But how fast these reported defects by testing team have to be fixed by the developers will be based on defect priority. For different defects, we specify different defect priorities. You see, these are the different types of defect priorities that we can mention for a particular defect. So the defects can be specified with urgent defect priority when that particular defect need to be fixed within 24 hours. Okay, after reporting the defect, within 24 hours, the defect has to be fixed. If so urgent, then we have to specify the defect priority of the particular defect as urgent, guys. Okay, so example for this kind of defects which fall into the urgent defect priority are unable to log into the application. Okay, if there is a particular functionality where there is a particular application where the user is unable to log into the application. Okay, this is very important, right? And this particular type of defect need to be fixed within 24 hours, very urgent. Now coming to the next priority type, defect priority type, that is high priority. So this high priority defects need to be fixed before the release. Okay, so before the release of the software, these high priority defects need to be fixed. It's not within 24 hours. It's like we have, let's say, one or 2 weeks of time for releasing the software into the market. Let's say in that case, the defect can be, okay, the defect which falls into the high priority can be fixed before release, okay, before the release happens. For example, for the high priority defects are important defects only, but they don't have to be fixed within 24 hours. Okay, here high priority is also important defects like urgent specified defects, also important defects. High priority specified defects are also important defects, but urgent are the ones which need to be fixed very fast, that is 24 hours. But these are also important defects only, but they have to be fixed before the release. Okay, unable to change the password or address. Okay, such kind of defects can be specified with high priority and they have to be fixed before releasing the software into the market. Now we have the next priority, that is medium priority. Okay, for what defects we can specify the medium priority? For the defects that can be fixed in later releases, we can postpone. Okay, we can postpone the fixing of the defects. So we can either fix in this release or we can postpone. Okay, we can take a call. For example, for this medium priority is unable to delete uploaded photos. Okay, unable to delete some uploaded. You can upload the photos. Okay, but you are unable to delete the uploaded photos. So such kind of defects fall into the medium priority. And finally, the low priority defects. Okay, low priority. So can be fixed by the final release. Okay, not this release or not next release. They can be fixed by any release. Okay, if you have time, all these defects will be fixed beforehand. But if the developers are busy, they can postpone these low priority defects in such a way that they can fix later. Okay, by the end of the just before final release, also they can fix them. It doesn't mean that it's mandatory for the developers to wait for final release, guys. Okay, if they have time, they will fix it right away. But if in case they have a lot of work and they are unable to fix, they can postpone it. Okay, till the final release, they can postpone the fixing of the defect. Okay, so there is no urgency in fixing the defects. So that is low priority defects, guys. For example, there is a spelling mistake in the paragraph of a particular page, which is there in the footer options. Okay, let's say there is an application. In that application, there are a few footer options that people don't generally visit. In that footer options, there is a footer options page. There is a paragraph. In that paragraph, there is spelling mistake. Okay, such kind of defects fall into the low priority. Okay, which can be fixed just before the release. Also, final release also is fine. Okay. So these are the different types of defect priorities that we can specify for a particular defect, guys. Okay. So hope guys you got an idea of what exactly is the defect priority now, and so that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 73. That is, what is the difference between quality assurance and quality control? Let me answer. Quality assurance, that is QA, and quality control, that is QC. Both the purpose of QA and QC is to improve the quality of the software. Okay, as you can see here, the purpose of the QA, that is QA purpose, is to improve the quality. And also at the same time, the purpose of QC, that is QC purpose, is also to improve the quality. The purpose of both QA and QC is same, but they are not equal. QA is not equal to QC, even though the purpose is same, that is to improve the quality of the software, but QA is not equal to QC. How QA is different from QC? How quality assurance is different from quality control? Let me answer. QA, okay, the QA, that is quality assurance, is a preventive process which will prevent the bugs. Okay, QA is a preventive process when used in the projects will prevent the bugs from occurring. It's a preventive process, guys. Okay, let's say there is a house. Okay, there is a house, and in the house you see a lot of mosquitoes here and there, right? So if you follow this kind of process, let's say there is a process that you follow in the house by which the mosquitoes will not enter the house. Okay, that kind of process. If I take another example for QC, guys, okay, it's like what will you do after the mosquitoes enter the house? Okay, this QA, let's assume in the real world example, guys, QA can be applied to a real world example where you see there is a house. Into the house, before the mosquitoes come, if you follow a process, mosquitoes will not enter your house. That is QA. Coming to QC, guys, okay, if I compare that QC with the real world, it's kind of thing where after the mosquitoes enter the house, how to prevent. Okay, so how to make sure that this mosquitoes doesn't bite you and how to kill the mosquitoes. Okay, that is QC, guys. Okay, in real world, if I compare now, let me explain more in a actual context of QA and QC. You understood, right? How to avoid the mosquitoes entering into the house. What if the mosquitoes enters? What we have to do? That is QC. Okay, QA is how to prevent the mosquitoes entering the house. Okay, in real world example. Now you will be able to understand what is QA and QC and how they are different properly. Now let me explain. QA, guys, is a preventive process. Okay, is a preventive process used to prevent the bugs, okay, from occurring in the projects. So QA focuses on building the right process, okay, by following a proper process, guys. Okay, following a right process in the project. Okay, when this right process is used in the projects, the bugs will not come, right? Whenever a project team uses a right project, what will happen? Whenever a project team uses the right project process in the project, okay, then what will happen? Bugs will not come, right? So QA focuses on building the right process for the project so that bugs will not occur in the projects. So here, who will perform this QA activity? Quality assurance will be performed by whom? Who will be creating that right process for the project so that bugs will not occur in the projects? Project team, guys. Simple. Anyone, it can be developers, testers, or anyone who is part of the project. Okay, how they will create the right process for the project so that bugs will not occur in the projects? This project team, okay, the people in the project, they will monitor the current process, guys. Okay, whatever the current process that is followed by the project will be monitored by this project team first. Okay, they'll first monitor, they will observe what is the current process being followed by the project. They will observe. After that, they will modify the process. Okay, they will do some necessary changes to the current process. If there are any problems in the process that is followed by the projects, they will try to do some modifications. Okay, do the necessary modifications to the process of the project so that, okay, they can create the best process out of that. So by modifying the process that is following the project, okay, there comes an outcome where a best process will be ideated by this project team. And when this best process is used by the project team as a process in the project, then what will happen? Automatically bugs will not occur. It's a preventive measure, right? So that is what is QA, guys. But what is QC then? QC is a corrective measure. Okay. Let's say due to some reasons, okay, even after having a process and all, let's say bugs came in the project. What you will do? You have to correct them, right? We have to identify the defects, that is bugs in the software, and we have to make these bugs fixed by the developers and thereby improve the quality of the software. Who will generally perform QC? QC is generally done by the software testers. Okay? Dedicated software testing team will be there whose actual objective or motto is to identify if there are any bugs in the software. Okay, so and they will identify and then report these particular bugs to the developers, and developers have to fix them. Once the developer fix them, again the software tester, dedicated software testing team who is doing this quality control, right, QC, right, who are part of QC, right, they will retest the bugs that are stated as fixed by the developers and thereby improve the quality of the software indirectly. Okay, so it's a corrective measure, it's not a preventive measure, guys. What we have to do when bugs are there in the software or the other project? Okay, that is a corrective measure, not a preventive measure. So it focuses on testing the product or software when used can identify bugs and get these bugs fixed by developers and retest and to confirm whether the bugs got really fixed, and thereby the quality of the software will get increased. Okay, when the bugs are corrected in the software, automatically the quality of the software will increase, right? That is what is QC, guys. Software testing is all about QC, guys, not QA. QA is about the process followed in the project, whether that process that is followed in the project is the right process or not. If right process is followed, automatically bugs will not occur, right? But coming to QC, it's not about the right process or something. It's about testing or checking the software with an intention of identifying the bugs and getting them fixed by the developers and retesting them to see if the bugs have been really fixed with an intention of improving the quality of the software. Here, dedicated software testing team will perform this QC, that is perform testing on the software by using their testing skills and tools to identify defects with an intention of improving the quality of the software by getting them fixed by the developers and confirming that the defects doesn't exist in the software. So hope guys you got an idea what is QA and what is QC now, right? So the purpose of both QA and QC is to improve the quality of the software. Okay, but it is QA is a preventive measure, whereas QC is a corrective measure. Okay. So hope guys you got the answer for what is the difference between quality assurance and quality control now. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 74. That is, what is the difference between inspections and audit? Let me answer. So what is the difference between inspection and audit? Coming to inspection, okay? As part of inspection, we do the examination of a work product or a software to see whether that particular product or software is developed or manufactured or created according to the standards. As per the mentioned standards, it has been created or manufactured or developed, we'll check. And also we'll see whether that particular work product or software that is manufactured or created or developed is working as per the expectations or working as per the client requirements or specifications. We are going to check. Here we are actually checking guys. Okay. This checking process is very frequent. We keep on checking, right? So very frequently we keep checking whether the developed or created or manufactured software or product, okay, any product or software is according to the standards or according to the compliances. Okay, it's complying some compliances and all, is working or not as per the given requirements, it's working or not. Okay, it's working as expected or not. Here we are checking something. Okay, that is what is inspection, and these inspections are done in a frequent manner. Very frequently we keep checking this kind of stuff. Okay, examples for the inspections are software tester testing a software. So software tester keeps on testing the software, right? For every version he will keep on testing, he or she will keep on testing, okay, to see whether the developed software is working as per the client requirements or not, it is working as per the end users needs and expectations or not. That is being tested. Here checking is going on. Similarly, another example for the inspections are a developer reviewing the code. Okay, developer is reviewing the code to see whether any syntax issues are there, okay, security standards are followed or not. Okay, so optimized code is written or not. Such kind of checking is going on. Okay, high level checking is going on in case of reviewing the code here, and also software tester testing the software very frequently to see whether the software is working as per the client specified requirements or it's also working as per the end users needs and expectation. Here we are simply checking guys, this inspection is a frequent process. Okay, frequent checking process. But here, what is audit? Audit is different from inspections, guys. Okay, audit is something different from inspections. So, what are audits? Audits are structured and independent process, guys. Okay, audits are nothing but structured and independent process used to determine whether whatever the checking activities that are going across inspection, right? Those checking activities are complying with the organization or project policies. According to the policies, we are checking or not. According to the organization policies, are we doing these inspections? Okay, we are auditing here. We are auditing our inspection process to see whether the process is complying with the organization and project policies or not, and it's following a proper process or not. Following a these inspections are following a proper procedures or not. All these are being audited as part of audits, right? So and also as part of audits, it will be checked whether these inspections, okay, where we are checking the working product or software to see whether they are working as expectations and complying with the standards and compliances, right? those those inspections are yielding the results or not. Okay, by doing the inspections, are we getting the desired results or not? That is being audited here. Okay, it's a very high level process than inspection, right? Coming to inspection, this here we are simply checking, it's a checklist or something, we are simply checking whether things are as per the desired way or not. We are checking here. Okay, that is inspection. Software testing, software tester doing software testing, or developer reviewing the code, all falls into inspection. It's very done frequently. But these frequent and inspections done by software testers, developers, and project team, right, are they happening according to the process Are they according to the complying with the organization policies, process and procedures or not? Whether the things are going well or not? Are these inspections yielding the results or not? All these are part of the audits, guys. Okay, and generally these audits are done by, okay, audits are done by some internal audit team will be there. For example, guys, in your company there will be some different projects will be there. In every project the software testers will do the inspection. Let's assume developers and software testers are inspecting their work, right? Software testers are testing the software, developers are reviewing the code. That such kind of inspections are going in each and every project. But throughout this project, okay, throughout all the projects work that are happening in the company, whether proper process is being followed while doing the inspections, whether the proper policies are being followed while doing that inspections, whether proper procedures are followed, whether the best practices are followed, whether all these projects are getting the better results by doing the inspections or not. Who will check? The checking is done by as part of audits, case. Audit is a high level checking of whether these checks are properly being checked or not. Okay. So like internal audit team will be there, PMO will be there, project management office. Okay. So these people will calculate everything, whether within the time and within the budget or the projects are being delivered or not. It's not about delivering the things. Okay. It's not about checking or delivering the stuff. It's about whether within the time and budget things are happening or not. PMO will audit that. Okay. So there in some companies external auditor will come, guys, and verify all the records. Okay, whether this process is a proper process or not will be audited. Okay, process followed by the inspections done by the different teams in the projects will be inspected by an external auditor to see whether the proper things are happening or not in the projects. Okay, so what are the different checks that can happen as part of audits? There are many examples for these audits, guys. Okay, whether the best practices are followed as part of inspections will be audited. Any improvements can be made in this part of checking or inspections will be audited. Okay, so any gaps to be filled, if any problems are there in inspection process, the current inspection processes, checking process, any improvements can be made, any problems are still there in the inspection process, what are the best practices can be followed so that more better results will be yielded by these inspections, and many more, guys. Okay, all this falls into audits. So hope, guys, you got an understanding of what is the difference between the inspections and audit as part of this session, and I hope you will be able to answer this to the interviewer if this particular question is being asked in the interviews. So that's all for this session, guys. In the next session I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 75. That is, what is bug taxonomy? Let me answer. In software testing, as part of bug taxonomy, we define different feature categories of the application and thereby adding test ideas for each of the feature category which may result in possible bugs. Okay, so that is what is bug taxonomy. Let me explain this line with an example so that you will understand what is bug taxonomy in a better way. For example, there is an application like Tutorials Ninja. I'll show you the application also. You see, this is the application, Tutorials Ninja application, right? So if I am testing this application, if I have to prepare a bug taxonomy as part of testing this application, if I have to create a bug taxonomy, I'll be creating like this. This is the project or application name, and for this application, I'll be defining different feature categories. What are the different feature categories in this Tutorials Ninja application? As you can see, we have a category like register account functionality, right? This is one feature. Registering an account with this application is one feature that I mentioned here, register account. And also, this particular application has another feature known as login feature. Okay, here I'll try to log into the application, right? That is another feature. And other features in the application like search feature, add to cart, checkout feature, placing order feature, all the other features I'll mention here. So this is a sample, so I'm not creating the entire bug taxonomy. So for a particular application, as part of bug taxonomy, we define different feature categories of the application. Okay, we define different feature categories of the application like this: register account, login, forgot password, logout, search, and so on. Like that, we'll define different feature categories for this application. Okay, and after that, for each and every feature category that I mentioned here, we are going to add the test ideas. For example, for register account, what are the test ideas I added for this as part of this bug taxonomy of this application? For register account, I added the test ideas like invalid email address. Okay, try to create an account with invalid email address. What's happening? We have to check. Okay. We will try to create or register an account with the help of invalid phone number. We'll try to enter invalid phone number while registering an account, see what will happen. So we'll try to create a duplicate account while registering an account. Okay. And many other test ideas we can add. Okay. This is only the sample list. And for similarly for register account, the way we added the test ideas, right? Similarly for the login feature also, for login feature category also, we can add some test ideas like SQL injection payloads. We'll try to insert some SQL injection payloads to see whether the hacker is able to bypass the authentication process, okay, the login process or not. Without having the valid credentials, whether the hacker is able to log into the application or not, we'll check. So without entering the credentials, okay, without providing any username password, if the user is trying to log in, what is happening? Okay, all such kind of test ideas I am adding to the respective feature categories of this application. So why I am adding all this list of test ideas for each and every feature of this feature category of this application? Because these test ideas may result in possible bugs. Okay, with the help of these test ideas, we may generate some bugs in the application. Okay, this is what is the bug taxonomy, guys. Okay, in software testing, as part of bug taxonomy creation, we define different feature categories of the application. We define different feature categories of the application and thereby adding test ideas for each and every category, thereby adding the test ideas for each and every category, feature category, which may result in possible bugs. Okay, these test ideas, we are not going to add all the hundreds of test ideas. We are going to only add the test ideas for which there is a possibility of uncovering a defect in the application. Okay, so we are going to add the test ideas which may result in some possible bugs, okay, in the application while testing. So this is what is called as bug taxonomy, guys. Bug taxonomy, if you give this bug taxonomy to the uh, newcomers, okay, new software testers, okay, who are newly entered into the software testing field, okay, they can test the application better. They can learn a lot. And also the experienced people, okay, experienced software tester also can use a bug taxonomy to increase the test coverage, to increase the test coverage. They're already testing well, but on the top of that, if they are missing any ideas, okay, so they can use this bug taxonomy so that they can increase the amount of testing by increasing the test coverage. So this is what is bug taxonomy, guys. Okay, and this is how it is created, which in simple terms is nothing but as part of bug taxonomy, okay, creation, we define different feature categories of the application. All the feature categories of the application we define here, and for each and every feature category, we are going to add test ideas which may result in possible bugs. Okay, all the test ideas we are going to add for each and every feature category that may result in possible bugs. Okay, and this is what is bug taxonomy. So hope guys you got the answer for what is bug taxonomy and what is the use of creating this bug taxonomy. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 76. That is, what is quality assessment measurement? Let me answer. Quality assessment is one of the QA activities performed to measure the quality. There are different QA activities which are generally performed to measure the quality. Quality assessment is one of them. Apart from quality assessment, we have quality monitoring and also external evaluation of the quality is also there. Okay, these are the different QA activities which are used for measuring the quality, where quality assessment is one of them. But what exactly is this quality assessment? Quality assessment, as I already mentioned, is a quality measurement. Okay, is a QA activity which is used to measure the quality. That's already clear. But on the top of that, how do we measure the quality using the quality assessment? How do we measure the quality with the help of the quality assessment? You see, in quality assessment, we measure the difference between expected versus the actual. Okay, expected versus the actual performance quality. So why we have to measure the difference between the expected and actual quality? So that we can identify if any gaps are there in quality. Okay, so that we can improve the quality by identifying the problems and by identify the gaps, okay, between the expected and actual, we can improve the quality. Okay, we can improve the quality by taking necessary measures. Okay, that is what is quality assessment, guys. So hope guys you got the answer for what is quality assessment in this session. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 77. That is, what is test management? Let me answer. Test management is a process or procedure of managing testing activities. Let's say there is a project. In a project, as part of software testing, we perform a lot of testing activities. Managing such kind of testing activities in a project is known as test management. So as part of test management, we follow a process or procedure for managing several testing activities. Test management is performed in several phases. Okay, it's not a single phase activity. Okay, test management where we are going to manage the testing activities is performed in several phases. What are the several phases involved in test management? Risk analysis phase, where the probable risks, okay, before we start testing, what are the probable risks that the team may encounter? That risk will be analyzed in advance and solutions will be created in advance. Okay, that is risk analysis. Then estimations. Okay, so we have to estimate what time, okay, what time and duration each and every individual testing activities take. Then planning, how to perform testing, how to plan our testing, what is our strategy, okay, what is our strategy, what are the functionalities we have to test, who will test what, all this kind of planning will be done as part of test management. Then test organization, so organizing perfect team for testing. Okay, in case of test organization phase of test management, we organize the perfect team. Okay, we'll provide perfect team for performing this kind of testing activities. Okay, who is suitable for which type of testing, will decide in advance as part of test organization. Then test monitoring and control. Okay, so test monitoring means to see how the testing progress is going on, what is the current state of the testing, whether the quality is good, whether things are going well or not. We are monitoring. Okay, if any problem is identified, okay, if a problem is identified, let's say the testing is not being done on time, or the proper defects are not fixed on time, such kind of monitoring will go on, guys. Okay, if any problems are identified as part of test management, as part of test management in test monitoring, then we have to control that. Okay, so control means bring that particular problem to control. That means things should go well, how to overcome that problem and proceed further, that is control. Okay, first we'll monitor to see if any issues or problems are there, then we have to control it, so that things will be on pace and things will be on control, like that. So here, as you can see, tracking project progress and controlling it if it is out of progress. Okay, if it is not going as per the plan, then we'll control it. We'll take necessary measures where it will follow the path, proper path. Then issues management. Okay, so during the project, a lot of problems will come, guys. Okay, we have to handle the problems as part of test management. Okay, so if any problem, any issue is there in the project, how to handle that? That is issue management. Then test report. You see, all testing is all about results, right? Okay, so where we can assess the quality, how much testing is completed, etc. So reports. These are the several phases in test management, starting from risk analysis to test report. So how to do all these activities in a detailed manner, you see there, that is explained in this components. Okay, that is written in this components. As you can see, there are a lot of components, like in case of test documentation, as part of this test planning. Okay, in test management, we create the test policy, test strategy, that is our approach for testing, test plan, which indeed contains a lot of things like scope of the project. Okay, what need to be tested, what in which environments we have to perform testing, schedule at what time we'll perform which type of testing, and what are the testing activities we perform based on the time and schedule. Okay, resources, who are going to work on this project, what are the those people roles and responsibilities, everything will be written, created in the test plan. Deliverables, what you are going to deliver as part of the project, what is the entry and exit criteria for the software testing, STLC, in followed by this project. Okay, for each and every phase of STLC in this project, what is the entry and exit criteria, risk analysis and solution, what are the probable risks in this project, and what are the backup solutions when they encounter. Okay, so that we have to follow when they encounter, like the test documentation we do as part of test management, where we create this kind of documents, and this kind of activities will be done in this as a, will be documented as part of these documents. Then test estimation. Okay, you see, test estimation is one of the phase, right? But estimation is a very big thing. Okay, what are the different factors which will affect this estimation? As you can see here, you see what level of quality is required. Based on that, we can estimate how much time it will take and all, right? So application size, what is a application is very big or small application, historical data, what type of data the application is using so far, Then test environments, okay, in which how many environments we have to perform testing also affects our estimation. If more environments are there, the testing will take more time. So like that. Tools, which tools we are using, based on that, are using tools, without tools we are doing, based on that estimation will be decided. Process complexity, how much complex is a project process, okay, which model we are following as part of the project, everything will depend. Strategy, based on our approach of testing, estimations will differ. Training, any training is required for the resources. Okay, if extra training is required for the resources, estimations will differ. Knowledge transfer. Okay, so how much knowledge transfer has to be done? If it's an existing project and if new people came, knowledge transfer is required. Okay, so their estimations will differ based on the technology that has to be used while working on the projects. Okay, or while testing something in the projects. Okay, that based on that. Specifications, based on the requirements of the project, based on the uh, test data preparation. Okay, how much time or how much important the test data plays a role in this particular application, how much efforts need to be put as part of creating the test data. All this differs in the estimation part. Resources, which type of resources are working in the project, based on that estimation differs. Okay, differs. So these are the different things that are done as part of the test management, guys. We do documentation as of, okay, um, the project team, okay, will do the test documentation as part of test management. They do test estimation as part of test management. Then metrics, so we have unless we measure something, we cannot get the result, right? Okay, whether we are going in the right direction or not. Okay, let's say you're traveling from destination A to destination B, you have to measure it, right? How much distance you already traveled, how much distance is left, how many kilometers is already traveled by a bus or train or something, and how much distance is still left. That metrics are required in the project also, as part of testing activities also. How much progress is done? To confirm that, we have to measure it. So what are the different metrics we need as part of the as part of managing the testing activities in a project? We have to measure the project metrics, like how much percentage of application is has passed the testing, and how much has failed, how much has not been tested it. Okay, all these things need to be measured. Okay, these are the metrics. Then product metrics, guys. Product metrics, what are the different attributes of the product? How many defects are coming in, how many area, if you take any across application functionalities, in each and every application, how many defects? Okay, that is defect density. Process metrics, like measure capability of testing, how much capable is our testing, are we doing the testing well? We can also measure this process metric with the number of defects identified by the testing team. And people metrics, okay, so how much capable the individual people, that is software testers who are working in the team, are really working and able to identify the defects. These are people metrics. Then test progress, it's all about the progress of the testing project, where how many test cases planned versus how many test cases executed, how much we thought of executed. We thought of executing how many test cases, but how many actually got executed? That is what this line all about. Total defects identified by the team, okay, and categorized according to severity, priority, and other categories. Change. These are all metrics, guys, to measure your progress. Okay, testing progress. Change requests. How many change requests are being introduced by the client every time? Okay, planned versus actual cost. Okay, so are we completing the testing in time and duration? That is, time is duration, and within the budget, it's testing is completing or not. Okay, so all things can be measured. So milestone, which milestones we have to reach by what time of time, and it is as per the expectations, or actually according to the plan it's happening or not. Quality risk status, what is a quality, is it going well, or are there any risks in the quality? And efforts, how much efforts, okay, the team is putting in performing the testing. All these are the metrics. Okay? So we are done with the estimation, we are done with the documentation. These are the different components in test management. So all these activities will be done as part of test management, as part of managing the testing activities. We do the documentation, we do the test estimation, we do the test metrics. Then we measure the testing progress. Okay. So product risk, how much risk covered, how much, you see, like testing means testing will uncover the defects, and when the defects are uncovered, risk will get reduced, right? How much risk is actually covered and how much thing is tested, how much risk is there from the field tested, okay, identified by risk identified by the individuals. This is the product risk, guys. Then coming to the defects, how many defects identified? Okay, this is a measurement here. Okay, this maps with the metrics actually. Defects reported, how many defects are reported according to the category, priority, severity, how many defects got rejected, duplicate defects, time taken to fix the defects, new defects introduced on fixing. You see, when in some projects, what happens is when developers fix some old defects, some new defects will occur again. Okay, so such kind of problems. Based on that, we can decide the progress, measure the progress. Then also, apart from product risks and defects, we can also measure the test progress based on the test. How many tests passed, how many tests failed, executed, blocked, total tests, how many total tests are there. Okay. Coverage. Coverage. Next one is coverage. That is requirements coverage. How much requirements coverage is complete as part of testing. Okay. How many requirements we tested. Design coverage. How many test cases we have executed or something like that. Risk coverage. How much risk is reduced. Environments coverage. Like in how many environments we completed our testing. Okay. Code coverage. This is generally done by the developers. Okay. So where you map, right, or testers also. So in background, whenever you perform testing on the application, in the background code will run. How much amount of code actually got executed? Okay, how much code is tested actually? Not only UI but also at the code level, how much testing is done? That's the code coverage. So this will measure the testing progress, guys, and on the top of that, monitoring metrics in testing life cycle. You see, we have to monitor and control, right? If things are not going according to the plan, we have to control it and bring it back to the pace. Okay. So as part of that, what are the different metrics we follow for monitoring? You have to monitor the test plan. As per the test plan, the things are happening or not. Whatever we planned, the things we have to, the things that are in scope, the environments we have to test according to the schedule mentioned, according to the resources and all deliverables we have to deliver. We are monitoring the test plan. Okay, number of risk resolved and number of requirements covered, defect discovery, planned versus actual efforts. As per the test plan, everything is going according to the plan. We are monitoring here. Test design. Okay, defects identified during the test design. Okay, then monitor test analysis, number of test cases, number of defects in analysis, like a while. Okay, number of defects identified or something. Monitor test implementation, percentage of environment configuration, percent of test case automated. So implementation wise, okay, so how much is completed. Then monitor execution, how many test cases got passed, failed, not executed, blocked, how much percentage test cases covered, planned versus actual defects resolved by the developers. Okay, percentile of planned versus actual coverage of testing. This is all monitoring part, guys. Okay, monitoring the closure part. You see, these are the STLC phases. You see, test planning, then designing, then execution. Okay, execution, then closure. Finally, closure will come, where final report should be there, right? Just to close the testing, what metrics we can actually measure, like how many test cases passed or failed to close up software testing as part of the project. Test cases checked. Okay, automated. Then based on these results only, if these are positive, then only we can close our testing. Okay, these are the metrics for monitoring the closure part of the software testing. Okay, defect resolved, defect not resolved, work product tested, how much. Okay, how much amount of work product tested, everything is a metric here. Because these are the components, guys. Components mostly involve documentation, estimations, and metrics, guys. Okay, measurements and metrics are the major areas in these components. Fine. And this is how the test management is done in phases, which I already covered. Okay, these are the different phases across which test management is done. Finally, it will give the reports. First, it will start with the risk analysis, and slowly it will go to the test report. As part of test estimation, you see a lot of components I covered here, okay, which will be involved as part of test planning and estimation already. Fine, and monitoring also. Fine. So you see, guys, if a person or a team is doing the test management for managing the testing activities in a project without using any tools, it's going to be very difficult, right? The software or software tool will make your job more easy. It will automate your process. You see, you cannot create a lot of Excel files and track all the stuff. That is a very hectic process. Nowadays, a lot of tools are available in the market, which makes our job of test management, where we have to manage the testing activities in a project, very easy. Okay, very sophisticated because things are automated, right? For example, in real world, what do you do, guys? You can do one thing. You can wash your clothes, or you can wash your clothes with the help of washing machine. Okay, so what is washing machine used there? It's automating the process of washing with your hands and all. Okay, which will take a lot of time and efforts. But by using some tools, right, like washing machine in real world, here we have some test management tools which make our job of test managing of this testing activities in a project very easy. Okay, what are the different tools available in the market which we can use for managing the testing activities as part of test management? The different tools we have are Jira is the number one in the market, guys. Okay, a lot of projects are. It also supports agile projects. That's why it's kind of very famous. And on the top of Jira, to manage it, to perform test management, we have to install plugins like Zephyr and X-Ray. So test trial also has a very good demand in the market. After Jira, test trial is very popular. Then TestLink, which is an open source one. Then Red, which is free and open source, also being used by most of the projects. Then we have Redmine, Bugzilla, PractiTest, Qtest, version one. Version one is also famous test management tool, I can say. Any AUT, test flow, test lot, test stuff. ALM is also popular in the market. Okay, so people who are not worried about paying hefty license amount and they have very big projects, right? They generally go for ALM QC. Okay, earlier it was called as QC, now it's called as ALM. The latest name is ALM. Then QA complete and many more test management tools are available in the market. Okay, so hope guys you got an answer, very detailed answer I gave as part of the test management. Okay, in whatever way you get an question from in the interview regarding test management, I think you will be able to answer it now. Okay, it may not be what is test management, it may be about can you explain different metrics, okay, that are measured as part of test management. That may be a question in the interviews. Okay, it may be any question, guys. So with this explanation, you should be in a position to answer that. Okay, that interview question. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 78. That is, what is test maturity model? Let me answer. Test maturity model, in short TMM, is nothing but a framework for assessing the maturity of software testing process. Using this TMM framework, we can evaluate the maturity level of software testing process that is followed by the projects. Why we have to assess the maturity level of software testing process followed by the projects? With an intention of improving it. Okay, if we can assess, we can improve it, right? That's the reason. So this TMM, that is test maturity model, is based on capability maturity model, okay, which is known as CMM. Okay, this TMM is derived from CMM. So what is the difference between this TMM and CMM? While TMM is going to assess the maturity level of software testing process, while CMM is going to assess the maturity level of software development process. Okay, CMM is going to assess the maturity level of software development process, whereas TMM is for assessing the maturity of software testing process. That's why I'm saying TMM is derived from CMM. Okay, first CMM is there, from there TMM is derived. This for testing, this for development. Okay, assessing the development process, this for assessing the testing process. Done. So this test maturity model TMM has 5 levels. Okay, 5 levels are there. 5 levels of assessment are there. Which project? Okay, which project has the software testing process falling into these levels? Okay, depending on the maturity levels of software testing process used by different projects. Okay, the projects may stand in level 1 maturity level of software testing. Okay, level 2 software testing process maturity can be there, level 3 software testing process maturity level. Okay, these are the different levels. Different projects may fall into different levels of maturity levels of following the software testing process in the projects. Okay, so coming to the level 1, when can we say that a particular project has a software testing process which falls into the level 1 maturity level? When it is in initial stage. Okay, level 1 means initial. Okay, initial level. So if a particular project has some software testing process where you're going to check whether software is running, just running. Okay, when you are able to use the software or not, are you able to run the software without any blocks? Okay, without any blockers, right? If you are able to use the software or not, that's what you are checking here. It's not a real software testing, but you are simply just using the software and seeing whether the software is working or not without any blockers or blocks. Okay, so there is no defined testing process here. Okay, you will not follow any proper testing process here in this initial level. That is level 1 of a TMM projects. So no quality checks before releasing the software. Before releasing the software, okay, as part of level 1, you are not going to check anything. Okay, in such projects where the quality checks are not being done before releasing software into the market, that particular projects are following software testing process maturity level as TMM level 1. Okay, simple words, which is nothing but initial level. Coming to the you see here you are simply checking whether software is working or not without any blocks. Okay, blockers or blocks. Here there is no testing process already mentioned in level 1. Then no quality checks being before releasing the software. Okay, you are not going to check anything before releasing software into the market. And also here there is no proper testing process. Instead, whatever you are doing is to see whether the software is running or not, without any blocks, will fall indirectly into the ad hoc testing process. Okay, ad hoc testing will be performed without any proper testing process. So such kind of projects which are at the level 1 are like this. Okay, they don't have a proper testing process defined, and here we simply see whether we are able to run the software without any blockage. That is what is level 1 TMM. Okay, so coming to the level 2, guys. Okay, so level 2 means definition. Okay, definition. So in this in this kind of projects, the software testing process will involve the a thing where you will define the requirements here. Okay, definition means you are defining the requirements here. Okay, in the initial, the requirements were not defined, but here in the level 2, that is definition TMM, that is level 2 TMM. Such kind of projects following this TMM level 2, okay, uh, having this maturity level of software testing process, in that projects requirements are defined, guys. Okay, we will define the requirements, and accordingly the test strategies, test plans, and test cases will be created. Okay, test strategies in this level 2 TMM followed projects, test strategies, test plans, and test cases are created, and testing again the requirements using test cases. Okay, so here we are going to perform a proper testing, guys. Okay, here no process is there. In level 1 there is no process, but here in level 2 there is some process. Okay, here we are testing the application against the requirements using the test cases. Okay, by using this test strategies, test plans, and test cases, we are going to perform testing against to see whether the software application is working according to the defined requirements or not. We will check. Fine. Now coming to the level 3, which projects fall into the level 3. Okay, as part of software testing process, which projects will fall into level 3? That is integration level, guys. So here, guys, in integration testing, integration level of TMM. Okay, level 3 TMM. So here what will happen is testing is integrated with software lifecycle. Okay, testing is integrated with software lifecycle and is performed independently after development phase. Here the testing is not performed independently. Okay, so it's together here. So it's not a separate entity. So here testing is independent, and which comes after which phase of software lifecycle? Development phase. Here test in level 2, the testing is there. Okay, the testing is there, but the problem is with the test cases we are testing here. But the problem is it's not a independent thing. Okay, testing is not taken as a serious thing there. Here it is independently performed after the development of the software is done. Then testing will start and it's performed independently. Okay, independently, and it's now part of the software life cycle. Till now it's not part of the software life cycle, guys, but from level 3 TMM falling projects, in level 3 TMM following projects, this kind of approach is followed where testing is integrated with the software lifecycle and is performed independently after the development phase. Okay, after the development phase of STLC, the testing will start and it's performed independently. That's the main thing. Here testing is not performed independently, but here testing is performed independently. Okay, here developers, testers, maybe, okay, they will work as a team and do something, but it's not a separate thing. Okay, the developers may also perform testing here, but here it's an independent thing, guys. Okay, so it's a independent team will be there and they are separating the development activities from the testing activities, and they are seriously testing, and now it is seriously recognized in the software life cycle. Okay, here there is no particular place, but here in software life cycle there is a one phase like testing phase which comes after the development phase. Okay, such kind of projects which fall into the level 3 follow this software testing process. Okay, where testing is independent and all. Okay, and is part of the software life cycle. Here the objective of the testing, okay, in the level 3, the objective of the testing is to manage risk. Okay, we are going to manage the risk. We'll reduce the number of defects, and after releasing the software into the market, the risk should be reduced, guys. Okay, the problem should be reduced before the software is released into the market. We are going to identify most of the defects with an intention of managing the risk after the software gets released in the market. Okay, so that's what is the level 3, guys. Coming to the level 4. Level 4 TMM is called as measurement and management level. Okay, till now we are not measuring the software testing process. Okay, we are not measuring the testing, how much testing is being done, and all those things we have not measured. But here, level 4 testing is measured, guys. Okay, till level 3 the testing is not measured, but in level 4 testing is measured, and here testing becomes part of all activities in software lifecycle. Here only one phase of software testing. Here, testing is only one phase of software lifecycle which comes after the development phase in level 3 and is performed independently. Here also testing is performed independently, but thing is that testing becomes part of all activities in software lifecycle. Okay, all activities means what? Across all phases in software lifecycle, that is in the during the requirements phase, design phase, coding phase. Okay, we'll review the requirements. We'll review the designs created by the developers. We'll review the code written by the developers. Then in coding phase, developers will perform unit testing, integration testing. You see, testing is part of all the phases of a software life cycle here, right? So more here testing only starts after development in level 3, but here in level 4, testing is like intact with all the phases of software life cycle, all activities of software life cycle, starting of the software development to the ending of the software development. That is through the entire software life cycle, testing will be there in different forms. Like in the beginning, it will be in the review forms for requirements design and coding phases. In coding phase, again, unit testing, integration testing will be done in the testing phase. In the after coding, right, system testing will be performed, acceptance testing will be performed, and so on. So it is involved in all the activities in software life cycle as part of level 4, and also it is measured now. Okay, in all phases, in all activities of software life cycle, it is there, and each and every testing thing is measured here. Okay, whether it may be reviews or it may be unit testing, integration, system accept, everything will be measured here. How much amount of testing is done is measured here, which is not done in the, which is not generally measured in the level 3, guys. Now final level of TMM, which projects fall into the TMM level 5, that is optimization. Okay, level, optimization level. Here testing, here on the top of level 4, guys, testing process is optimized. Okay, here till now we are performing testing, guys, and in all activities, all activities in software lifecycle, testing is there in different forms, and we are measuring that. But here testing process is optimized for level 5. So projects which fall into the level 5 TMM, in that software testing process is optimized, guys, that is improvised. Okay, so here testing in such projects, guys, testing process is verified. Okay, we will assess the testing process, and also on the top of that we'll take the measures to improvise it. Okay, it's not just about following the testing process. Here we are going to assess the current testing process that is followed in the projects, and with an intention of improvising it and optimizing it. Okay, more better and better will make it. So here, if you make the testing process more better and better and optimize, what will happen? The process will prevent the defects, right? The process, by improvising, automatically the defects will be prevented. Instead of just detecting the defects that has been done till level 4, okay? But here, level 5, since we are improvising the testing process and optimizing it, the defects will get prevented, okay? They will not occur actually, okay? Before we identify, they don't occur. So it here, a next level where we are stopping the defects from occurring. Okay, prevention is better than cure kind of thing. Okay, so here testing is performed with different tools, guys, and also we are going to take the help of different tools here with an which can optimize our testing. Okay, so we are going to use different type of tools which are required in our software testing process, which can optimize the testing process. Okay, so these are the 5 levels of TMM, guys. So finally, to conclude, guys, test maturity model TMM is nothing but a framework for assessing the maturity of the software testing process with an intention of improving it. And it's based on CMM, and it has 5 levels: level 1, level 2, level 3, level 4, level 5, initial, definition, integration, measurement and management, and optimization levels. So hope, guys, you got the answer for what is test maturity model now. So that's all for this session. See you in the next session. Thank you. Bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 79. That is, what is capability maturity model? Let me answer. Capability maturity model, in short known as CMM, is used to measure the maturity level of the process followed by software organizations for producing software into the market. In simple words, CMM is used to measure the maturity of process followed by software organizations. Why? Why the CMM has to measure the maturity of the process followed by software organizations with an intention of improvising it or improving it. Okay, that's the actual purpose. There are 5 levels in this CMM, that is capability maturity model has 5 levels based on which the maturity level of the process followed by software organizations is decided. Level 1. Level 1 means initial. Okay, initial. So if the software organization process is a ad hoc process. Okay, the software organization is following an ad hoc process for producing the software into the market without there is no proper process here. Okay, in that case we can call that CMM level of that particular organization as level 1. Okay, coming to the level 2, guys, it's known as managed. Okay, second level is managed level. Here process will be there. Okay, process are planned. Okay, for a particular project needs, process will be planned, process will be documented, process will be implemented, monitored, and controlled. That is second level. Now coming to the third level, that is defined level. So well-defined standard and established process. Okay, here general process is there. Okay, it's just process is followed. That's it. Here no process, direct ad hoc process. Here no process. In second level, we have the process followed, but in third level, a well-defined process. Okay, well-defined standard and established process is followed across the entire organization, not just a single project, but across organization. All the projects will follow the same well-defined standard established process. Then we can call it as level 3. Then level 4, quantitatively managed level. Okay, here process is not just followed but is also measured and controlled, guys. Okay, it's also measured. Okay, measurement is the main word here. Okay, it's measured. Here simply in the previous level 2, level 3, the process are followed, but they are not measured. Here it is measured, and if anything is going wrong, it's controlled. It's again brought to the same. Okay, so proper direction. If it's not going well, the process is not going well, modifications will be made and brought to the proper level. Okay, that's process is measured and then it is controlled. Okay, now coming to the last level, it's called as optimizing level. Okay, here continuous process improvement is there. Okay, it's not just followed, process not just followed or measured, it's continuously improved. Day by day, the process is improved. Continuous process implementation is there in this level of okay CMM. So hope guys you got the answer for what is capability maturity model in this session. See you in the next session where I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 80. That is, what is forward traceability matrix? Let me answer. Forward traceability matrix is one of the types of RTM. RTM stands for requirements traceability matrix. There are different types of RTMs where forward traceability matrix is one of the types of RTM. What is the purpose of RTM? First of all, the purpose of the RTM is to map the requirements, application requirements with the test cases which are created by the software testers. Okay, the application requirements are mapped with the test cases with the help of RTM, but RTM is of different types. Okay, there are different ways you can create RTM. There are different types of RTMs we can create to map the requirements with the test case. What are the different types available? Forward traceability matrix is one type. Backward traceability matrix is another type. Bi-directional traceability matrix is another type. Okay, there are three types of RTM where forward traceability matrix is one of the types of RTM which is used for mapping the requirements with the test cases. But what is the process followed by this forward traceability matrix type for mapping the requirements with the test cases? With forward traceability matrix, we first step is the first step we derive the requirements, guys. Okay, to create this forward traceability matrix, which is a type of RTM, we first derive the test cases. Okay, we have two things: requirements are there, test cases are there. But out of the requirements and test cases in forward traceability matrix, what you are going to derive first? All the application requirements you are going to derive first. That is a step one. What you are going to do in step two? In step two, all these derived requirements are mentioned in this FTM, that is forward traceability matrix. Okay, whatever the derived requirements are there that you are going to provide, that requirement IDs and description of the requirements you are going to provide in the RTM template, that is a forward traceability matrix RTM template. Okay, so after the requirements are derived and after all these requirements along with the requirement IDs and descriptions are provided in this RTM template, that is forward traceability matrix template, finally each and every requirement will be mapped to the respective test case. Okay, the third step is the third step in creating this forward traceability matrix is each and every specified requirement, that requirement ID and description, right, that is going to be mapped with the respective test cases. Mapping the requirements with the test case comes in the third step, guys. Okay, so why this forward traceability matrix is required? What is the purpose? Why people generally use forward traceability matrix, where first they derive the requirements, then they are going to document all these requirements in this template, and then map each and every requirement with the respective test cases? Why this process is followed is, what is the purpose? Is to check whether each requirement is tested thoroughly or not. Okay, to check whether each and every requirement is tested thoroughly or not, we have to create this forward traceability matrix where requirements will be derived first, then requirements will be documented into the template next, and then each and every requirement is mapped with the test cases. The purpose of creating this forward traceability matrix is to check whether each requirement is thoroughly tested, each requirement is thoroughly tested. So that is forward traceability matrix. Let me show you an image for forward traceability matrix. You see here, first requirements will be derived, okay, and documented in this traceability matrix, that is forward traceability matrix, and each and every requirement ID is now getting mapped with the test cases as part of the third step. This is called as forward traceability matrix. And there are other traceability matrix like backward traceability and bidirectional also as part of the RTM types. So in this session, since I have to answer this question, what is forward traceability matrix? I'm only explaining what is forward traceability matrix. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 81. That is, what is spillover in Agile Scrum? Let me answer. In simple words, spillover is nothing but the work that is not completed by the end of the sprint. Even though the sprint is completed, if there is some work that is left out, that left out work is known as spillover, guys, in simple words. But if I have to explain in detail, I have to go with the basics like there are several SDLC models, right? In different projects follow different SDLC models like waterfall model, V model, RAD model, and so on. Agile SDLC model is one of them. Under Agile SDLC model, there are several methodologies like Scrum, Kanban, and so on, extreme programming, and so on. Scrum is one of the methodology of Agile SDLC. So, especially if your project is following the Scrum methodology of this Agile SDLC model, in that case, the work will be done in the form of sprints. Okay, so iterations will be there: iteration 1, iteration 2, iteration 3, and every iteration incrementation will of the software development or testing will happen, right? So that iteration duration will be generally 1 to 4 weeks. So that is nothing but a sprint, right? Sprint is nothing but the iteration which is having a duration of 1 to 4 weeks. So for that 1 to 4 weeks, some work will be assigned in the form of stories. Okay, if your project is following this Scrum methodology as part of Agile SDL's model, in that case, the work will be divided into multiple portions, like that is iterations, guys. Okay, first, after first iteration is done, second iteration will be done, then third iteration, and so on. That iterations are nothing but sprints. So by the end of the each sprint, that is each iteration, some work need to be completed. That work is nothing but stories, right? Stories will be assigned by the product owner to the sprint, and the team, Agile team, has to work that these developers and testers have to complete these stories by the end of the sprint. That's what is the thing. But if any case, okay, if any situation happen where by the end of the sprint, that is sprint can be 1 week to 4 week duration, right? By the end of that 1 to 4 weeks, whatever that duration that is decided for this project as part of the sprint, if there is still work is pending, okay, by the end of the sprint also some work is not completed, that uncompleted work is known as spillover. Okay, within that sprint, the work has to be completed. If there is some left out work after the end of the sprint, also if there is left out work which is not completed by the team as estimated, also that left out work is known as spillover in simple terms and in detail explained. So what are the reasons why the work will be left over by the end of the sprint? What may be the reasons? There are many reasons, guys. Okay, there are many reasons. But for example, I listed down 3 reasons here. So one of the reason may be more work than the capacity. Okay, there are like 5 to 6 people and they can do this much of work, but if you overburden them and assign them more work, okay, if someone is assigning more work and the team has overcommitted the work, okay, they decided to come work on that overcommit, I mean that overburdened work they have taken up, they committed to complete that over capacity work within that sprint, which will not be possible, right? So within that sprint, if someone is assigning you more work, that will not happen. Okay, that may be one of the reason for spillover. Second reason will be during the project, guys, during that particular sprint, that 1 week to 4 weeks, let's say 2 weeks is a sprint duration, that is 10 working days. In the 10 working days, you have estimated the work and you have within the capacity you have accepted the work and you are working on that. But during that period, there came some extra discussions between the different team members, developers, testers, and business. Some discussions came, because of which some modifications happened. Okay, some more feedback we got in the form of change request or something. Okay, extra work we got in the form of feedback. So that extra work will add to the spillover. Okay, some 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 situations that extra work also the team will complete, but in some situations, despite of doing the hard work and all, if the team is not able to fulfill the complete the work by the end of the sprint because of this unplanned work coming in the coming between the sprint, in between the sprint, because of that extra feedback or extra changes happened during the discussions between the team. Okay, that also is another reason for spillover. And other thing is that the team has worked, okay, the team has worked on as per the estimations and all, the capacity and all is very good and the team has worked, but due to some XYZ reasons, the team was unable to, okay, unable to come I mean get these stories accepted by the business, okay, or some other things, okay, due to some XYZ reason, the stories are not completed. They have given their 100% and they have done the work also, but the work has not been accepted by someone. That is a product owner or something during the review or whatever it is. The work has not been completed. That is definition of done for this particular stories is not done because of some XYZ reason. If it is not done again, these pending work will go into the spillover only, right? Spillover. It's nothing but the spillover. These are the different reasons for spillover, guys. There may be other reasons also. The major reasons causing the spillover in Agile, Scrum methodology sprints. These are the examples, okay? We have more reasons for the spillover also. So hope, guys, you got the answer for what is spillover in Agile Scrum. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye-bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 81. That is, what is spillover in Agile Scrum? Let me answer. In simple words, spillover is nothing but the work that is not completed by the end of the sprint. Even though the sprint is completed, if there is some work that is left out, that left out work is known as spillover, guys, in simple words. But if I have to explain in detail, I have to go with the basics like there are several STLC models, right? In different projects follow different STLC models like waterfall model, V model, RAD model, and so on. Agile STLC model is one of them. Under Agile STLC model, there are several methodologies like Scrum, Kanban, and so on, extreme programming, and so on. Scrum is one of the methodology of Agile STLC. So, especially if your project is following the Scrum methodology of this Agile STLC model, in that case, the work will be done in the form of sprints, okay? So iterations will be there. Iteration 1, iteration 2, iteration 3, and every iteration incrementation will, of the software development or testing will happen, right? So that iteration duration will be generally 1 to 4 weeks. So that is nothing but a sprint, right? Sprint is nothing but the iteration which is having a duration of 1 to 4 weeks. So for that 1 to 4 weeks, some work will be assigned in the form of stories, okay? If your project is following this Scrum methodology as part of Agile SDLC model, in that case, the work will be divided into multiple portions, like that is iterations, guys. Okay. After first iteration is done, second iteration will be done, then third iteration, and so on. That iterations are nothing but sprints. So by the end of the each sprint, that is each iteration, some work need to be completed. That work is nothing but stories, right? Stories will be assigned by the product owner to the sprint, and the team, Agile team, has to work that these developers and testers have to complete these stories by the end of the sprint. That's what is the thing. But if any case, okay, if any situation happen where by the end of the sprint, that is sprint can be 1 week to 4 week duration, right? By the end of that 1 to 4 weeks, whatever that duration that is decided for this project as part of the sprint, if there is still work is pending, okay, by the end of the sprint also some work is not completed, that uncompleted work is known as spillover, okay? Within that sprint, the work has to be completed. If there is some left out work after the end of the sprint also, if there is left out work which is not completed by the team as estimated also, that left out work is known as spillover in simple terms and in detail explained. So what are the reasons why the work will be left over by the end of the sprint? What may be the reasons? There are many reasons, guys, okay? There are many reasons, but for example, I listed down 3 reasons here. So one of the reason may be more work than the capacity, okay? If there are like 5 to 6 people and they can do this much of work, but if you overburden them and assign them more work, okay, if someone is assigning more work and the team has overcommitted the work, okay, they decided to come work on that overcommit, I mean that overburdened work they have taken up, they committed to complete that over capacity work within that sprint, which will not be possible, right? So within that sprint, if someone is assigning you more work, that will not happen, okay? That may be one of the reason for spillover. Second reason will be during the project, guys, during that particular sprint, that 1 week to 4 weeks, let's say 2 weeks is a sprint duration, that is 10 working days. In the 10 working days, you have estimated the work and you have within the capacity you have accepted the work and you are working on that. But during that period, there came some extra discussions between the different team members, developers, testers, and business. Some discussions came, because of which some modifications happened, okay? Some more feedback we got in the form of change request or something, okay? Extra work we got in the form of feedback. So that extra work will add to the spillover, okay? some 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 situations, that extra work also the team will complete, but in some situations despite of doing the hard work and all, if the team is not able to fulfill the complete the work by the end of the sprint because of this unplanned work coming in the coming between the sprint, in between the sprint, because of that extra feedback or extra changes happened during the discussions between the team. Okay, that also is another reason for spillover. And other thing is that the team has worked. Okay, the team has worked on as per the estimations and all, the capacity and all is very good, and the team has worked. But due to some XYZ reasons, the team was unable to, okay, unable to come. Get these stories accepted by the business, okay, or some other things. Okay, due to some XYZ reason, the stories are not completed. They have given their 100% and they have done the work also, but the stories, the work has not been accepted by someone, that is a product owner or something, during the review or whatever it is. The work has not been completed, that is definition of done for this particular stories is not done because of some XYZ reason. If it is not done, again these pending things, pending work will go into the spillover only, right? Spillover, it's nothing but the spillover. These are the different reasons for spillover, guys. There may be other reasons also. The major reasons causing the spillover in agile scrum methodology sprints, these are the examples. Okay, we have more reasons for the spillover also. So hope guys you got the answer for what is spillover in agile scrum. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 82. That is, what is DOR in Agile Scrum? Let me answer. DOR stands for definition of ready. But what exactly is this definition of ready? To understand what exactly is this definition of ready, you should have some basic knowledge about Agile. Okay? Let me give you the basic knowledge of Agile that is required for understanding DOR. So first of all, what is Agile? So there are several SDLC models. Okay, for developing the software, for producing the software, there are several SDLC models. Agile is one of the SDLC model. Okay, apart from Agile, we have waterfall model, V model, RAD model, and so on. Agile is one of the SDLC model we have. So this Agile SDLC model has a lot of methodologies. Okay, a lot of frameworks or methodologies. One of the methodology we have is a Scrum methodology. So in Scrum methodology, how the work will go on? You see, the work will happen in the Scrum methodology in the form of sprints. Okay, sprint means iteration. After first iteration is done, then second iteration. Okay, this is all about Scrum, guys. Whatever I'm explaining is all about Scrum. Okay, so the first iteration, second iteration, like that, the work will keep on happening in the case of Scrum. Fine. So what is work here? But what exactly is work? Who is going to work on this in the sprints? Here there will be something known as agile team. Okay, we have agile team in the scrum. The scrum, there will be something known as sprints. Okay, this sprint one means iteration one, sprint two. So work will be done in multiple sprints. Each and every sprint or iteration will be having a duration of 1 to 4 weeks. So who will be working in the sprints? Who will be working in this multiple iterations? Agile team will be working in multiple iterations. So agile team means what? The developers and testers, right? Dev team and testing team are going to start working here and complete their work assigned for this particular iteration or sprint by the end of the sprint. Okay, whatever the work that is assigned in the beginning of the sprint, the agile team, that is dev team and testing team, has to complete by the end of the sprint. So to start working for this particular agile team, for this particular development and testing team to start working on their work and finish them by the end of the sprint, the work should be there now. Okay, the work should be ready. Okay, so can we start working? Do we have all the necessary things to start working on the things? For example, if you ask some person to construct a building, can the person directly construct the building? No, the person has to see whether all the necessary things are there for building or constructing the building. So is a sand available? Okay, are the bricks available? Okay, all the construction material available for this particular to start building it, start constructing the building, all the necessary items should be there, right? Then only they can start working. Here also, for this agile team to start working, what the agile team, that is Java and testing team, will start working in the sprints. They work on the user stories. Here work is nothing but here material for constructing the building. Here material for constructing the building, right? Here material is nothing but user stories. Okay, they require small chunks of requirements. User stories are nothing but the requirements. So If these user stories are ready, then only the dev team and testing team, that is agile team, can start working, right? So when we can say that user stories are ready, if user stories are ready, we can say DOR. Okay, DOR means definition of ready. That is, user stories are ready for starting working. Okay, for the development and testing team to start working for this sprint, the user stories need to be ready. So when user story is ready, we can say DOR status as fine. Okay, DOR definition of ready. User story definition of ready. Is it ready or not? If it is ready, then the agile team can start working on the user stories. When we can say that the user stories are ready for the agile team to start working on the sprint, start working on these user stories in the sprint, when we can say these user stories are ready, the criteria for DOR for the user stories is acceptance criteria for the user story is properly defined. Okay, who will write the acceptance criteria for the user story? Product owner will create the acceptance criteria for the user story. Okay, is it properly written by the product owner or not? Okay, if the acceptance criteria is not mentioned for the user story, that means user story is not DOR. Okay, it's not ready to start working for the development and testing to start working. The user story is not ready. So user story has clear business value. Okay, so not just writing the acceptance criteria, guys. Product owner has to make sure that the particular story has a proper business value. Okay, then it is estimated well. The user story need to be estimated well. Then all dependencies for the user story are identified and mentioned in that particular user story by the product owner. All this need to be there in the user story. Then only we can say that DOR for the user story. Okay, the user story is ready for start working on. Okay, definition of ready. User story is understood by the team, not just writing, guys. The whenever the agile team goes through this acceptance criteria or whatever the details provided by the product owner in the user story, the agile team need to understand. Without understanding, how can they start working, right? So only when the user stories are ready for working, we can say DOR, definition of ready. So hope guys you got an idea what exactly is DOR. DOR means definition of ready. Whether the user stories are ready to start working in the sprint or not by the agile team is known as DOR in simple words. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 83. That is, what is DOD in Agile Scrum? Let me answer. DOD stands for definition of done. To understand what exactly is this DOD, you have to first understand what is Agile, and under Agile what is Scrum, under Scrum what is Sprint. All these terms you have to understand. So let me explain that basic things that you need to learn before understanding what is DOD. Okay, so first one is Agile SDLC. So what is Agile SDLC? There are several SDLC models that are followed by the projects for producing the software, right? Like waterfall model, V model, RAD model, and so on. Agile SDLC model is one of them. So under Agile, we have different methodologies or frameworks. Okay, you can either call them as methodologies or framework. One of the one of the popular methodology we have is Scrum. Okay, which is followed by most of the projects. Scrum methodology. Under Agile SDLC model, Scrum methodology is there. So what is the Scrum methodology? As per Scrum methodology, the project work will happen something like this. Okay, so it will happen in iterations. First iteration, then next piece of work will be done in the second iteration, then third iteration, fourth iteration, and so on, guys. Each and every iteration is known as sprint. Sprint one, let's say the first one is sprint one, the second one is sprint two, and sprint three, sprint four. Each and every sprint is nothing but an iteration. It generally has a duration of 1 week to 4 weeks. So in that, this is starting of the sprint, starting of the iteration, this is ending of the iteration. That is, it can be 1 week to 4 weeks. For example, if you take the sprint duration as 2 weeks, it's nothing but 10 working days. Okay, though it is 14 days, but it is 10 working days only. Okay, in the 10 working days, the work assigned to this particular sprint need to be completed by the agile team. Who need to complete the work? Here, agile team has to complete the work. Who are other agile team? Who are part of the agile team? Developers and testers, right? Developers and testers are generally known as agile team. In Scrum, you call these developers and testers as agile team. These agile team, that is developers and testers, are going to start the work here and finish the work by the end of the sprint. Okay, So if it is 2 weeks duration, 10 or in 10 working days, this agile team has to complete the work. So far, so good. You see what happens here is there will be some role known as product owner. The product owner is the one who will create these user stories. Okay, in Agile Scrum, user stories will be created by the product owner. These user stories are nothing but work, guys. Okay, these are the requirements. These are the user stories are nothing but the small pieces of requirements which need to be developed and tested by the testing team and to be completed their work by the end of the sprint. So here user stories will be assigned in the beginning of the sprint. The user stories will be assigned. These user stories will be picked by the developers and testers, and the developers will develop these user stories according to the requirements. And testing team will test this as per as mentioned in the user stories and all. And they have to complete by the end of the sprint. Okay, these work the testers and developers have to complete by the end of the sprint. When can we say that the user stories are really completed? When can we say that the user this particular user story is completed? Or when can we say that the sprint is completed? When can we say that after a few sprints, right, the software will be released into the market? The software will be released into the market. When can we say that the software is ready to be released into the market? When can we say that the sprint is ready? Sprint is completed. When can we say that software can be released? When can we say that the particular each and individual user story is completed, is working, is developed and tested properly? When can we say that? So all these things are related to definition of done, guys. You see, the user story completion is also related to definition of done. Sprint completion is also related to definition of done. These are all works, guys. Okay, individual works. User story is a requirement. When can we say that the requirement is properly developed and tested completely? That is also related definition of done. When can we say that the entire iteration, that is 2 weeks or whatever it is, the work assigned to that particular sprint is completed? When can we say that is assigned to? That is nothing but related to definition of done. When can we say that the software can be released into the market? Software is now ready for releasing into the market. Again, that is also related to definition of done, guys. So let's understand what is definition of done now. Okay, definition of done in simple terms is nothing but a checklist, guys. Okay, it's a checklist of items which decide the work that is assigned to the team has been completed or not. Okay, with the help of this DOD checklist, we can check whether the user story is completed or not. Okay, with the help of this checklist of things. Okay, if the development team and testing team, okay, are according to the, okay, their work is according to the work completion is according to the checklist as mentioned in the checklist. If the work is done, in that case we can say the work is completed, right? The user story can be completed if the checklist of items are satisfied. Okay, DOD means what? Definition of done, which is nothing but a checklist of the things which decide whether the work assigned to the team has been completed or not. With the help of this checklist, we can find it out whether the work has been really completed or not. This checklist is nothing but the DOD, definition of done. Okay, so how this checklist will decide whether the work, that is user story, is completed or sprint is complete, sprint work is completed or software release work is completed? How this checklist will decide? Based on this criteria. Okay, coming to the user story, guys. Okay, specifically this criteria is mainly about the user story. So when can we say that the user story is completed? Okay, the work, that is the requirement that is mentioned in the user story. When can we say that developers and testers have developed and tested this particular user story completely? And when can we say that this particular user story work is completed? Is this is the criteria we have to follow. User story built without any errors. Okay, user story built without any errors. That means developers have developed this particular software. Developers have developed the functionality of the application according to the requirements mentioned in the user story. Okay, without any errors, the software is working. Okay, the functionality related to this particular user story requirement is working in the software without any errors. Then we can say that. And also user story is tested against. Okay, to confirm that there are no errors, testing need to be performed, right? Developer have to develop it, developer has to build it, and testers have to test it. Then only we can say the user story built without any errors means that's what we can say. Development and testing should happen properly. Then user story is tested against acceptance criteria. So who will provide the acceptance criteria? Product owner will provide the acceptance criteria. According to the mentioned acceptance criteria and business needs, the user story is properly developed and tested. Okay. If the story, if the functionality of the application is working as mentioned, as per the acceptance criteria mentioned in the user story, which is properly tested, then we can say this is one of the criteria, guys, to decide definition of done for a user story. Okay, so user story is demoed to stakeholders. So to mention that the user story is done, another item we have to consider here is a demo will happen, guys. Okay, the demo will happen at the end of the sprint. Once the work is done, the work will be demonstrated to the stakeholders and the product owner. Okay, stakeholders and product owner, the work will be demoed and they have to accept that. The product owner has to accept the work. done by the developers and testers, then only we can say the story is completed. So what is DOD again? To conclude, guys, DOD is nothing but the checklist of things which will decide whether the work assigned to the Agile team has been really completed or not. Okay, a checklist which decides whether the work assigned to the development and testing team, that is Agile team, is really completed or not. DOD applies for user story to see whether user story is really completed. DOD checklist can be used with the sprint to decide whether the sprint has been the work assigned to that particular sprint is really completed or not. DOD can also be related to the release to see whether the work that is assigned to the team as part of building the software so that it can be released into the market is really done or not. Work is done or not for releasing the software into the market. To decide that, we can use DOD for all these needs. So hope guys you got an idea what exactly is DOD in Agile Scrum now. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 84. That is, what is backward traceability matrix? Let me answer. Backward traceability matrix is one of the types of RTMs. Okay. So there are multiple types of RTMs like forward traceability matrix, backward traceability matrix, and bi-directional traceability matrix, where backward traceability matrix is one of the type of RTM. Where what is RTM then? RTM stands for requirements traceability matrix. Okay, the full form of RTM is requirements traceability matrix. The purpose of the RTM is to map the requirements with the test cases. Okay, so no matter which type of RTM you are referring, the only purpose is to map the requirements with the test cases. Okay, the client specified requirements will be mapped with the tester created test cases. That's what is RTM purpose. But there are different types of RTMs, as I already mentioned, where backward traceability matrix is one of the types of RTM. So how this backward traceability matrix is created? What is the process of creating the backward traceability matrix? So to get started, guys, okay, we'll start with the test cases. Okay, so test cases will be mentioned in the backward traceability matrix in the document, that is RTM document. If that RTM type is backward traceability matrix, the first column will be the test cases. So the test case IDs will be mentioned in the first column, and for each and every test case ID, okay, for each and every test case ID, it will be mapped with the respective requirements in the next phase. First, all the test case IDs will be mentioned in the RTM document, and these test cases will be mapped with the requirements. So here, test cases are identified first. After that, these test cases are getting mapped to the requirements. Requirements are not mapped to the test cases. Test cases are getting mapped to the requirements. That is what is backward traceability matrix. Okay. Here we are mapping the test cases with the requirements in the reverse direction. So since we are generally, if you talk about RTM, we generally say that RTM maps requirements with the test cases, right? So this is actual way, right? Where requirements are mapped with the test cases, actual way. But in case of backward traceability matrix, the reverse process is happening where instead of requirements getting mapped with the test cases are getting mapped with the requirements. Okay. First test cases are identified, and for each and every test case ID, we are mapping with the requirements in a reverse way. That's why backward traceability matrix is also known as reverse traceability matrix, because the process is happening in a reverse manner where first test case IDs are mentioned in the RTM document, and for each and every test case ID, we are mapping the test case IDs with the requirements. So what is the purpose? Why we have to map the test cases with the requirements in this backward traceability matrix, and what is the benefit that we are going to achieve? So the benefit here is, so we can check the current scope of testing, guys. Okay, with the help of the backward traceability matrix, we can check by mapping the test cases with the requirements, we can check the current scope of testing by verifying whether any new functionalities are added to the requirements for which test cases are not documented in a reverse way. Okay, here the purpose is simply to find out the current scope of testing. Are there any changes in the current scope of testing because of any new functionalities or changes happened in the requirement level? Okay, to find out that, to figure out the current scope of testing, the testers have to actually perform. To do that, we create the backward traceability matrix. As you can see in this image, guys, how the backward traceability matrix will work. You see, first test case IDs will be derived. Okay, for each and every test case ID will be mapped with the requirement IDs. Okay, the test case IDs will be mapped in a reverse way to the requirements, and the purpose is to see whether the current scope of the testing is same or any changes happened because of any new functionalities or change requests added to the requirements. Okay, so whatever the test cases that are not documented, we can identify and see what is the current scope of testing. Are there any changes in the current scope of testing? We have to identify with the help of the backward traceability matrix. So hope guys you understood what exactly is a backward traceability matrix in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 85. That is, what is bidirectional traceability matrix? Let me answer. Bidirectional traceability matrix is one of the types of RTM. While RTM means mapping the requirements with the test cases. Okay, the full form of RTM is requirement traceability matrix, whose purpose is to map the requirements with the test cases. That's what is the purpose of the RTM, but there are different types of RTM. So the way we map the requirements with the test cases, okay, there are different ways in which we can map the requirements with the test cases. So based on the different ways, there are different types of RTM. One is forward traceability matrix, other one is backward traceability matrix, and we also have the bidirectional traceability matrix. So bidirectional traceability matrix is one of the types of RTM we have. And what exactly is this bidirectional traceability matrix? So it's a combination of forward traceability matrix and backward traceability matrix. Okay, what is bidirectional? It's a combination of, okay, forward traceability matrix and backward traceability matrix. So what is the purpose of this bidirectional traceability matrix? Using this bidirectional traceability matrix, we can traverse, okay, we can trace in both the directions. Okay, we can trace in both the directions. That is, we can trace the test cases with the help of requirements, and we can trace the requirements with the help of the test cases. In both the directions we can trace. Okay, and we'll get the benefit of both this forward traceability matrix and backward traceability matrix. Both the benefits we get in a single traceability matrix, that is bidirectional traceability matrix. As you can see in this image guys, bidirectional traceability matrix is a combination of forward traceability matrix and backward traceability matrix, where what happens is, here to create this bidirectional traceability matrix RTM thing, we are going to map the requirements with the test cases, and at the same time parallelly we are going to map the test case with the requirements. So mapping is happening in forward direction and reverse direction at the same time. So this is what is bidirectional traceability matrix, and you already have understood the purpose, right? So with the help of this bidirectional traceability matrix, we can trace in both the directions. Okay, we can trace the requirements with the help of test cases, and we can trace the test case with the help of the requirements, and both the directions are possible. Okay, tracing in both the directions, and the combined benefit. Okay, whatever the benefit we get with the forward traceability matrix, and whatever the benefit we generally get with backward traceability matrix, both the benefits we get with the bidirectional traceability matrix. So this is what is bidirectional traceability matrix, guys. Okay. So hope guys you understood what exactly is bidirectional traceability matrix. So that's all for this session. In the next session, I am going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I am going to answer software testing interview question 86. That is, what is software testing lifecycle? Let me answer. Software testing lifecycle, in short, is known as STLC. And this STLC is nothing but sequence of phases. Okay, STLC is nothing but sequence of phases followed while testing the software from start to end. I'll show you a diagram here. Okay, from this you can understand this line. What is STLC? STLC is nothing but a sequence of phases. You see there are 5 phases here, different colors. Requirement analysis is one phase, test planning is another phase, test designing is another phase, test execution is another phase, and test closure is the last phase. Okay, so one after the another, the phases are coming. Sequence of phases. First phase is requirement analysis, then test planning. Like that, it is a sequence of phases which are followed while testing the software. When this sequence of phases are followed while testing the software, the testing team will follow the sequence of phases from start to end of the project. Okay, while testing the software, the testing team will follow the sequence of phases from start to end. Okay, so these are the different phases we have. So as you can see in this diagram, that is requirement analysis, test planning, test designing, test execution, and test closure are the 5 phases of the STLC. You see the same thing are mentioned here. These are the different phases of STLC. That is requirement analysis, test planning, test designing, test execution, test closure. Coming to the first phase, that is requirement analysis phase. Okay, so entry criteria, each and every phase will have an entry criteria and exit criteria, and during this phase we'll perform something. Okay, so what is entry criteria, what is exit criteria? For each and every phase in this STLC, there is an entry criteria and exit criteria. So what is the entry criteria, what is exit criteria, we'll discuss. Okay, so to start this phase, we need to satisfy this entry criteria. Okay, only when this entry criteria is met, then only we can start this phase. Okay, as part of software testing, while testing the software, if you want to perform requirement analysis phase, when to start this requirement analysis phase? When this entry criteria is met. And when to stop this requirement analysis and move to the next phase? When we match this and exit criteria. Okay, so to stop this phase and go to the next phase, okay, from requirement analysis, if you want to go to the test planning phase, you have to match with exit criteria. Okay, you have to other to the exit criteria. When exit criteria is matched, then only we can move to the next phase, like that. So to enter, to exit, these are the criteria. So what is the entry criteria for the requirement analysis and what is exit criteria for the requirement analysis? Let me show. So for requirement analysis, the entry criteria is the requirements itself. Okay, without the client giving you the requirements, how can you start testing, right? So we have to perform requirement analysis first. Okay, so any project when it starts, right, the development team and testing team has to understand and go through the requirements. Especially testing team, to perform the testing, guys, they have to understand the requirements, right? So then only they can start the testing. So the first phase in STLC will be requirement analysis phase, where when can we start the requirement analysis phase? When can the software testers can start this requirement analysis phase? When the requirements are provided in the form of some BRS document, etc. Okay, in different forms, the client team will be sharing the requirements. Okay, the software testers will be receiving the requirements of the software that has to be tested in different ways. So most of the cases it will be like BRS document. Okay, business requirement specification document. So when the client gives you this BRS document, then that is the entry criteria to start the requirement analysis phase. Okay, so let's assume that the BRS document has been given by the client and entry criteria for the requirement analysis phase is met, and we have started performing the requirement analysis. That software testing team has started performing the requirement analysis. So what will be the actions performed by the testing team as part of this requirement analysis phase? So in this requirement analysis phase, the testing team will go through this BRS document. All the requirements that are mentioned in this BRS document or in the given requirements, the testing team will go through, understand those requirements. Okay, and also if some of the requirements are not understood by the testing team, they will clarify the doubts with the client team. Okay, so they have to clarify with the business team or the client team. That's what the testing team will do. They will simply go through all the requirements given by the client one by one and understand them. And if they have not understood anything, they will clarify the doubts. That's the first step. And while doing this process, where going through the requirements, understanding and clarifying the doubts, the testing team will derive the testable requirements. Okay, not all requirements will be related to the testing purpose. Okay, some requirements will be for development team and all those stuff. Okay, the architectures and all will be there, which testing team doesn't need, right? They don't have to understand. The development team will understand that. But ultimately, in that BRS document or in the given requirements, right, whatever the requirements that testing team can use for testing purpose, that testable requirements will be derived and documented in a separate document. Okay, if required, the testing team will go through the requirements, understand them, clarify the doubts, and finally they will come up with a checklist of testable requirements that they can use for performing the testing. Okay, so they'll document this checklist of requirements in a separate document if required. So these are the two activities that the testing team will perform during the requirement analysis phase, guys. So when the testing team will exit this requirement analysis phase, when this exit criteria is met, then testing team will exit this requirement analysis phase. Okay, when we can say the requirement analysis can be exited, when this exit criteria of the requirement analysis can be met, when all the testable requirements are derived. Okay, all the requirements are understood by the testing team and they have all the doubts has been clarified for all the requirements that are mentioned in the BRS document. All the doubts about the requirements are clarified and the testing team has understood all the requirements, and the team has derived the on the top of this understanding, the testing team has derived the testable requirements. Okay, they derived the testable requirements from this BRS document or set of requirements given. So once the testing team is ready with all the testable requirements, okay, that are derived from this BRS document. So that is nothing but the exit criteria is met. Okay. So there the testing team can exit the requirement analysis phase when they are ready with the testable requirements derived from the given requirements documents or requirements. So this is the first phase. So what is the second phase we have after requirement analysis? Once all the testable requirements are derived from the requirements given by the client, then the testing team has to start the next phase, that is test planning phase. This test planning phase is also having the exit criteria, entry criteria, exit criteria, and there will be some actions performed, activities performed by the testing team during this second phase. Okay. So what is the entry criteria for the test plan? The same exit criteria of the previous phase is going to be the entry criteria for the test planning phase. That is, if the testing team has derived all the testable requirements from the given requirements by the client, that is exit criteria of the requirement analysis phase. The same thing is the entry criteria to start the test planning. Also the same, whatever the exit criteria of the previous phase, that is the entry criteria of the test planning phase. That is testable requirements are derived by the testing team. That is the entry criteria. So once this is met and once we start test planning, so what are the different activities that the testing team will perform while performing this while working on this test planning phase, while going through the second phase, that is test planning phase? Testing team will create a test plan document. Okay. So test plan and test strategy related documents will be created by the testing. So in some companies, guys, okay, the test strategy is part of the test plan, and in some cases, right, if the project is very big, the test strategy will be separated out of the test plan document. Okay, so most of the cases, test plan and test strategy will be together. Test strategy will be one of the part of the test plan, but in some cases where the project size is very big and they need a separate document for the strategy, the client may require a separate document for the test strategy. In that case, test plan will be created separately and test strategy will be created separately by the team. Okay. So in the test planning phase, the testing team will prepare the test plan and test strategy documents. Okay. That is the activity performed. So when the testing team can exit this test planning phase, that is exit criteria. What is exit criteria for the test planning phase? When this test plan and test strategy documents are reviewed and signed off by the client. Okay, once the testing team has prepared this test plan and test strategy documents, they will send this. Okay, the testing team will send this particular documents to the client for review. The client will go through this test plan and test strategy documents, review them, and if they are okay with this created plan and strategy, then client will sign off. Okay, approve that. Or if there are any feedback from the client, based on the feedback, we have to update the test plan test strategy and again send it to the client review. And once the client reviews and accepts that by signing off, then only this particular test planning phase will be completed. Okay. So the work done by the testing team here, that is the creation of the test plan and test strategy, should be approved by the client to go to the next phase. Okay. So that is exit criteria of the test planning phase, where the client has to sign off these documents. Okay. Once the client has signed off this test plan and test strategy documents, then we'll go to the next phase. Testing team will go to the next phase, that is test designing phase. The entry criteria of the test designing phase is same as exit criteria of the test planning phase. Okay, as you can see here, same. Okay, exit criteria of this test planning is nothing but the entry criteria of the test designing phase. That is, test plan is reviewed and signed off by the client. What are the different activities that software testers or testing team will perform during the test designing phase? In the test designing phase, first the software team will create the test scenarios. Okay, test scenarios will be created, and after the test scenarios are created, these scenarios will be sent to the client for review. Client has to approve these scenarios. Once these test scenarios are reviewed and approved by the client, for each and every test scenario, a multiple set of test cases will be created. Okay, test scenarios are nothing but the high level test cases. Okay, in simple words, test scenarios are nothing but the high level test cases. So before writing the in detail test cases, the software testing team first will create the list of test scenarios which are high level test cases. And once this high level test cases are approved by the client, that is test scenarios are approved by the client, reviewed and approved by the client, for each and every written scenario here, the testing team has to create multiple test cases. For each and every scenario, multiple test cases will be created by the testing team. And once this test cases, in detailed test cases document is created, these test cases will be again sent to the client for review. Client has to go through these test cases, review and approve them. Till then, they keep on working on the scenarios and test cases. Okay. So in this test designing phase, mainly the testing team will create the scenarios and followed by the test cases and get the scenarios and test cases reviewed by the client. Okay. So the exit criteria for the software testing team to exit this test designing phase and go to the next phase is these scenarios and test cases need to be reviewed and approved by the client. Okay. When these scenarios that and test cases that are created by the testing team are reviewed by and approved by the client, signed off by the client, then only the testing team can move to the next phase. That is The next phase we have is the test execution phase. In the test execution phase, again, the entry criteria of the test execution is nothing but the exit criteria of the test designing as usual. As you can see here, test scenarios and test cases are reviewed and signed off by the client. That is the entry criteria to start working on the test execution phase for the software testing team. So what are the different activities that software testing team will perform during the test execution phase? There are several activities that the software testing team will perform during the test execution phase. They are nothing but first application to be tested is received from the client. Okay, receiving the application from the without receiving the application that need to be tested by the testing team from the client, the testing team cannot start testing, right? So in the test execution phase, the application that need to be tested by the testing team will be received from the client. That's the first step. Okay, then what happens next is testing team will prepare all the test environments. Okay, for testing this application. Okay, so let's say there is a web application. The web application cannot be tested only in Chrome browser, right? We have to test the same application, Firefox browser, Opera browser, like that. Every application will have multiple supported environments in which it has to work. So in the testing team will prepare all these test environments. Okay, maybe it may be operating system related environments or browser related environments, whatever it is, based mobile environments or whatever it is. Based on that, based on the application and supported environments, the testing team has to prepare all the test environments in which they are going to test this application on, and they'll prepare these test environments and make them ready for testing. Okay, first application should be there. Application should be received from the client. After that, test environment should be ready for testing. The application, same application on multiple environments. For that, test environments are prepared and made ready for testing by the testing team as part of the activities. Third thing will be testing team will run the test cases. Okay, whatever the test cases that are created in the previous phase, that is test designing phase, which are reviewed and approved by the client, right? That particular test cases are run by the testing team, and results will be evaluated. Okay, test cases are executed, and some test cases will pass, some test cases will fail, like that. Okay, and apart from executing the test cases, guys, the testing team will also perform the exploratory testing. Okay, it's like a right, guided testing here, right? It's a guided testing, but it's like unguided testing where using the heuristics and cognitive thinking process of the testers, they will perform the exploratory testing with some plan and all. So test cases will be executed. On the top of that, if there is some more time, the exploratory testing will be performed. So these two things will be done by the software testing team. And while executing the test cases, while performing the exploratory testing, okay, the guided and unguided kind of process. Okay, so in both these cases, the testing team will come across some defects. Okay, some functionalities of the application may not be working as per the requirements. Okay, so as per the user needs or requirements, if some functionalities of the application are not working, in that case, the testing team will report the defects. Okay, the deviations from the requirements and deviations from the user needs and expectations, those kind of deviations in the functionalities while testing the application will be reported as defects, and these defects will be assigned to the developers for fixing. Developers have to fix these particular defects. Now let's say the developers have fixed some defects. Okay, so in that case, the testing team, apart from reporting the defects, the testing team has also retest the defects. Okay, has to retest the defects that are stated as fixed by developers. Okay, whatever the defects that are stated as fixed by developers, the testing team has to perform retesting to cross check whether the defects are really fixed by the developers or not. And these are general activities that software testing team will perform during the test execution. Apart from this, there may be other activities also, like there are different types of testing performed during this test execution phase and all, which I have not mentioned in this list. But at a high level, this is a list of the activities that software testing team will generally perform during the test execution phase. So to finish up this execution phase, what is required? When can the testing team exit this test execution phase? What is the exit criteria of the test execution phase? In other words, you see, software should look stable. Okay, these activities of testing, these testing activities in test execution phase, that is executing the test cases, exploratory testing, reporting the defects. Okay, all these things will be performed in multiple cycles. Okay, it will not happen in a single cycle of testing. Okay, so developers will be giving you multiple versions of the software, and in each and every version, the testing will be performed. Execution will be performed. It will take a lot of time, while the testing cycles will keep on going until the software looks stable. Okay, at some point of time, while the developers have fixed most of the defects in the software that are reported by the testers, slowly and slowly the software becomes stable and the quality of the software will rise. Okay, the software will reach a state where it becomes stable, and a kind of situation will come where the software looks very stable that it can be released into the market. Okay, so after a lot of cycles, testing cycles, this kind of state will come. So we have to wait. Okay, the testing team has to wait and continue the test execution phase until the software reaches a stable state and the team feels that it can be released into the market. Till then, testing will be performed as part of the test execution phase. And also, the testing team has also created a lot of reports for analyzing the state of the software that is ready for releasing into the market. Okay, so how many pending defects are there? Which functionalities of the application are kind of stable, unstable functionalities? Okay, what are the things like what is the quality level of the software that has been tested over a period of time? All these things reports will be created by the testing team. So once the software looks stable and a team feels that it can be released into the market, and also all the reports supporting this stableness of the software are ready, that will become the exit criteria of the test execution phase. Okay, that will become the exit criteria for the test execution phase. And testing team, once it meets this kind of exit criteria, will move to the next phase, that is test closure phase. And the entry criteria for the test closure phase is same as the exit criteria of the test execution phase. As usual, software should look stable and the team feels that it can be released into the market, and all the reports supporting that stableness of the software and releasing decision for making the software to be released into the market is created and prepared by the testing team and is ready. So that is nothing but the entry criteria. Then what are the different activities that are performed by the testing team during the test closure phase? Here, all the reports created by the testing team will be analyzed, okay, in detail analyzed, and based on this analysis, some summary reports will be created, okay, quality reports and summary reports will be created, where the testing team will provide all the details like how many pending defects are there and all those stuff, okay, which areas of the functionality are stable and etc etc. And on the top of that, testing team will provide a judgment whether the software can be released into the market or not, okay, whether software can be released into the market or not. The final judgment based on the pending defects and based on the stability of the all the different functionalities on the application, the software testing team will create a report here with their judgment. And when can the test closure phase will close? So this summary report will be shared to the client, guys, okay, during the disclosure phase. Once the software testing team has prepared this final report having the judgment of the quality and all of the software, that report will be shared to the client has to go through the report, and client has to decide whether to stop testing or not, okay. And also the client decides to release software into the market, and the client decides, because this is the ending point, the quality of the software looks kind of good, and the stable software is kind of stable when the client believes, after evaluating the report and checking the software, the client feels that this is the right time to stop testing and release software in the market. When this happens, that will become the exit criteria for the test closure phase. Then the testing will stop. So these are the different phases of STLC. The testing will start here with the requirement analysis and end with the test closure phase. Okay. So hope guys you got the answer for what is software testing life cycle in this session. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye.
Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 87. That is, what is requirement specification document? Let me answer. There is no single requirement specification document. Instead, we have to say there are several requirement specification documents. It's not document, guys, documents. So what are the different types of requirement specification documents we have? So you can see here we have the main requirement specification documents as BRS and SRS. Okay, these are the two major requirement specification documents that everyone talk about. Apart from this BRS and SRS, there are other types like FRS, CRS, PRS, and RPS. Okay, so these are the different requirement specification documents we have, and BRS and SRS are the mainly one that most of the people talk, and few people will talk about FRS, CRS, PRS, and RPS. Okay, so these are the different types of requirement specification documents we have, and here we need to understand clearly like what exactly is BRS and what exactly is SRS and what is the difference between BRS and SRS. Okay, this is very important. Let me focus on that. So coming to the BRS, guys, BRS stands for Business Requirement Specifications Document. Okay, BRS is a business requirement specification document, specifications document. It is generally created by business analyst. Okay, BRS document is created by business analyst. So, and it is derived from the client interaction. You see, the client side, some discussions will happen, like how the software
what are the requirements for the software and how the software should be created, and all discussions will happen at the client side. The client interaction will happen where the business analyst will involve in that client interactions. Okay, in the all the meetings done by the client to derive the requirements. In that meeting, the business analyst will attend that meeting and will be part of that meetings, and the business analyst will prepare this BRS document as a outcome of that kind of client interaction meetings where requirements are being discussed. Okay, so simple words, BRS document is created by business analyst, and this BRS document is an outcome of the client interactions where the requirements are actually discussed. And this BRS document outlines what software must do in business language. Okay, so it's simple words, it's nothing but a list of requirements. Okay, list of requirements that what software must do in business language will be documented in the BRS document by the business analyst. That's what is BRS document at a high level. Coming to what is SRS then. Okay, BRS is all about what software must do. Okay, what exactly software must do. Okay, the requirements of the software will be outlined here. But coming to SRS, it's not about what software must do, but it's all about the technical aspects of the software, that how software will be created. So what are the technicalities that we have to use. Okay, what are the technical things we have to follow for developing the software, for creating or building the software. That's what is SRS is all about. Okay, so requirements are all about BRS, whereas how the software has to be created in what way, okay, is all about SRS. So, SRS means system or software requirement specifications document, and it is created by system architect. It's not created by business analyst. SRS document is created by system architect who has good technical knowledge on how the softwares are generally created. And this SRS uses BRS as a reference. Okay, with the help of BRS only, because BRS clearly states that what the software must do. Okay, all the requirements of the software are mentioned in the BRS document. Based on the requirements only, the system architect will decide how the software need to be created. Okay, how the software need to, which technicalities we have to use for creating the software. Based on the requirements only, system architect will derive. Okay, so SRS is derived from the BRS document, and it outlines how the software will be created in technical aspects. Okay, which tools we are going to use, which architecture we are going to use. Okay, all those things will be mentioned or described in this SRS document by the system architect. It's all about technical aspects of the how the software will be created, whereas BRS is all about the business aspects of how what the software must do. Okay, what the software must do, and it's created by the business analyst. So hope guys you got an idea what exactly is BRS and what exactly is SRS. And as I already mentioned, there are different types of requirement specification documents apart from BRS and SRS, which are given very less importance and very less discussions happens everywhere in the project about these other types of requirement specification documents when compared to BRS and SRS. But let's see what exactly they are. FRS stands for functional requirement specifications. Okay, whereas CRS stands for compatibility requirement specifications and configuration. Okay, there is another CRS apart from compatibility requirement specification document. There is another type of document known as configurations requirement specifications. We also have performance requirement specifications, and we also have reliability requirement specifications document, and many other things may exist also. Okay, apart from the given list, there may be other type of requirement specification documents, but these are the general ones. So hope guys you understood what exactly are the requirement specification documents. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 88. That is, what are APIs? Let me answer. API stands for Application Programming Interface. Okay, A for application, P for programming, I for interface. It's an application programming interface. So to understand API, here I'm not going to give any definition. Okay, for API, because with the definition you will not understand what exactly is API. Okay, there are a lot of misleading definitions out there, but let's go into the reality. Okay, and try to understand what exactly is API, that is application programming interface, right? Why it is required. Okay, why developers have to develop these APIs. All these things let's learn in this session. Okay, so To understand what exactly the application programming interfaces are, we have to first understand that in an application, okay, whatever the application you take, the application has multiple layers. Okay, the application will have multiple layers. We can divide the application, a single application, into multiple layers. That is presentation layer, where you see the look and feel, UI layer of the application. Okay, user interface, where all the text box fields are there, buttons are there, hyperlinks are there. Okay, that is a UI layer. That is a presentation layer of the application. And every application will have a middle layer known as business layer. Okay, there will be another layer known as business layer. It is a middle layer. Okay, where all the application logic will be written. Okay, where all the complete application logic will be written. So how the application has to work, so programmers or developers have written the logic, okay, programs for building this business layer. Okay, so complete application logic will be written in the business layer. And finally we have the database layer, guys, which stores the data related to the application. So if I take you to any application, let's say if I take you to this one of the sample application, and if I take you to the let's say what you can say login page, let's assume that let me take you to the login page. So whatever that you are seeing on this page is the UI, right? It's a UI, user interface, graphical user interface. It's a presentation layer. So the colors and right, the options, okay, the hyperlinks, the buttons, the text fields. So it's all part of the presentation layer. That is a UI layer or graphical user interface layer. But what happens when you enter an email address here and password here and click on the login button? What generally happens? So here, when I click on login button, after giving the credentials, the application is allowing you to log in, right? Application, you are getting logged in. But how that is working? Is presentation layer doing all this stuff for you? No. Okay. In the background, there is a business layer, okay, where the logic has been written by the developers. Okay. That is known as business layer. Okay. How the login functionality is working for you when you give the proper credentials and click on the login button, how the login functionality is working. The program has already been written by the developers. So when a particular user gives valid credentials and click on the login button, allow him to log in. That logic is written in the business layer. Using the presentation layer, we are performing the actions, but ultimately the application code which is allowing the user to log in is written in the business layer. And finally, the data. Okay, how the application is able to judge that this is a valid username and valid password, because already the created account, the data related to the existing account is stored in the database. Okay, the business layer logic is checking with the database layer logic to see whether with this account credentials any user account is existing or not. It is checking. So all that such kind of data, okay, whatever, when you are creating an account or when you are adding an address, when you are trying to log in, right, this data is stored in the database. Okay, database like DB you can say, it stores all the database of the application. Hence, you can divide an application into multiple layers. That is presentation layer, which is just look and feel graphical user interface. But when you perform actions using the presentation layer, okay, the code that is written by the developers in the business layer will be running. Okay, to make that possible, the code that is written in the business layer will be running, and this code will be involved with the data, and all this data will be maintained by the database, that is database layer. Okay, these are the three layers of the application. But where do these APIs stand? Okay, where the APIs will be created, in which layer the APIs will be developed by the developers. Okay, for which layer the developers will be developing the APIs? Will they develop the APIs for presentation layer? No. Will they develop the APIs for database layer? No. But will they develop the APIs for business layer? Yes. Okay, developers build the APIs for business layer of the application. Okay, why? I'm going to answer. Okay, why the developers have to build or develop or create the APIs for the business layer? What are the different reasons why the developers have to build the APIs for the business layer of the application? Here are the reasons. Okay, with these reasons you will understand why APIs came into picture. Okay, this is how we have to understand APIs, guys. Just understanding the definition is not at all good, because a lot of definitions only talk about APIs in one point of view. Okay, so APIs are something like which communicate with different system, like that. Some kind of definitions are there in the market. I strictly don't recommend following such kind of definitions, because you have to ultimately understand what exactly are APIs, and which layer of the application they are created and why they are created. This understanding is more important than understanding or like memorizing a definition for API. Okay. So here, guys, the reasons for developing APIs. Okay, what are the different reasons for developing? Why developers have to build the APIs in this business layer of the application that I'm going to explain. These are several reasons, guys. So each and every reason is very important. So focus. Okay. So first of all, the functionality of a software to be utilized by other software. Okay. There comes a situation where one software want to use the functionality of another software. What can be the examples here? I'll show you the examples. I will give you the examples so that it will make your understanding more easy. You see, make my trip. Okay. Anyone use make my trip? Let me show you how the make my trip looks like. If I go to the makemytrip.com, okay, and if I search for, you see, from New Delhi is there to Bangkok is there. If I click on search button, what happens? This makemytrip.com will search all the flights of different companies. Okay, at this given details, right? According to the given details, what are the flights available? It will display. You see, Vistara flight is available. The Thai Airways is available. Okay, if you want to travel from New Delhi to Bangkok, Thailand, then we have Vistara, Thai Airways, Indigo, different flight. Sri Lankan Airways is there, Singapore Airlines, Qatar Airlines. A lot of airline company related flights are coming. But you see, Make My Trip is a different software, whereas Vistara is a different flight company, right? They are both are different companies. Make My Trip is one company, and Vistara flights is another company. Similarly, Indigo is another flight company. So if I search for Indigo, let's go for Indigo, guys. Okay, if I search for Indigo here, I'll get a lot of flights from Indigo. You see, Indigo has its own website, okay, to display the flights and all. Indigo company has its own website. Like you have to give the like same thing. Like for example, Delhi, he will say Delhi, and again the same location will give Bangkok, Thailand, and yeah. So what is the return date? Something 3rd April has been selected here. Let's say 29th. We'll select the return date, and yeah, search flights for now. I just want to see the flights, okay, on that particular date from Delhi to. You see, these are the flight details, okay. These are the flight details from Indigo, okay. Indigo has its own website and its own functionality is there, but still, Make My Trip is another website where not just Indigo related flight details will be displayed, but all the airlines, okay. All the different airlines related flight details will be displayed in a single place, a centralized place where you can find the flight details of different flight companies. So how the Make My Trip is able to display the flight details of this Vistara or Indigo or something? Indigo has its own, right? But still, Make My Trip is able to display the flight details of this Indigo company. How this is possible? Because what MakeMyTrip.com has done is it has taken the APIs of the Indigo. Okay, Indigo company has shared the APIs to the Make My Trip company, and Make My Trip software using the APIs of the Indigo is displaying the flight details of the Indigo here. Similarly, Make My Trip is using the APIs of the Vistara flight company to display the flight details of the Vistara. Similarly, Make My Trip software is using the APIs given by the Thai Airways to display the flight details here when people search on Make My Trip. Okay, everyone is there. You see, all the different flight companies are providing their APIs, okay, which will display the flight details to the Make My Trip software, so that Make My Trip can utilize the APIs of different flight companies and display all the flight details at a single place. Is how the APIs work. Okay, this is one of the reason why the software have to develop the developers have to develop the APIs for the software. You see, here the developers of Indigo or the developers of Vistara or Emirates or whatever it is, okay, developers of different flight companies are building the APIs so that other software can utilize these APIs and display the information like this here. Okay, that is one of the reason. Okay, functionality of the software to be used by other software. Here, functionality of Indigo is being used by Make My Trip. That's one of the example. This is the reason why developers build API. This is one of the reason why developers build APIs. Okay, so that other company websites, other softwares can use these APIs and build something on the top of that. You see, have you another example? I will give. Okay, more examples. Different contexts are there here. So here, Google authentication. Have you heard about the Google authentication? You see, different websites, okay, instead of building their own sign-in mechanism or registering account mechanism, what they are allowing is to make the sign-in authentication process more simple. What the different software companies, softwares are doing is they are allowing the users to log in with their Google authentication or Facebook authentication or Microsoft authentication, right? So that's what is being done. Okay. So there is a website, and the website, instead of okay, instead of ask, a website is giving multiple options to login, guys. Okay. So you can create a new account, or you can use your Google account to login, or you can use your Facebook account to login. You can use your Microsoft account to login. Like that's a lot of functionalities the different applications are giving, so that it will make the job of the users easy. Trying the people who want to sign up with the account, right? If they want to sign up with Google, you see, it will be very easy to sign in, right? So Google authentication. For example, Jira software is there. I'll show you how the Jira works. Let me take you to Jira. Just search for Jira in the Google, and you'll get this atlassian.com software Jira. Click on this link. You'll be taken to this web page and say get it free. Just click on this get it free option. So yes, click on next, and you'll be taken here. You'll be taken to this page. I'll say sign in with a different account, and I'll say add another account. You see, when I'm trying to sign up with add login with different account, you see this particular Jira website or Atlassian company Jira website is asking you to log in with Google. Google authentication is allowed. Microsoft authentication is allowed. Apple authentication is allowed. Slack authentication is allowed. These are the different platforms, right? So how this is possible? This website, Atlassian Jira website, is using the APIs of Google. Okay. Here, Atlassian website is using the APIs of Google. Atlassian website is using the APIs of Microsoft. Atlassian website is using the APIs of Apple. Atlassian website is using the APIs of Slack. Okay. So instead of building their own mechanism of getting the user login into the application, here this Atlassian website is using the APIs provided by Google, so that when they embed this APIs of the Google in this Atlassian website, people can also sign in with Google account. Okay, that's what is the benefit. You see here, APIs of Google authentication are used by Atlassian Jira. Okay, this is another reason. Okay, so if functionality of the software to be used by other software, for example, functionality of Indigo need to be used by MakeMyTrip, or functionality of Google authentication need to be used by Jira. In that case, these companies like Indigo or Google authentication softwares have to provide their APIs to the respective applications. Okay, this is one of the reason why APIs are required, why developers develop the APIs or create the APIs. Another reason why APIs are developed by the developers is reusing the application logic for creating different customized software. Okay, using the application logic for creating different customized software. I'll show you. So if you talk about Visual Studio, guys, okay, you'll understand this after I explain about Visual Studio, how the application logic is reused for creating or developing different customized software. So let's Google search for Visual Studio here. Let's Google search for Visual Studio here. Visual Studio. When I Google search, I'll get this link. I'll go to this website, and I'll go to the downloads, guys. After going to the downloads, you see here, let's say Visual Studio 2022 software is there, but this Visual Studio 2022 is not coming in a single version. Okay, you see when I click on this download Visual Studio, multiple options are coming. A community edition is there, professional edition is there, enterprise edition is there. Multiple editions are there. Okay, you can use the Visual Studio community, which is free, guys. Okay, people can download this Visual Studio 2022 for free. Okay, it's a community edition, but some features will be limited here. Okay, some advanced features will be limited in the community edition. People who don't want that advanced features, right, they can use a free version of this Visual Studio. And similarly, we have another version, that is professional edition, is also there, which is not free, guys. It's a trial free. After trial period is over, you have to pay the license amount. Okay, similarly, enterprise, even more advanced than professional, there is an enterprise. Okay, it will be more costly than professional. So here, most of the functionalities will be common. Okay, whatever the functionalities that are there in the community edition will also be there in professional, and whatever the functionalities that are there in community and professional also will be there in enterprise, and more and additional functionalities will be there. So here whether the developers of these three editions of the software, same software, have to write the code from scratch for each and every application. They have to write the code from scratch. So if the developers have developed this community edition having the basic features, again the same basic features have to be developed from scratch for professional edition? No. What the developers of this professional edition will do is they will use the APIs of the community edition to create the professional edition. Okay, simply they'll use the APIs of this community, and using the APIs, right, they will reuse the APIs. Okay, instead of building again from scratch, they will reuse the APIs, guys. Okay, so here reusing the application logic for creating different customized software. That's where APIs are required. Okay, they simply reuse the application logic for creating different customized software. So example I gave you, Visual Studio, which is having multiple editions. So instead of building the code programming logic from scratch for each and every edition, they are going to reuse the APIs of the previous edition, the basic edition, and try to build up some more customized software on the top of that. Okay, so this is where the developers have to. This is one another situation where developers have to build the APIs, okay, and reuse APIs for building other customized softwares. Now, reusing the application logic for different platforms. This is another situation where why developers have to build the APIs for a particular functionality of the software where let's assume that there is a web application. Okay, let's say there is a application and it's only in the format of web application is already developed. Now what happened is the requirement came where mobile application has to be created for the same web application. Okay, web application for that particular application type is already there, but mobile application is not there. So here, instead of the developers writing the code for mobile application from scratch, what they are going to do is they are going to create the APIs for this web application. Okay, they are going to build the APIs from using this web application code. They are going to build the APIs, and these APIs they are going to reuse in mobile application so that the development for mobile application will become faster. Okay, so this is another reason. So same application in web application format and mobile application format. Okay, so let's say there is a Facebook .com application, web application is there, but Facebook doesn't have the mobile application. Facebook mobile app is not there, let's assume. So what the developers of the Facebook mobile app will do is they will first build the APIs for the web application. Web application is already there, Facebook.com is already there. They will build the APIs using the logic created for the application logic created for the web application Facebook.com, and using the APIs, they will reuse the APIs for building the mobile application so that they just build the user interface of the mobile application, and in the background, they're going to use the same APIs that web application is using. So ultimately, mobile application development becomes faster, okay, because of the APIs. Reusing the APIs in the mobile application platform, mobile application development becomes faster. This is another reason. And other thing is client server communication. Okay, every application communicate over right, the client and server communication will be there for the web application generally. For example, if you take facebook.com, okay, if you take facebook.com, how the facebook.com communication will happen? You see, this will be your laptop, right? This is your laptop, let's say, and in your laptop you opened one browser, let's say Chrome browser or some browser you open. In the Chrome browser or whatever the browser you just browse facebook.com. What will happen immediately when you say facebook.com? Okay, a request will be sent to the server. This is your laptop, let's say this is my laptop. I am staying in India, Telangana, Hyderabad, my location. And here we have the server. Okay, this is a server where the actual application code of the Facebook, okay, a set of servers or server of Facebook. So Facebook server, this is Facebook server, but this Facebook server is somewhere else. Okay, maybe in Singapore or somewhere it is hosted. Okay, somewhere in the remote location the server is set of servers are there. So when I hit the facebook.com here, over the internet, a request will be sent to the server, right, which is at a remote place, and this server will have the application logic. All the application logic will be there in the application logic related to facebook.com will be there in this server machine, which is in which is running in Singapore. A request will be sent to this Singapore server machine, and this code will be running in the server, and as a response, okay, as a result, the response will come back to the client machine. Okay, as a response will come back to the client machine, that is a browser inside this laptop. It's nothing but the client here, and based on the response, so you will see the pages of the facebook.com. Okay, based on the activities you perform Facebook, a request will be sent to the server. Appropriate application logic will be running on the server machine, and a response will be coming back so that you will see the respective responses or results in this facebook.com UI page. So this is what happens. So here, whatever the request and whatever the responses we are getting, right, this is via APIs only. Okay, these are nothing but APIs, guys. Okay, without the APIs, okay, without these APIs. So here, what's happening is we are requesting and requesting via a this request and response are nothing but APIs, guys. Simple words. And a particular API endpoint will be hit here, and that logic will be running. Okay, API endpoint will hit here, and particular logic will be running, and you will get the response. So here also APIs are there. Okay, here also APIs are there, but these APIs are traveling over internet. Okay, what is the means of traveling for these APIs? Over the internet. So APIs which are which are communicating over the internet are known as web services, guys. Okay, what are web services? So type of APIs which communicate over internet are known as, if the communication of the APIs, that request and responses is happening over internet, that is web. Okay, the APIs are communicating over web, that is internet. That APIs are called as web services, guys. Okay, that such kind of APIs are called as, which type of APIs? Web services. Okay, web services. Fine. So you see, you need to understand one more thing. Okay, so here this is another reason why developers have to develop the APIs, because for client server communication to happen, for client server communication of a web application to happen, the developers have to develop the APIs. Okay, for that, and the communication will happen over the internet in case of client server communication, and you see, these APIs are generally known as web services type of APIs. There's one more important point you have to understand, that is, what is the difference between web services and APIs? This is very important, guys. Okay, so as I already mentioned here, these APIs are communicating over internet, that is over the web. That's why these APIs are known as web services. Okay, so all web services are APIs. So whatever the APIs that are happening over internet are nothing but web services. So all web services are APIs. Any web service you take, you can call them APIs. That web service is a type of APIs. Okay, web services are a type of APIs. But there is one problem there, that is all APIs are not web services. Okay, so it's not compulsory that this communication should happen over internet every time, right? Only the only the all the web services are APIs, because web services are APIs. Okay, the communicate a type of APIs which are communicating over internet. That's why all web services are APIs. But all APIs are not web services. Okay, it's not compulsory that APIs have to communicate over internet. If APIs communicate over internet, they are called as web services. But if there are kind of APIs types which doesn't communicate over internet, okay, it doesn't communicate over internet, so those APIs are not web services. Okay, the APIs which are not communicating over web or internet are not web services. That's why all APIs are not web services. All web services are APIs. Okay, so an example for the APIs which doesn't communicate over web or internet, which cannot be called as web services, okay, are, for example, Chrome add-ons. So you just go to your Chrome browser, guys. Okay, let's go to any Chrome browser, and this is a Chrome, right? This is a Chrome browser. Let me search for any add-on. Let's say Selectors Hub add-on. I'll go to Selectors Hub, one of the extension or add-on. Chrome browser add-on is there. Here you see I don't have Selectors Hub add-on installed here in this Chrome browser. So what I'm doing is I'm just clicking on this Chrome option, and I'm taken to the Chrome Web Store. So by default, my Chrome browser doesn't have the functionality related to Selectors Hub, right? By default, by default. My Chrome browser doesn't have the functionality related to selectors. So for example, if I go to any website and right click inspect here, I'll get the cool Chrome dev tools. Okay, the browser dev tools I'll get. So here elements is there, and I'll just drag this side. And here you see only the styles, computed layout, event listener, DOM breakpoints, properties, accessibility options are there. But here you see selector sub is not there by default. And in the Chrome dev tools, that is a browser dev tools, we don't have the selector sub option available here. But what I will do is I'll just go to selector sub and click on the Chrome, and then I will add it to Chrome. Okay, I'm extending the functionality of the Chrome browser with this. I'm adding this extra plugin. Okay, because the Chrome browser by default is not providing the functionality of selector sub. I'm adding the selector sub to the Chrome. I'm adding the selector sub to the Chrome. Just see what happens. So when it is it's adding, guys. It's taking some time. Let it add. You see once, yeah, it got added, guys. It got added, and you can pin it if you want to see it on the top. You can pin it. So you see now the Chrome browser has now the Chrome browser is extended with the functionality of the selector sub. So what I can do here is I'll just right click on this and select inspect option. Right click and inspect option, and this time you see there is an extra functionality coming here. Selector sub functionality is coming here. The selector sub functionality is communicating with, okay, is communicating with the browser. Okay, this in the Chrome browser earlier selector sub is not there in the Chrome dev tools, but now Chrome dev tools also include selector sub, which was not there by default. I have manually extended the function of the Chrome browser with the selector sub so that I can get the selector sub functionality in the browser dev tools here. So here, how the communication between the Chrome browser and the selector hub is happening? Is it happening over internet? No. Okay, they are natively communicating, right? It's not happening over the internet, guys. They are using the APIs, they are communicating internally. Okay, so here also requests and responses are happening between Chrome browser. Chrome browser is actually interacting with the selector sub. Okay, selector sub. But is this communication happening over internet? No, it's not happening over internet. It is internally happening in your local machine. Okay, in your local machine, that is in your laptop only. In your laptop only, it's there is no other machine somewhere in the remote like here. Okay, for example, Facebook you are accessing in the laptop, but the actual Facebook code is there in the Singapore, right? Server, in the Singapore server. But here in this case of selector sub, it got installed in the same Chrome browser, which is there in your local machine only. The communication doesn't require any internet. This requests and responses of the APIs will not actually travel over internet. They travel in your local machine only, in the same machine, the same browser only, they will travel. So here, since the APIs requests and response are not communicating over internet, they cannot be called as web services. That's why all APIs are not web services. You see, this APIs related to the Chrome browser and selector hub communication is not happening over internet. That's why all APIs are not web services. So you see, I'll give you one more example. Okay. So there are some softwares which coexist, guys. Okay. There are some softwares which coexist. I'll show you the image. Everyone know about the Microsoft Word, right? Microsoft Word. I'll show you this image. After that, you'll understand what's happening. You see, Microsoft software can coexist with other softwares. Okay. So in your laptop, okay, in your laptop, guys, in your laptop, you generally have the Word document, right? Word document. Okay. You generally have the Word document. If you open the Word document, guys, by default, you will not see this option like Workshare or some other third-party website software related options. You will not see. But here, Workshare kind of third-party software is getting integrated with your Word document. They are working together. So by default, the Word document doesn't have this Workshare. Okay, if you open the any Word document in your machine, it will not have the Workshare options. Okay, because Workshare is another software. So after I install Microsoft Office in my machine, then on the top of that, if I install this Workshare software, then what happens is again, if I open the Word document, earlier in the Word document, Workshare menu will not be there. But after I install Workshare software on the top of the Word document, I'll get this menu options here. Okay, extra functionality I'm getting here. So here, this Workshare software is communicating with the Word document via APIs. Okay, the APIs of the Microsoft Word document are communicating with the APIs of the Workshare. But here, does it require internet? Does Microsoft Word require the internet to communicate with the Workshare functionality here? No. They use APIs and communication will happen internally. The functionality of Word will be communicating with the functionality of the Workshare internally, not over the internet. So here, that's the reason all APIs are not web services. Okay. Here in this case, these APIs are not web services, right? Only the APIs which travel over internet are web services. But in this case, these APIs are not web service APIs because they're not traveling over internet. Okay. The communication is happening locally in your Word document, in your local machine without any need of the internet. The program is talking to program directly without any travel requirement of internet. Okay, that's why all APIs are not web services, guys, but all web services are APIs. Okay, web services are a type of APIs, but all APIs are not web services. Some APIs communicate without internet. Okay, those are not web services. So hope guys you got an idea what exactly are APIs now, right? So instead of going with a single definition, if you understand like this and different reasons why APIs are required, why developers have to build the APIs, and which layer of the application they build the APIs developers, all these things you have to understand, guys. Okay, this is what is a real knowledge about APIs. Okay, don't worry about the definition. If someone asks you about APIs, you have to explain like this. So they will understand that you have the real knowledge of APIs rather than going with the bookish definitions out there in the market. Okay. So that's all for this session, guys. See you in the next session where I'm going to answer another software testing interview question for you. Till then, bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 89. That is, what is API testing? Let me answer. So what is API testing? Testing the APIs, that is application programming interfaces. If you are testing the application programming interfaces to check whether these application programming interfaces are resulting in proper responses with the different possible inputs. Okay, we'll keep on altering the inputs while testing these APIs to see whether with this altered inputs, the APIs are giving the proper responses or not. Okay, this process is called as API testing. So to understand what exactly is API testing, you should have some basic knowledge of what exactly are APIs, right? So in the previous session of this training series, I already covered and explained what exactly are APIs in detail. In a very detailed manner, I explained what are APIs in the previous video. Okay, the previous software testing interview question training series, I already explained what exactly are APIs. With that knowledge, you will be able to understand what is API testing in this session. Okay, I'm not going to repeat what are APIs in this session. You just go and watch the previous video and come to this session, then you will understand API testing better. So testing the APIs to check whether they are resulting in proper responses with different possible inputs is nothing but API testing. So this statement, few people may not be able to understand. To make their understanding easy, I have come up with an example, guys. Okay, I'll practically show how to perform API testing before you. So here is an example. So I have website here. So this is a website, guys. You guys can use for practicing the API testing. Request.in is the website. Request.in is a website. If you scroll down here, there are a lot of APIs. You see, this website people are giving you a list of APIs that you can use for practicing the API testing. Okay, you can use any of this list of items. Okay, each and everything is an API here. Each and every API is having a request, and each and every API is having a response. Okay, so when you hit this request, you should get this response. Okay, so I'll show you practically how to test one of the APIs here. Out of all this given list of APIs, I'll show you how to test one of the APIs. So I'll go with this one, guys. Register successful. Okay, post one, post register successful. Let me select this one. When I select this one, guys, you see this is a request. Okay, when I select this one, the request has been changed. I'll right click on this and open a new tab. I'll get this URL, copy this URL, guys. This is a request URL. Okay, this is a request URL of the API. And when I hit this request URL, I should get this response. Okay, with these details, if I request this URL, then I have to get this response from the server. Okay, so I have to verify whether I'm getting a proper response when I hit this URL or not. I have to check request or not. I have to check how to test it. In order to test that, guys, I'll use one tool known as Postman tool. Okay, I'll search for Postman here. Postman Chrome extension. I'll say Postman Chrome extension here, and I'll click on this link. It will take you to this page, Chrome Web Store for Postman, and you'll get an option like Add to Chrome. Click on that Add to Chrome. So yeah, I selected Add to Chrome. Nothing is happening. Let me select it. Okay, Add an app option is coming. I just selected Add an app. Yes, in a while, you see the Postman has been installed. So I'll click on this Postman Chrome extension. I'll launch it like this. Let's wait for it to launch. So here I'm practically showing you, it's asking me to sign up. For now, I don't want to sign up, guys. I don't want to waste your time. I'll say, take me straight to the app. I'll create an account another time. Okay. So it has taken, it's asking you to download if required. Okay. For a better experience. It's not required compulsory for now. I'll just close all these dialogues. And here you see, this is a Postman, guys. Okay. This is a Postman tool. Here we have the get. I have to change it to post because here in this website, guys, if you have seen, we are testing this register successful, which is of post type, right? This is of post type. So here, select post and paste the URL here. Okay, paste the URL here. And along with this request, we have to send some information also. Okay, what is that information we have to send? We have to send this information, right? Copy this information. Copy this information and click on this and select this body. This body will be enabled only when it is post. You see, when I change it to get, you see body is not enabled. Again, if I select post, you see body is getting enabled. So for post requests only, we can enable the body. Okay, so that we can send some information. Select the body, guys, and by default, some other option is selected. Means select the raw option. Okay, so change this option to raw option. And here, after selecting the raw option here, so this particular data that you are passing along with the request is in JSON format. So select, change the text to JSON and then paste the text here. Now we have the request URL, and along with that, we have the data that we have to pass. Okay. Now, if you click on send with this email and password, if you click on send, it should give a proper response for us. Okay. Here they have mentioned the proper response. So click on the send. See what is the proper response? You see ID for token. Did we get the proper response? Yes, we got the proper response. So what if you see you have done a positive case so far? Okay, you have tested the API but in a positive manner. by providing the valid details and valid URL and post and all, you have verified it. Now I want to perform more testing on this API. Okay, for this particular API request, I want to perform more testing on this API. Okay, so what I will do here is I'll remove this guys. Okay, so here as we have discussed, right, as I explained, right, testing the APIs to check whether they are resulting in proper responses with different possible inputs. Okay, I have to alter the inputs here. Testing the APIs to check whether they are resulting in proper response with the different possible inputs. So here, let me remove the email and click on send button. Okay, you see what's happening. Earlier it has created, but this time it's saying missing email or username, it is saying. Okay, missing email or username, it is saying. So it's working fine still. Okay, if you don't provide username, if you don't provide email, it has to give this message, right? The API is working fine. So what else you can do? So again, say Control Z and go back and change it to get guys. Okay, get, and click on send. You see, when I say get, some other things are coming, all the registered users are coming. This not is a functionality, right? So this is how guys we can alter the inputs. Okay, while testing the API, we have to alter the inputs and see whether we are getting proper response or not. Okay, what will happen if you don't give the password? You have to test. Okay, different ways you have to modify the API and see whether we are getting the proper result or not. Okay, you see missing password is coming, it's working fine. Okay, when I am removing the email, it's saying missing email. When I am removing the password, it's saying missing password. If I remove both email and password, another test. Okay, by altering the inputs here, I'm performing another test on this API. Click on send. This time missing email or username, because by default email is missing, even though password is also not there, it's giving the same message. That's okay. What if you remove all this stuff, you don't give any parameters and click on send, the same message is coming. Okay, so like this guys, like this you can keep on altering the different varieties of inputs here and keep checking. Okay, you can give different email formats, okay, different password formats, and you can keep on testing that particular API and see whether by altering the different inputs, okay, by providing different inputs, by altering them and testing the APIs, whether we are getting proper responses or not. If you are getting proper responses, the tests on the API are passing. If you are getting improper responses, okay, if when you remove the email address and you click on send, if that response is not saying that email is missing, then in that case the API is not working as expected. Okay, that's how you have to perform testing. So this is one of the example for API testing, guys, and this is how the API testing is performed. And so hope guys you understood what exactly is API testing in this session. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 90. That is, what is web services testing? Let me answer. Before I explain what exactly is web services testing, we need to first understand what are web services. Web services are nothing but the type of APIs which communicate over internet. Okay, so there are different types of APIs. Not all APIs will communicate over internet, that is web. But web services are the type of APIs which communicate over web, that is internet. Okay, so you see in one of the previous sessions of this training series, I already explained what exactly are APIs in a detailed manner. And I also mentioned the difference between the APIs and web services. The thing here is all web services are APIs, but not all APIs are web services. Not all APIs will communicate over web or internet. Only some set of APIs, some type of APIs will communicate over web, that is internet. Those type of APIs which communicate over web or internet are known as web services. Testing such kind of web services, okay, testing such kind of web services is known as web services testing in simple words. So all APIs are not web services, as all APIs not communicate over internet. Okay, there will be some type of APIs which doesn't communicate over internet. Okay, there will be a type of APIs which communicate over web or internet. Such kind of APIs are known as web services. So how these web services communicate over internet? Okay, how these web services are the type of APIs which communicate over internet? Let me show you. So let's say there is a laptop. Okay, let's assume this is the laptop. Is laptop, and let's say this is my laptop. And in my laptop, I opened a browser, say Chrome browser. In the Chrome browser, I opened an application, say facebook.com. I opened. Fine. I just opened the facebook.com. I went to the login page or whatever it is. And in the login page, there will be some form, right? Generally, login page will have a form like email address, password, and login button will be there. Okay, there are some buttons and all. Now, what happened is here from my laptop, I went to the login page of Facebook. I entered the email address, I entered the password, then I clicked on the login button. The moment I click on the login button, a request will be sent to the server machine. Okay, the server machine of this Facebook is available at a remote location. Okay, so my laptop is in India and Telangana state and Hyderabad. Okay, from this laptop, a request is being sent to the a server machine. Okay, a server machine which is at a different location. Maybe this server may not be in India, it may be in Singapore, let's say. Okay, so the server machine of facebook.com is in Singapore, let's say. So this is a Facebook server. So this particular server machine which is hosting the code for the Facebook application is in Singapore. So how this request will travel to Singapore where the server is available? The only means to, okay, only means to travel possibility for this particular request is over the internet, guys. Okay, over internet. Over internet means what? HTTP protocol. Okay, HTTP or HTTPS protocol. Okay, so that is over the web, over the internet. That is via the HTTP protocol. A request will be sent to the server machine, and the application code will run. Okay, the Facebook application code will run when the appropriate API endpoint is hit in the server machine, and in return of this execution of the code, a response will be sent back to the laptop. Okay, and this response also will travel over internet only. Here, this is API request. Okay, API request is traveling to the Facebook server machine over internet from my laptop. Okay, when I try to log in with my credentials and all, and the response which is being sent back from the server machine to my laptop is also traveling over internet. This is API response. This is API response. This API request and API response are traveling over internet. That is web, right? Internet means web only, right? So that's why this type of APIs which communicate between the client and server or whatever it is on the internet are known as web services. The APIs which communicate over internet, which travel over internet or web are known as web services. But not all APIs communicate over internet. There are some other type of APIs which will be there in my laptop only. Okay, they don't have to travel to Singapore. In my laptop, there may be two different softwares. They can communicate with each other, and they don't use the internet as a communication channel. They may communicate with each other, guys. Such kind of APIs which are internally communicating with the resources of the laptop, okay, cannot be said as web services. Okay, they are normal APIs, but this is a special kind of API which travels over the internet, whose API request and response travel over the internet. Such kind of APIs are only known as web services, guys. Okay, testing such kind of web services. Okay, testing such kind of web services is known as web services testing. Testing such kind of web services which where APIs travel over internet to do the communication thing is known as web services testing. So hope guys you understood what exactly is web services testing in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 91. That is, what is the duration of the sprint? Let me answer. So if I have to answer this straightforward way, the duration of sprint is nothing but 1 week to 4 week. Okay, the duration of the sprint can be either 1 week or 2 week or 3 week, 4 week. So 1 to 4 weeks is the duration of any sprint. But let me explain this in a detailed manner. So as we already know, there are several SDLC models. Okay, so for developing the softwares into the market, there are several SDLC models followed by the projects. So what are they? We have waterfall model, prototype model, incremental iterative model, spiral, V model, agile model, RAD model, big bang model, where agile model is one of the SDLC models. So if you talk about this agile model, again, we have different frameworks or methodologies under the agile model. That is Scrum methodology, Kanban methodology or framework, Lean, extreme programming, Crystal FDD, DSDM, and so on. These are the several methodologies or frameworks in the agile. So in that several methodologies, if you talk about Scrum methodology, there is a concept known as sprints. Okay, the software development and testing will happen over the sprints in the Scrum methodology. To talk about Scrum methodology, the software will be developed and tested in the form of the sprints. So what are the sprints? So here is what are the sprints, guys. Okay, so what happens in the sprints is, sprint is nothing but an iteration, guys. Okay, in simple words, sprint is nothing but what? An iteration. This is an iteration. So the work will not happen at a go. Okay, the work will not be completed at a go. Rather, the work will be broken down into small parts and will be completed after every iteration. Okay, in the iteration work, iteration one, some portion of the work will be completed. After that, iteration two will start. Okay, so after that, iteration two will start, that is ITR2. Then after that, another iteration will start, that is iteration 3, then iteration 4, iteration 5, and it will keep on continuing, guys. Okay, so it will start with the first iteration, second iteration, third iteration, and the work will keep on going. So in every iteration, okay, in every iteration, some portion of the software will be developed. In the first, after first iteration, some portion of the software will be developed, and in the second iteration, more portion of the software will be covered. Okay, the software will be in an incremental fashion. Okay, iterative and incremental way the software will be developed and tested. Okay, so in every iteration the work is going on, and the work is increasing in an incremental fashion at the end of every iteration going ahead. So here each and every iteration is nothing but a sprint. It's nothing but a, here each and every iteration is a sprint. The Scrum methodology, if you talk about under Agile STLC model, if your project is following the Scrum methodology, we work on the software development testing in the form of multiple iterations. Okay, here each and every iteration is nothing but a sprint. Sprint 1, sprint 2, sprint 3, sprint 4, sprint 5. Okay, for every sprint we'll assign some set of stories. Okay, some set of stories at the beginning of the sprint, some set of stories, that is set of requirements, will be assigned to the sprint, and development team and testing team, that is Agile team, has to complete these stories by the end of the sprint. So this is what happens after the end of sprint. Another sprint will start, that is another iteration will start, where again another set of stories, that is another set of requirements, will be added to the sprint, and second sprint, and the development team and testing team have to complete by the end of the second sprint, and so on. This process continues. So here the sprint is nothing but an iteration, and this iteration will have some time, right? Duration will be there. So most of the projects, okay, so in the market, the sprint duration is around 1 to 4 weeks. Okay, so 1 to 4 weeks. So few projects may follow 1 week. Okay, they may end this sprint or iteration in 1 week. Some projects may end this iteration in 2 weeks. So each and every sprint will take 2 weeks. Okay, and some projects will take 3 weeks. Some projects will have the kind of concept where they will take 4 weeks for to end the sprint, and so on. Okay, so 1 to 4 weeks is the general duration of the sprint, but most of the projects will have their sprint ideal duration as 2 weeks. Okay, 2 weeks is the most popular one. So even though the range is 1 to 4 weeks, but the most popular one that is currently running in the market, a lot of projects are following, is 2 weeks. Okay, they work on the sprints. That is, they set the duration of the sprint, that is iteration duration of the iteration of the sprint, for just 2 weeks. That is 10 working days. Okay, after 10 working days, again they will start another iteration, and so on. But if you have to answer it properly, if you get this interview question that what is the duration of the sprint, you have to say that the duration of the sprint is 1 to 4 weeks. Okay, it can be 1 week, 2 week, 3 week, or 4 week. So most of the projects follow 2 weeks duration. Okay, so hope guys you got the answer for what is the duration of the sprint in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 92. That is, what is product backlog refinement? Let me answer. Product backlog refinement is nothing but refining the product backlog items. Okay, in simple words, what is product backlog refinement? Refining the product backlog items. Okay, making it more better kind of thing, right? Making it more clear, better, useful. That's what generally we call a refining word. If you Google search for refining word here, you will get the meaning. Refining means, so remove impurities, making it more pure, and any unwanted elements or anything are there in that, we have to remove that, and you see, we refine the oil and all those stuff. Okay, we use refined oil. Okay, we have any bad unwanted elements, impurities are there in the oil, right? That will be removed, and finally the oil will get sold in the market. So that is a refining process. So in case of, okay, in case of the product backlog, in product backlog which is maintained by the product owner, okay, who maintains the product backlog? Generally product owner will maintain that, right? So in that product backlog we have items. What are these items that are there in the product backlog? They are nothing but the user stories. So indirectly refining the product backlog items means, or product backlog refinement means refining the user stories. Okay, refining the user stories in simple words. So how the user stories are refined, okay, how they are made better, how they uh, how the impurities are removed from that user stories, kind of in that context. Okay, so this refining the product backlog items, that is user stories, is done by reviewing that. Okay, reviewing the user stories, then explaining, okay, explaining these user stories to others, so we can find, discussing about these user stories in the meetings, adding required details. If any details are missing in the user stories, any additional details are missing, the details need to be added. Or if any unwanted, okay, unwanted details are provided, or misleading details, or ambiguous, okay, confusing details are provided, that need to be corrected. So estimating, so how much time it will take for the agile team, that is development team, that is developers and testers, to finish up the work. Okay, that estimating. Then fixing things. If any problems are there in the story, like if anything is missing or anything need to be added, okay, anything need to be removed, anything need to be cleared off. Okay, so here the fixing will happen. Even the size of the story matters. Sometimes the size of story is very large. Okay, it will not fit into the sprint or whatever it is. In that case, the things can be fixed. Okay, it can be broken down into smaller parts and made it better. Then ordering the items. You see, there will be multiple user stories, but which one need to be developed and tested first, and which one need to be worked on later, okay, have to be decided. So that is ordering the items. So all these are the activities for resigning the user stories, that is resigning the product backlog items. And this is nothing but the product backlog refinement in simple words. Hope you got the idea what is product backlog refinement now. Just a refining process. So where we are going to refine the product backlog items, that is nothing but user stories, by doing all these kind of activities. Okay, reviewing it, explaining, discussing, adding required details, estimating, fixing things, and ordering the items. Okay, these are the few of the activities for doing the product backlog refinement. Fine. So let me explain more details about this. Now you understood what is product backlog refinement. Let me explain more details about this product backlog refinement thing that is followed by the Scrum methodology in Agile STLC model. Okay, so this is an ongoing process during the sprint, guys. Okay, while the sprints are going on, as you already know, in the Scrum methodology, we have a concept known as sprint, which is nothing but an iteration where the development and testing will happen in iterations, multiple iterations, where the sprint duration will be around 1 to 4 weeks. Okay, it can be 1 week, 2 week, 3 week, or 4 week. So during the sprint, during that iteration, while the sprint is going on, this product backlog refinement happens. It's an ongoing process, guys. It never stops. Okay, and this product backlog refinement meeting will be conducted, guys, once in a sprint, or once per week sometimes. Okay, if the sprint duration is 2 weeks, it can be done in 2 times. Okay, once per week. Or if the sprint duration is 1 week, it can be conducted once in a sprint, like that. Okay, depends. Sometimes it is conducted once in a sprint. If required, it can be spread across the sprint by dividing once per week, something like that. So if the sprint duration is 2 weeks, okay, if sprint duration is 2 weeks, that is 10 working days, in the 2 hours, okay, 2 hours will be the duration of this product backlog refinement meeting. And who will attend this meeting? Who will do this product backlog refinement? Ultimately the owner of this product backlog refinement will be the product owner, okay, because he is the one who is in charge of the product backlog items. And product owner along with the development team, that is in agile, development team is nothing but the combination of developers and testers. Okay, product owner and the development team work on this together. So they will involve in this meeting where they will do all these activities. Okay, as part of product backlog refinement, this product owner and the team, agile team, that is developers and testers, will go through all this. They will perform all these activities. Okay, they will spend 2 hours per a sprint, which is having a duration of 2 weeks. Okay, so if they have to do it at a one go in this 2 week sprint, they will do only one that is 2 hours continuously. They will sit and complete, or they may also make it flexible where if they want to do once per week, So every 1 week they will do 1 hour like that. Okay, so it depends. Yeah, approximately it will take 2 hours. Okay, and these are the two people who will be participating, two teams who will be participating. And what is the purpose? Why the product backlog refinement has to be done? Why all these activities has to be done? So the main reason for performing the product backlog refinement is to have a set of product backlog items, that is to have a set of user stories ready for the upcoming sprint. While the current sprint is going on, we are preparing for the next sprint. Okay, we are trying to add quality stories, okay, refined stories, instead of adding the stories as it is. Okay, instead of adding the stories with the improper information, confusions as it is for the next sprint. So this product backlog refinement meeting is conducted, okay, where the team will be sitting and they will be refining the user stories. Okay, they will have the discussions, explanations, reviewing all these activities will be performed with an intention of refining them, removing the unnecessary things, adding the necessary things, any missing things, all this stuff, and making them kind of refined and ready for working for the next sprint. Okay, so that they can be assigned for the next sprint, even ordering, prioritizing them in a proper way. Okay, all these things will be done during the current sprint, so that these refined backlog items, that is user stories, okay, but backlog items, that is user stories, will be which need to be assigned to the next sprint are ready, okay, in beforehand. That's what is a product backlog refinement. So hope guys you got the answer for what is product backlog refinement in this session. So that's all for this session. In the next session, I am going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I am going to answer software testing interview question 93. That is, what are different SDLC models? Let me answer. There are several SDLC models that projects will follow to deliver their products into the market. They are waterfall model, then we have prototyping model, then iterative incremental model, spiral model, V model, agile model, RAD model, and big bang model. These are the different SDLC models we have. So hope guys you got the answer for what are the different SDLC models. So that's all for this session. In the next session, I am going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 94. That is, what is the difference between Agile and Scrum? Let me answer. Agile is not equal to Scrum. Rather, Scrum falls under Agile. Okay. So what is the relation between the Agile and Scrum? Let me explain in a detailed manner in this session. Okay. Coming to Agile, Agile is one of the SDLC models. There are different SDLC models. Different projects follow different SDLC models for producing the software and delivering them into the market, where Agile is one of the SDLC models. As you can see, Agile is one of the SDLC models. So here are the different SDLC models we have, that is waterfall model, prototyping model, iterative incremental model, spiral model, V model, agile model, RAD model, big bang model. These are the different SDLC models that different projects use for producing the software and releasing into the market. Agile is one of them. Okay. So what is the relationship between this Agile and Scrum then? Coming to Scrum, Scrum is not an SDLC model. Rather, Scrum is a methodology or a framework which comes under Agile SDLC model. Okay. Out of all these SDLC models, Agile is one of the SDLC model under which there are several methodologies. As you can see here, Scrum is one of the methodologies, that is frameworks. Okay, is one of the frameworks under the Agile SDLC model. So there are several SDLC models like waterfall, prototyping, incremental, iterative, spiral, V model, Agile model, RAD model, Big Bang. But under Agile SDLC model, there are several methodologies like Scrum methodology, Kanban methodology, Lean methodology, Extreme Programming methodology, Bristol methodology, FDD methodology, DSDM methodology, and others. Okay, there are several methodologies or frameworks under Agile. So any project can use any of these methodologies. Okay, a project A can use Scrum methodology, while project B can use Kanban methodology. While Scrum is the famous one, guys. Okay, most popular one in the market, popular methodology of the Agile SDLC model in the market. Okay, so hence, guys, Agile is not equal to Scrum. Rather, Scrum is one of the methodology which is followed in the Agile SDLC model followed projects. Okay, so apart from the Scrum, we have other methodologies under Agile SDLC model. So hope guys you got the answer for what is the difference between Agile and Scrum. Okay. While Agile is an STLC model, Scrum is one of the methodology or framework under this Agile STLC model. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 95. That is, what is pesticide paradox? Let me answer. Pesticide paradox is one of the principles of software testing. In software testing, there are different principles. As you can see here, these are the different principles we have in software testing. There, testing shows the presence of bugs. This is the first principle. Then we have exhaustive testing is impossible, which is the second principle. Then early testing is the third principle. Testing is context dependent is fourth principle. Defect clustering is fifth principle. And sixth principle is pesticide paradox, okay, that I'm going to answer in this session. That is pesticide paradox is the sixth principle. And finally, we have the last principle of software testing, that is absence of error fallacy. Okay, this is the last principle. So pesticide paradox is one of the principles of software testing, but what exactly this principle says? Okay, what exactly this pesticide paradox principle says? So according to the pesticide paradox, if the same set of test cases are executed again and again over a period of time, this test, that is test case tests, won't be capable enough to identify the new defects in the software. Okay, let me explain you clearly what's happening. Let's say the developers have given you the version 1 of the software. Okay, developers have given you the version 1 of the software. Then you have started testing this version 1 using some test cases. Okay, so you have created some test cases. Using the test cases, you have verified the functionality. You just checked or tested the functionality of this particular version 1 of the software, and as a result you got some defects. Let's say you got some 15 defects here. Okay, you got some 15 defects, assume. Now the developers have to fix these defects, and they gave you another version of the software. Okay, so with the fixes, with the defects fixes that you have, that the testers have reported earlier, developers have fixed them and they added some new functionalities, updated the existing functionalities, again gave another version of the software for testing, and again you are using the same document. Okay, the same test cases document you are using, the same test cases document you are using here for testing this version 2 of the software. This time surprisingly you didn't get 15 defects, you got only 10 defects. Okay, the defect count was reduced a bit, let's assume. Now again the developers have fixed this defect, and they have given you another version of the software having the latest code changes, the defects fixes, code changes, any other stuff like updation of the code, whatever it is. Okay, and they gave you another version of the software. Again the software testers have used the same set of test cases to test this particular version 3 of the software. This time the software testing team only got 5 defects. Okay, with the help of this particular document they were able to identify only 5 defects. Okay, in the first version they were able to identify 15, then 10 defects, then 5 defects. And again the developers have fixed these defects and they did some code changes, and they gave you the another version of the software. Let's say this is an example, guys. Okay, ideally it may happen like this, but it in real time the numbers will be different. Okay, now again the testing team is using the same test cases, same set of test cases to test this particular version of the software. This time they only got some 2 defects. Okay, and again the process continued where the development team has given the version 5 of the software with the code changes and code fixes and defects fixes, etc. And again the testing team has used the same set of test cases for testing, and this time the testing team didn't find any defects. Okay, 0 defects. No matter how many versions came after this, version 5, version 6, version 7, the test cases were unable to identify the defects in the software, because the problem here is, this is what is pesticide paradox, guys. Okay, if the same test cases, okay, if the same set of test cases are repeatedly used for testing the different versions of the software over a period of time, okay, again if the testing team is using the same set of test cases for testing, so these test cases won't yield any new defects. Okay, the defects will be lost. You'll not be able to identify new defects. What's the problem? The problem is that there are no defects in the software. It's not about, still version 5 has more defects, but testing team is unable to find the defects with the help of the test cases. Okay, version 5 has some defects, but testing team is unable to identify the defects with the help of test cases, because the problem here is test cases are not updated. Okay, so if the test cases are not updated and the same set of test cases are being used for testing the different versions of the software over a period of time, over a period of time, this same set of test cases will not yield you the defects. Even though there are defects in the software, the test cases will not be able to identify the defects in the software. That is the problem. And this is called as pesticide paradox. The only solution for this, for avoiding this problem, pesticide paradox problem, is to resolve this problem, we need to continuously review and update the test cases. Okay, we should not be using the same set of test cases for each and every version. We have to update the test case. Here we have to update the test cases, add new test cases, modify the existing test cases, and we have to keep on improvising the test cases and adding more tests to this particular test cases. Okay, like the software version changes, the test case version also should change so that the defect identifying process will continue. Okay, so this is what is pesticide paradox problem, where if you are using the same set of test cases without updating them, but testing the different versions of the software over a period of time, the test cases will not yield you any new defects in the software. Okay, even though there are defects in the software, the test cases will not help you in identifying the problems in the software. To resolve the problem, we need to review and update the test cases continuously. Okay, so that the test case will be still able to identify the defects. So hope guys you understood what is pesticide paradox problem. So that's all for this session. In the next session, I am going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 96. That is, what are different agile methodologies? Let me answer. Before I show you the list of different agile methodologies, you have to understand that there are different SDLC models that different projects will adopt. So to produce the software and to release the software into the market, different projects follow different SDLC models. So what are these different SDLC models we have? We have waterfall model, prototyping SDLC model, iterative incremental model, spiral model, V model, agile model, RAD model, and Big Bang model, where agile is one of the SDLC models we have, right? So all these agile methodologies belong to this agile SDLC model. Okay, under this agile SDLC model, we have different agile methodologies. We can also call them as frameworks. Okay, agile frameworks. So what are the different agile methodologies or frameworks under this agile SDLC model? These are the list of the different methodologies or frameworks under the agile SDLC model. That is Scrum methodology we have, Kanban methodology, Lean methodology, extreme programming methodology, Crystal, FTD, DSDM, and many others are there. These are the things. If you mention them, that will be enough. Okay, you can mention this given list of agile methodologies, that will be more than enough, guys. Okay, Scrum, Kanban, Lean, extreme programming, Crystal, FTD, and DSDM are the different agile methodologies or agile frameworks. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 97. That is, what is defect clustering? Let me answer. Defect clustering is one of the principles of software testing. In software testing, there are different principles. What are they? Testing shows the presence of bugs is one of the principle. Then we have exhausting testing is impossible as a second principle. Then early testing, third principle. Testing is context dependent, fourth principle. Defect clustering, fifth one. Pesticide paradox, sixth one. And the last one, we have absence of error fallacy. These are the different principles in software testing. Defect clustering is one of the principles of software testing. So what exactly is this defect clustering? Let me explain. Defects won't be equally distributed across the application. Okay, the defects won't be equally distributed across the application. For example, assume that this particular box is a software. Okay, assume that this particular box is a software, and I'll divide this box into multiple portions. Like this, I'll divide this particular box into multiple portions. Let's say this is the entire application. This box is an entire application. I'm dividing this box, that is entire application, into multiple portions like this. Okay, so here each and every portion is a functionality of this application. Assume that. So in this entire box is an application, right? This entire box is nothing but application that you are testing. And in this entire box, each and every portion that I have divided now is a functionality. Functionality one, okay. Let's say this is login functionality, this is register account functionality, this is forgot password, this is logout, okay. This is search functionality, like that. So each and every divided box is a functionality of the application. in this case, guys, okay, in such case, so according to the defect clustering, the defects won't be equally distributed across the application. Okay, so if I am testing this entire application, so if I am getting 5 defects here, I'll not get same 5 defects here, right? If I am getting 5 defects in first functionality, I'll not get the same 5 defects in another, and again same. So defects will not be distributed equally. This is not possible. Okay, this is ideal case. Okay, very rarely this will happen, but generally it doesn't happen, right? Defects are distributed equally. Okay, so according to the defect clustering, the defects won't be equally distributed across the application. Rather, instead of this kind of thing happening, rather most of the defects that are found by the software testers in this particular application will be coming from very less number of functionalities. Okay, majority of the defects come from a small number of modules or functionalities. So maybe this functionality may giving one defect, this one will giving one defect, one defect, one defect. Okay, let's say you are getting some 2 defects from this functionality, some 2 defects from functionality, 2 defects, and here you are getting 3 defects. Let's say three. Okay, three, three, some 3 defects you are getting. Again, you are getting one defect from this, and 2 defects from this. I'm just creating an example, guys. Okay, just assume. So here 8 defects are coming from this. Here some 12 defects are coming from this functionality. Here 15 defects, and here something around 6 defects. Okay. So you see, if I'm testing this application, and if I'm getting the defects, okay, if I'm dividing this entire application into multiple blocks, and I'm giving the number of defects that are coming from each and every functionality of this application. In this case, you see, according to the defect clustering, the defects won't be equally distributed across the application. You see, here one I'm getting 8. They are not equally distributed, right? If they are equally distributed here, if I'm getting 5, it should be 5 here, right? But here, you see, here one of the functionality we are getting 1 defect, another functionality we are getting 8 defects. Defects are not equally distributed. That is one of the thing that defect cluster is mentioning. Okay, that is one of the software testing principle that is defect clustering, mentioning that defects won't be equally distributed across the application. Okay, defects will be like this. Okay, this is one of the example, and majority of the defects come from a small number of modules. So in this, if you see, guys, what are the few functionalities? Okay, small number of modules. What are the small number of modules from which most of the defects are coming? You see 8 defects. Okay, and here 12 defects, here 15, here 6. These are the small number of modules. Okay, out of all these modules, only in few modules we are getting major of the defects. Okay, majority of the defects are coming from this less number of modules. Okay, this is what is defect clustering. This is what happens in real time when you are really testing an application. The defects won't be equally distributed across application functionalities. Rather, you will get majority of the defects from the small number of functionalities or modules. Okay, that is what is defect clustering. So hope, guys, you got the answer for what is defect clustering from this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 98. That is, what are Scrum ceremonies? Let me answer. Before I explain what exactly are these Scrum ceremonies, we have to first understand the meaning of ceremonies. Ceremonies means meetings. So Scrum ceremonies means Scrum meetings. So what are these Scrum meetings or Scrum ceremonies? Let me explain. Different projects follow different SDLC models. Like some projects will follow waterfall SDLC model. Okay, for building the software and producing the software into the market. Some projects may follow waterfall model. Some projects may follow prototyping SDLC model. Some projects iterative incremental, spiral model, V model, agile model, RAD model, and Big Bang models. Okay, these are the different SDLC models followed by the projects for delivering the software into the market, for building and delivering the software into the market. So Agile is one of these SDLC models. Under Agile, we have different methodologies. We can also call these methodologies as frameworks. Okay, Agile has different methodologies or frameworks. That is Scrum methodology or framework, Kanban methodology, Lean methodology, Extreme Programming, Crystal FDD, DSDM, and other methodologies and frameworks are part of this Agile SDLC model. Okay, so in that, Scrum is the number one in the market. So under this Scrum methodology of Agile SDLC model, there are different ceremonies. Okay, ceremonies are nothing but meetings, right? So there are different meetings conducted in this during this Scrum methodology, Agile Scrum methodology projects. Okay. So what are these different ceremonies we have in this Agile Scrum methodology? We have different meetings like ceremonies like sprint planning meeting, daily Scrum meeting, sprint review meeting, and sprint retrospective meeting. Okay. I'll show you the diagram. So as you can see here, this is a Agile Scrum methodology diagram. As you can see, I can increase the size if you want. So this is Agile Scrum methodology, guys. As you can see here, there is a bar here in the bottom, right? The entire Agile Scrum methodology, guys. So in that, you see there are 4 meetings, okay? 4 ceremonies. What are these 4 ceremonies? One of them is sprint plannings meeting or ceremony. Then we have daily Scrum meeting or ceremony. Then we have sprint review meeting and sprint retrospective meeting. So when is a sprint planning meeting conducted in this Agile Scrum methodology? So you see, before the sprint starts, okay? Before the sprint starts, sprint is nothing but what? Sprint is nothing but an iteration having some duration like 1 to 4 weeks. In that 1 to 4 weeks of given time or duration, the Agile team, that is development team, that is developers and testers, have to complete their work. Okay, in that sprint, having a duration of 1 to 4 weeks, the development team, that is developers and testers, have to complete the assigned work, right? So before this particular sprint is started, what happens is the product owner who actually maintains this product backlog containing a list of user stories and all. Okay, so this product owner will conduct a meeting. Okay, will conduct a meeting known as sprint planning meeting. To this meeting, along with the product owner, who will attend? Development team, that is developers and testers. In Agile Scrum, right, we'll call development team, that is developers and testers, as development team. So there is no separate words like developers and testers. So the developers and testers will attend this sprint planning meeting along with the product owner. So in that meeting, the product owner will put the list of stories they have to, the development team or Agile team has to complete by the end of the sprint. Okay. So the product owner will put all the stories that the development team has to complete by the end of the sprint. Before the sprint starts, this meeting will happen. Sprint planning meeting will happen. So the development team has to evaluate, okay, whether or estimate whether this much amount of work assigned by the product owner to the sprint for the development team to complete by the end of the sprint is achievable or not. The development team has to think and has to discuss with the product owner, okay, has to negotiate with the product owner to see whether if the product owner is overburdening the development team, then development team has to mention that to the product owner saying that, okay, this is too much of work, we cannot do this much of work. Okay, uh, can you decrease the amount of work and can you reduce or something? Okay, so like that, some discussions will happen in the sprint planning meeting, and the product owner and development team has to agree with the estimates. Okay, the product owner will give some estimates according to the amount of work that need to be completed by the end of the sprint. Product owner will give estimates to the stories, and that estimates need to be accepted by the development team in the sprint planning meeting. So at the end of the sprint planning meeting, product owner and development team will get a clarity on how many stories are getting assigned. Okay, how much amount of work is being assigned to the sprint. Okay, so this sprint planning meeting happens before the sprint begins. So after the sprint planning meeting, according to the agreed things, okay, the product owner will move the list of user stories to the sprint backlog based on the decision taken in the sprint planning meeting. Okay, whatever the development team has agreed right to work, that amount of work will be assigned by the product owner to the sprint backlog. Fine, this is what happens in the sprint planning meeting. Now, let's say the sprint work started. The development and team and testing team started working on the stories that are assigned by the product owner to the sprint backlog. So these stories that are assigned to sprint backlog need to be completed by the end of the sprint, right? Development team, that is developers and testers, have to complete this user stories by the end of the sprint. So, but the problem here is there will be multiple people working on this, and right, the things may go wrong, right? The development team may not be able to complete the task by the end of the sprint. Okay, because maybe the teamwork will be missing, or some problem blockers will come during that work while they're working on a sprint. Some blockers will come, some problems will happen. Okay, development team and testing team has to focus only on the work, but because of some blockers or because of some problems in the teamwork, some people performing, some people not performing, or whatever it is, uh, due to some XYZ reasons, the work that is assigned to the sprint, properly estimated work that is assigned to the sprint, may not be completed by the end of the sprint. To avoid this problem, okay, to avoid this problem, The second type of meeting comes into picture known as daily scrum meeting. Okay, it's also called as daily stand-up meeting, daily scrum meeting or daily stand-up meeting. So this particular daily stand-up meeting will be conducted by another role in the agile scrum methodology, that is scrum master. Okay, there will be scrum master who will be conducting this daily scrum meeting, that too every day. Okay, while the particular sprint has started, every day of the sprint, for example, the duration of the sprint is 2 weeks, that is 10 working days. In each and every 10 working days, that is continuously 10 days, every day at same time, okay, the scrum master will conduct a meeting known as daily scrum meeting. All this development team, that is developers and testers, have to attend this daily scrum meeting. Okay, so it will not be for more time, guys. It will be just for 10 to 15 minutes. So, and all the team will be standing. That's why it's called as daily stand-up meeting. The scrum master will be presenting, okay, the list of stories that the team has to complete, and he'll be showcasing the burn-down chart if required. And the scrum master in this daily scrum meeting will check with the development team, individual development and testers. Okay, he will check to see where they are standing. Okay, how much amount of work they completed, what exactly they are working now. Is there any work pending? Is any work delaying? Okay, what they are going to do next, whether this team can complete the things on time. All this scrum master will inquire with the development team, and if the team is lagging, if team is not going well, okay, the scrum master will get to know all these things from the burn down chart. Okay, so where he'll identify that whether the team is on track or not, whether they can complete the things on time or not by the end of the sprint or not. He will come to know. If the things are not going well, scrum master will take the necessary actions. Okay, he will give the solutions, he will talk to the different people and make the things possible, and he will indirectly push the development team in completing the work on time. Okay, he will resolve the issues in the team, and he'll make sure that the work goes smooth and can be completed in time. Okay, that's what is a scrum master, and he will conduct the another agile scrum ceremony known as daily scrum, that is a daily stand up meeting or ceremony. Okay, so this is what is the importance of the daily scrum, okay, which happens daily during the sprint, every day during the sprint. Fine. Now the another agile scrum ceremony we have is a sprint review. Okay, sprint review meeting. So this meeting will be conducted at the end of the sprint phase. Okay, sprint review meeting generally happens at the end of the sprint, before the sprint ends, almost at the climax level or ending level of the sprint, guys. Okay, so the development team has to showcase, okay, whatever the work the development team has done, that is developers and testers have done in this agile scrum methodology, that particular user stories or work done by them, the developers and testers have to demo them, okay, to the stakeholders and product owner. Okay, the required stakeholders and product owners, the development team has to showcase their work. Okay, the demo their work. Once the product owner accepts the stories, okay, accept the work done by this development team, then only the sprint will be completed. Okay, here there's one checkpoint, right? It is a checkpoint, check post kind of thing, where the work will not be directly pushed by the development team, that is developers and testers cannot simply say that my work is completed. Okay, our work is complete, they cannot simply say that. They have to demo their work to the product owner, and product owner is the one who has to accept the work. Okay, he has to go through, he has to review the work done by the development team during the sprint, and he has to accept that. Then only the work will be treated as completed, definition of done, you can say. And to actually demo the work to the product owner and stakeholders, and for the product owner and stakeholders to accept the work, they will conduct a meeting. The product owner will conduct a meeting known as sprint review meeting, in which the product owner will review the work that is done by the development team, okay, from the starting of the sprint till the time of the ending of the sprint. Okay, so that is what is sprint review meeting. So let's say the sprint has completed successfully. The sprint has completed successfully. At the end of the sprint, before the next sprint starts, okay, after this sprint ends and another sprint will start. Okay, in agile scrum methodology, the work will happen in a iterative fashion, in an incremental model. Okay, so after first iteration, that is first sprint, second sprint will start. After second sprint, third sprint will start. Like multiple work will happen in multiple sprints. Each and every sprint will have a duration of 2 weeks. Okay, 1 to 4 weeks. If you take most of the projects follow 2 weeks, that is 10 working days. Okay, so at the end of the every sprint, there will be one more meeting conducted known as sprint retrospective meeting. Okay, Scrum Master will be conducting a meeting known as sprint retrospective meeting, where all the people in the team will attend this sprint retrospective meeting, where these guys will discuss. Okay, these people will discuss in the after the end of the sprint, before the next sprint starts. The sprint retrospective meeting will be conducted in between the sprints, and in this sprint retrospective meeting, the team will be discussing what went well in the completed sprint. Okay, just now completed sprint, what went well, what didn't went well in the sprint. Okay, and what are the improvements we have to make in the next sprint so that mistakes will not be repeated. Such kind of things will be discussed in a sprint retrospective meeting. Okay, they will discuss on what went well in the sprint, what didn't went till the completed sprint, and what are the improvements we have to make sure make or implement in the next sprint so that we'll get better results or will not face any problems. Okay, that is what happens in the sprint retrospective, which is the final Agile Scrum ceremony. Okay, so we have 4 Agile Scrum ceremonies, that is sprint planning meeting, daily Scrum meeting, sprint review meeting, and sprint retrospective meeting. So hope guys you understood what are Scrum ceremonies, that is Agile Scrum ceremonies now. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 99. That is, what is acceptance criteria? Let me answer. Acceptance criteria is nothing but a set of conditions which the application functionality should satisfy in order to be accepted by the product owner. This is what is acceptance criteria. In order to understand this statement regarding this acceptance criteria, you need to first understand the structure and example that I'm going to explain now. Okay. After I explain the structure and example regarding this acceptance criteria, you will be able to understand the statement regarding the acceptance criteria. Okay. So let me explain the structure first. So here you see there are multiple epics. Okay. There are multiple epics, epic 1, epic 2, epic 3, and so on. Okay. An application can have multiple epics. Who creates these epics? The product owner will create the epics. Okay. All these epics will be created by the product owner. But what exactly are these epics? These epics are nothing but the higher level requirements of the application. Okay. For whatever the application, the product owner is deriving the requirements, right? First, the product owner will derive the higher level requirements of the entire application in the form of epics. Okay. Here, each and every epic is a higher level requirement. This each and every higher level requirement, that is epic, can be broken down into smaller requirements. Okay, smaller chunks of requirements known as user stories. You see here epic 1 is broken further down into smaller requirements. Okay, this is higher level requirement epic, whereas higher level requirements will be broken down into smaller chunks of requirements known as user stories. Okay, in agile projects, okay, in whatever you are working in agile project, in that agile projects you will get the requirements in the form of stories. Okay, which are smaller chunks of requirements which are broken down from a higher level requirement known as epics. Okay, fine. So each and every epic will be down into smaller chunks of requirements, which are nothing but user stories. Okay, an epic may have one user story, an epic may have more than one user story. Okay, and so on. So that is what is epics, and this is what is user stories. Okay, user stories are the smaller chunks or requirements which are derived from the higher level requirements known as epics. All these epics and user stories will be created in the agile projects. Okay, by the product owner. Who will be creating these epics and user stories? The product owner will be creating. Fine. While the product owner creates this epics and user stories, for each and every user story, the product owner is going to write something known as acceptance criteria. Who is going to mention the acceptance criteria for each and every user story here? Each and every user story you see here, guys, has an acceptance criteria, right? You see the higher level requirement, that is epic, is broken down into user story, and for each and every user story there is an acceptance criteria. But who has written this acceptance criteria? Who has created this epic? Who has created this user stories for each and every epic? All these activities are done by the product owner. Okay, for each and every user story the product owner will mention the acceptance criteria. So what will be there in this acceptance criteria? As you can see here in this statement regarding the acceptance criteria, what is acceptance criteria? Is a set of conditions. So what will be there in this acceptance criteria? Set of conditions will be there. You see, each and every acceptance criteria of the user story will have a set of conditions. Condition 1, condition 2, condition 3, and so on. Okay. one or more conditions will be there in the acceptance criteria of the user stories. Okay, fine. So this is what is the structure, guys. Okay, this is what is the structure. Now you got an understanding about what exactly the acceptance criteria to some extent. Okay, so let me give you more better understanding. Okay, with the help of this example, I'll give you more better understanding for you. A realistic example I'm going to give this time. Once you have understood the structure, you will be able to understand this example. So let me open that example here. So there is an example epics, there's an example user stories, and there is an example acceptance criteria. You'll be able to understand everything clear now. As you can see, guys, okay, there is an Excel file here, user story related Excel file. Here you see the first, you see application. For an application, the product owner can create multiple higher level requirements known as epics. Okay, the higher level requirement is epic here, epic 001. For a new e-commerce website, for example, if you talk about this application, assume that this is application for which the product owner is creating the epics. Okay, so this is an e-commerce application. For this, if the product owner is creating an epic, he will create something like this. For a new e-commerce website to launch, the highest business value will be when a new user is able to register, login, search, and purchase an item from the website. Okay, so what will be the highest business value for the new user on a e-commerce application? The new user should be able to create an account. Okay, here, create an account, register an account here. After registering an account, the new user should be able to log into the account. Okay, after logging into the account, the new user should be able to search for the product. Okay, search for the product. And what will be the another thing? And purchase an item from the website. Okay, so this particular product, the user should be able to purchase it. Okay, add to the cart. All these activities will get added into the purchasing category. Okay, so like this, the user should be able to purchase the product. With all these activities will be involved in a single higher level requirement, that is nothing but epic. Okay, so this is what the epic is talking about. This higher level requirement, which is talking about registering an account, logging, searching, and purchasing an item from the website, can be broken down into smaller chunks of requirements known as user stories. You see, user story 1, user story 2, user story 3, 4. This single higher level requirement is broken down into smaller chunks of requirements known as user stories. Let's understand one by one user story here. First user story is all about, user story will be generally in this format, guys. Okay, as a something, I want to do something so that something should happen. Okay, as a something, as a some user, I want to do some action so that some result should come. As a something, I want to do something so that something should happen. As a something, I want to do something. This is how the product owner will create the user stories. Okay, who will be creating this epic? Product owner, not the software testers, guys. Okay, product owner will create this epic, and product owner will only create this user stories also. You see, for each and every user story mentioned here, there's an acceptance criteria. But who is writing this acceptance criteria? In fact, this entire document is created by product owner only. Okay, this entire Excel sheet having the details of the epics, user stories, and the acceptance criteria for each and every user story is created by whom? Is prepared by the product owner. Who has written this acceptance criteria? Product owner only. You see, what does acceptance criteria contain? Acceptance criteria contain a set of conditions which the application functionality should satisfy. Okay, so the application functionality should satisfy the set of conditions against this requirement of the user story, right? You see, ensure the first time visitor is able to navigate to the register account, fill his first name, last name, email, and this is what privacy policy. All the details about the user story are clearly mentioned. All the conditions that the application functionality should satisfy. User should be able to enter the details. User should be able to create the account. After creating the account, user should be able to log in. These are multiple conditions for this user stories. Okay, that should be achieved. For this requirement, okay, for confirming that this particular requirement has been properly developed and tested by the software testers. Okay, properly developed by the developers and tested by software testers. These are the set of conditions that should satisfy the application functionality should satisfy all these conditions to prove that the development team and testing team has properly developed and tested this particular requirement. That's what is acceptance criteria. Product owner is mentioning these conditions here so that tomorrow when the time comes, okay, when the time comes where the development team and testing team has completed this work of this user story, they have development team has developed this user story, and that is requirement of this user story, and testing team has properly tested this as mentioned in the requirement. Okay, then a time comes where this agile team has to demo the their work regarding the story to the product owner. Then on what basis the product owner will accept this user story as completed, the work has been completed. The product owner will check these conditions, okay, that the product owner has mentioned in the acceptance letter, whatever the conditions that the product owner has mentioned while creating this user stories as part of the acceptance criteria, right? All these conditions should be satisfied so that then only the product owner will accept the work that is done by the development team and testing team as part of this requirement, okay, as part of this work against this requirement. So now you'll be able to understand this, guys, okay. Now understand what is acceptance criteria. Now after I explain the structure and example here, this statement is pretty easy. Now you see what is acceptance criteria is nothing but a set of conditions, right? Acceptance criteria is what? A set of conditions. You see a lot of conditions are there written by the product owner. Set of conditions which who has to satisfy these conditions? The developed application functionality, okay, and tested application functionality should satisfy that, okay. Set of conditions with the application functionality should satisfy, okay. Here in this case, which application functionality should satisfy? Register account functionality should satisfy, okay. Set of conditions with the application functionality should satisfy in order to be accepted by whom? Who need to accept the work done by the development team and testing team for this user story as part of this acceptance criteria? Who need to accept the work? Product owner, in order to be accepted by the product owner. So hope guys you got the answer now for what is acceptance criteria. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 100. That is, what is sprint goal? Let me answer. Before understanding what is sprint goal, we need to understand that different projects follow different SDLC models for producing the software into the market. So there are different SDLC models that different projects follow, like waterfall SDLC model, prototyping model, V model, spiral, iterative, incremental, agile, rad, and big bang. These are the different SDLC models that different projects will follow to produce and release the software into the market. While agile is one of these SDLC models, right? Agile is one of the SDLC models that projects may follow to produce the software into the market. Under agile SDLC model, we have different methodologies. You can also call them as frameworks, okay? Different methodologies or frameworks are under this agile SDLC model. They are nothing but Scrum methodology, Kanban, Lean, Extreme Programming, Crystal, FDD, DSDM methodology, and there are other methodologies under agile SDLC model. So out of all these methodologies, there is a methodology known as Scrum methodology, okay? There is some methodology known as Scrum methodology, which is popular in the market. So under this Scrum methodology, the development and testing, that is the work, okay, for producing or building the software, the work that is done by the team, that is developers and testers, to build the software, right, will be done in the form of sprints. Okay, the work will be done in the form of sprint. Sprint means what? Iteration, having some time bound. Okay, sprint is nothing but an iteration having some time bound. Like every sprint will have an iteration duration of 1 to 4 weeks. Okay, some projects will follow 1 week duration for the sprint in the Scrum methodology. If a particular project is following Agile Scrum methodology, then in that the work will be done in the form of iterations. Okay, complete work will not be done at a go. Rather, the entire work will be broken down into smaller parts and will be completed one by one. Okay, completed iteration by iteration. This iteration in this Agile Scrum methodology is known as sprint, and this sprint, that is iteration, has some duration, guys. Okay, different projects will follow different durations for this sprint as part of the Agile Scrum methodology. So some projects will follow 1 week, some projects will follow 2 weeks duration, some projects will follow 3 weeks duration, some projects will follow 4 weeks. Okay, the general duration is from 1 to 4 weeks, guys. Okay, most of the projects follow 2 weeks duration. 2 weeks means 10 working days. Okay, 10 working days, excluding the weekends, it will be 10 working days. So the sprint has to be completed. The work has to be completed by the development team and testing team in this Agile Scrum methodology projects, okay, followed projects in that 2 weeks, okay. The 10 working days, the development team and testing team has to complete the assigned work for that particular sprint. Not the entire work will be assigned to the sprint, only some portion of the work will be assigned to the sprint that can be completed by the team in the 10 working days. It will be estimated and assigned to the sprint. Okay, so for that means in Agile Scrum methodology, the work will be done in multiple sprints, right? After first sprint is completed, some portion of work will be done and next sprint will start. where other set of requirements will be developed and tested by the agile team. Okay. Again, after the sprint, again another sprint will start. The work will keep on going in multiple iterations, multiple sprints. Okay, till all the things are completed. So those are the sprints. So for every sprint, guys, okay, for every sprint, a sprint goal will be set. Okay. So for every sprint, a sprint goal will be set. So here the question is, what is sprint goal? To understand the sprint goal, you should understand what are the SDLC models we have under the SDLC model, that is Agile SDLC model. What are the different methodologies we have under that Scrum methodology? What is meant by sprint? You have to understand. Otherwise, you will not understand what is sprint goal. Okay. So for every sprint in this Agile Scrum methodology followed projects, for every sprint, a sprint goal will be set. A goal will be set. Okay. Something the team has to achieve by the end of the sprint. Okay, that is nothing but the sprint goal, the objective that the development team and testing team has to achieve by the end of the sprint. That is called a sprint goal. Let me explain more about this sprint goal. So it is a sprint goal is nothing but a high level objective. Okay, high level objective or goal that describes the key outcome of each sprint. Okay, for every sprint. Okay, for every sprint in this Agile Scrum methodology followed projects, a goal will be set that is called as sprint goal, which will describe the key outcome of each sprint. What will be the outcome of that sprint is nothing but a sprint goal. Okay, it's a high level objective. Okay, that describes the key outcome of each sprint. For every sprint, a separate sprint goal will be there, and that describes the key outcome of each sprint. So where this sprint goal will be created and who will be creating it? Sprint goal is created in the meeting known as sprint planning meeting. Okay, in Agile Scrum projects, a sprint planning meeting will be conducted. Okay, in that sprint planning meeting, the sprint goal will be created. Who will create that? Product owner will create. Okay, created in the sprint planning meeting by the product owner by collaborating with the development team. Okay, he will not individually create it with the help of, okay, by collaborating. The main person will be product owner with his guidance and with his collaboration with the development team. Okay, the product owner is going to create sprint goal in this meeting known as sprint planning meeting. Okay, this sprint planning meeting is generally conducted before the sprint starts. Okay, sprint planning meeting is generally conducted in Agile Scrum methodology followed projects. Before every sprint, it will be conducted, guys. And in this sprint planning meeting, the product owner and the development team, that development team here in the Agile Scrum methodology means development and testing team together. Okay, they are called as development team. So product owner and the uh, development and testing team, that is development team, Agile development team, okay, will collaborate together, and the product owner with the discussion and collaboration will create a sprint goal. Okay, in the sprint planning meeting. So what is the purpose of creating the sprint goal in the sprint planning meeting by the product owner with the collaboration with the development team? What is the purpose? Why the sprint goal has to be created? Because with the help of the sprint goal, the team, okay, the team that is working on this project understands the purpose and impact of the work they are doing in every sprint. Okay, there should be some objective, right? For example, if you are studying for some exams, there should be some objective, right? Okay, you should be good at some subject. Okay, why you are taking exam? You want to be good at some subject, or you should be good at some topic of the subject. Okay, that will be your goal, right? So if without the goal, you'll not be able to achieve the things, right? So here also, sprint goal, which is assigned to every sprint, helps the team understand the purpose. Okay, why they are working in that particular sprint. The team who are working in the sprint should understand. The sprint goal gives that set of purpose for the team, and it will impact the work they are doing in every sprint. Okay, it will motivate them to achieve that goal by the end of the sprint. Okay, so it guides the development team. Development team in Agile is nothing but developers and testing team. Okay, guides the entire team of Agile on why it is building the current iteration, why exactly they are working. Okay, a lot of requirements are given for a particular sprint, and why they are working with the requirements. What is the end goal? What they want to achieve? What is the business value they want to incorporate into the application they are building? That they have to understand. That is mentioned as a high level objective as part of the every sprint. A sprint goal will be set, which is a high level objective that describes in current iteration what is the business goal or objective that the team is going to achieve by working. Okay, that set of purpose is nothing but a sprint goal, guys. Okay, that is what is sprint goal. So, and while setting this sprint goal, who is going to create the sprint goal? Product owner, right? With a collaboration with the development team, that is developers and tester. Product owner is going to create the sprint goal in the sprint planning meeting, and while creating, the product owner and this team will make sure that the sprint goal that is created is adhering to the SMART. Okay, SMART means each and every letter you have to understand. The sprint goal should be specific. Okay, a specific goal should be there. It should not be non-specific. Okay, what goal you are going to achieve should be specific. Okay, it should be measurable. You should be able to measure that. Okay, and attainable, achievable. Okay, by the end of the sprint, this particular goal should be achievable. Relevant. It should be relevant to the context. Okay, it should not be irrelevant. Time bound. It should be completed in the time. Sprint itself means time bound. So it should be time bound. Okay, so sprint goal should satisfy all these measures, that is specific, measurable, attainable, relevant, time bound. And product owner will make sure that every sprint goal is specific, measurable, attainable, relevant, and time bound while creating in the sprint planning meeting with the collaboration with the development team, that is developers and testers. And you already understood the purpose why we have to create sprint goal. It will guide the team on why it is building the current iteration, and the team has to work with a set of purpose, and they have to know that okay, by doing this work, we are going to impact the work like this. Okay, this is what we are going to achieve by the end of the sprint. They should know. That is the reason sprint goal should be created. So hope guys you understood what is sprint goal in this session. So that's all for this session. Thank you. Bye.